Welcome to not just a course but an experience that is set to transform your understanding of Spring security. Now, this course is not about passively watching videos, but it's all about engaging, learning, and becoming a Java developer that's capable of building real-world applications that are secure. Now, this is because in this course, we learn everything in a very hands-on way. And we build a project which is called Secure Notes application. Okay, and it's a application which is about managing and storing your notes in a secure way. Now, there are several benefits of learning Spring security this way. You will not just learn about the security concepts, but you will actually learn how you can apply these security concepts into real world applications and real world projects. Now, since in this course or with this project, we'll be making use of React for frontend and Spring Boot for backend. So you will actually get exposure to full stack development. You will also understand how security works in a full stack context. So you'll understand how things work when you have a React frontend and a backend that is built out in Spring Boot. You will know how things like JWT token, OAuth, and CSRF protection work when you have a React frontend in place and you have a Spring Boot backend. Now, this knowledge is really important to be able to build secure, robust, and scalable web applications. Now, who am I? I am Faisal with over 13 years of experience in building startups and global products. My expertise and passion for technology has empowered thousands of developers out there to excel in their careers. Now, here are a number of benefits that sets this course apart. Number one benefit is true instructor support. Now, this is a course where I as an instructor is fully committed to your learning. I've quit my job and I'm a full-time instructor now. Yes, you heard that right. And I did this because I believe I should be 100% invested so that I can support your growth and success. The second benefit over here is there are no teaching assistants. Now, with this course, I personally respond to all the questions and queries that you post in the Q&A forum. Unlike other courses where you are just left out with your Q&As there, I personally take charge over here to answer each and everything and each and every doubt that you have. Depth and breadth. So I just don't talk about security concepts. I actually show you how it's done. We actually build stuff. So that's something distinguishes this thing from everything else out there in the market. Real world project. Yes. So like I said, we are building a full-fledged application which will have a lot of security features. All right. And we'll be doing this with a front end. So you'll understand how things work when you have a front end and a back end in place. Up-to-date content, so goes without saying, I'm 100% committed to provide regular updates. Like you know, Spring security has undergone a lot of changes in past few years. All right, and I, as an instructor, I'm 100% committed to provide all the updates that are happening. So you have a course that is fully updated and you have lifetime access to it. Now, who is this course for? So this course is for learners of all levels. So if you're a beginner, don't worry. I'm 100% committed to help you succeed. And all the concepts that are taught in this course are super beginner friendly. But I won't take much of your time. I would just want to mention that do watch this till the end. Okay, do complete the course because it's going to be really beneficial. And if you like, do hit the like button and do subscribe to my channel. That would motivate me a lot and it impacts my ability to bring in more such free content on this platform for you all. Also, if you have any specific requests or any sort of videos you want to bring in, do comment and let me know. Also in the comment section, let me know who you are, where you are joining in from, and yeah, what sort of videos you would want to see from me in future. So yeah, without further ado, let's jump right in. All right, so let me give you a demo of what we are going to build. All right, so here you can see this website over here. This is the Secure Notes application. Okay, and it's about it's essentially a note-taking application that is built in a secure way, and we have made sure that we implement the Spring security concepts over here. All right. So this is a landing page, if you see, okay, a landing page with a lot of components here onto the landing page. Here you have two buttons, sign in and sign up. And at the top right, you have buttons like contact, about, and sign up. All right. So if you say sign up over here, okay, you are being taken to a page wherein you are being asked to register or create an account. And of course, make a note that you can even create an account using Google and GitHub. Okay. If you come back to the home page, you can even head over to the sign in page from where you can log in. Okay. So let me log in and let me show you. So I'll log in as admin over here. Okay. These are my admin credentials. I'll say login. Now, the moment I log in, I'm being taken to the home page of the application. Okay. So this is a dashboard where I can see all my nodes that I have created. I can even log out by clicking on the top right over here. You can see I'm logged out. You can even sign up. Now, let me also show you the reset password functionality. So you will see over here this button. So if you don't remember your username and password, if you don't remember your password and if you wish to reset it, you can head over to forgot password over here and you can enter the email. Okay, so let's say I will enter this email. This is a dummy email that I have for demonstration purpose. I'll say send. Now what will happen is a forgot password email will be triggered to this particular email that I have entered. Okay, this is the email address that is associated with my account. And I can head over to my mailbox and check the email that I would have received. Now here in my mailbox, you can see the password request, password reset email that I have received. All right. Now over here, I have not used a lot of copy or design over here, but you can do that if you wish to. Okay, but you can see it's a very simple email. And here you can see this is the link. And if you observe the link here, I am adding a token in the end. So this part is token, you can see. So this is the URL, localhost 3000. So this will be replaced by any domain where you host your application, reset password, and then you have token over here. Okay. Now this token is important from the security standpoint. This token has an expiry date. So this token expires. Okay. It's not like this token will be valid forever. Okay. And if you click on this, okay, you will be asked to enter a new password over here. Okay. You can see this URL. Okay. And after a while, this link would reset or it won't be valid over here. Okay. After the expiry ends over here. Okay. And yeah, this is only usable once. So once you update the password, okay, this URL or this token is marked as used. Okay. So this password reset related things, okay, these things that you are supposed to keep in mind, all of this we will be implementing using Spring Security. So how can you have URLs that you can make use of, to allow users to reset the password? Okay, you can see there is a very unique token that is being embedded in the URL. Okay, and this token is unique to this user. Okay, so if any other user or if I do a password reset request again, I'll get a new token, something like that. All right. So this is about a password reset. All right. Now what I will do is I will log in over here and I'll show you some features. Okay. So here you can see this is a note taking application. So you can see these are all my notes. Okay. And I can go over here, click over here. You can see this create note tab. I can go over here and I can create a new note. So I can type in my new note over here. Okay. Also keep in mind that this part of the application is like it supports a lot of formatting options. So you can see over here, you can bold a text over here. You can see it will appear in bold. You can make it italic, right? You can even have underline over here. You can underline it. Strike through is also there. Okay. So there are lots of formatting options that you can add over here to your notes. Okay. If you wish to. So we are making use of this editor that I'm going to talk about, and you can also like remove the formatting from here. You can see the formatting can be removed. All right. So I'll just keep bold over here. Okay. You can even change the heading style to heading 2 or something like that if you wish to. Okay. But I can create a node like this. Okay. And the node would be created. You can see my new node over here. This is the one. Okay. And it's created today. And you can view it if you wish to. So this is a view page and you can see the audit logs over here. Now audit logs tell you like what has happened with the node. So if I edit the node again, you will see all of this in the logs. Okay, so let me edit this over here. I can say 1. I'll update it. You can see this user has updated. So there is an update that happened on this node. This user updated the node, and this is a timestamp as to when he updated the node. Okay, so we are recording every event that happens with a node. So if there is a shared node in the system, and if anyone updates the nodes or anything, you can keep a track or a log of what has happened with that node. All right. So that's how this functionality helps. You can even delete the node if you wish to. I can click on delete, and this will delete the node. All right. So yeah, that's about node over here. The create node, you saw this editor as well. You have contact page, about page. These are all static pages. Then you have the profile section over here, where you can update all the details that you wish to related to your profile. We'll come to this shortly. Okay. But I also want to talk about the admin area over here. Okay. So what is the admin area? Admin area is a tab or a section in our application which is only accessible by admins and not by anyone else. Now, what does this mean? So it means that users with only specific set of privileges or roles can access this particular area. All right. So I am logged in using admin credentials over here, right? And you can see I'm able to access this. Now, let me open another instance of the browser over here. Okay. So this is Firefox open. Okay. And let me sign in with a separate user. Okay. So I'll say user 1. Okay. And I have a password for this user as well. Okay. Let me log in. Now over here, you will see I'm not seeing admin tab over here. Why? Because this user is not an admin. So he is not seeing admin tab. Okay. But when I logged in from my admin credentials, I'm seeing the admin tab and I can access it. Okay. Now, if for some reason, okay, I'll copy this URL, and let's say if this user who is not an admin, he gets to know that, hey, there is something on this URL which is only accessible to admin. Let me access it. If he tries to access it, okay, he's going to see this page which is access denied. Okay. So this is authorization in place that is there in our application, where we are keeping a track as to who has access to specific pages and who does not. And if a person does not have access to a specific set of pages, we take them to access denied so that they cannot access it. So this is a security feature that we have implemented, and I'm going to show you how you can build this. Okay. So yeah, this is about authorization part. Okay. Now I would also want to talk about the OAuth part. Okay. So we'll come to admin, this admin section a little after a while, and the profile section as well. I want to talk about OAuth. So here you can see login by Google, login with GitHub. So you can log in and create accounts using these two methods as well. Okay. So let's say if I want to log in, I will click on this button and I'll log in. And on the sign up page also, if you click on sign up, you have these two options again. Okay. So if I say login over here, I'm being taken to this page, right, where I'm being asked to select the account using which I want to log in. So since I selected Google, I have this option over here. Okay. You'll also see that we have this application here as well. Okay. So this is the application that we'll be creating on the Google console. I'm going to show you step by step how you can do that. Okay. We are seeing the name of the application. And if you select this, okay, normally you would see, okay, so I'm being prompted for a Google Authenticator code over here because I have two-step verification enabled. So I'll quickly enter this code over here. Okay. So 1 second. So it's this. All right. So I entered the code. I'm into the application. I will be asked for a authorization page over here from Google. Okay. And this is going to ask you for 3 permissions. Okay. You can see your personal info that is public, and your email. So all of this, how you can fetch all of this from Google, I'm going to show you. Okay. And you can say continue over here. All right. And you can see over here, we are into the application now. So we logged in using Google. Okay. You can even log in using GitHub. All right. So if I log out, you can come over here. You'll see the login with GitHub account. Login with GitHub option over here. Okay. Now how this functions is what happens is if you authorize Google, and if we
if our application gets the details from Google, then the application checks if the user exists with those credentials, like that username, that email. If the user exists, then the application will log you in. If the user does not exist, then the user will be created and the application will log you in. That is how it works. All right. So that's about how OAuth works. You can log in using GitHub as well over here. All right. But now what I will do is I'll just log in using admin. Okay. And we'll head over to profile now. We'll talk about profile first and then we'll talk about admin. All right. Now, profile section is a section where you manage your profile details. Okay. So you can see over here, I'm admin. Okay. My role is this. I can update my credentials from here. I can update my username, email, my password from here. All right. I also have an option to mark my account as expired, locked, or enable my account. Okay. So my account is enabled right now. And my credentials expire with time. So this is when my credentials are expiring. All right. You can even mark your credentials as expired immediately. You can, here you can see your last login session. So this gives you an indicator of when you had logged in last. Okay. So if there is a security breach or something, or if someone else gains access to your account without your knowledge, you will get to know from here. All right. So this is all general details that we are displaying over here. You can update your credentials as well. All right. Now over here, you have something called as multi-factor authentication. All right. Now, if you see this is disabled right now. You can see deactivated. Okay. So using multi-factor authentication, you can add additional layer of security to your account. Okay. Wherein first your account would be validated with one way using your credentials. And then you will be prompted to add a Google Authenticator code over here. Okay, so that is what we have done over here as well. So let me show this to you. Okay, so I'll say enable two-factor authentication over here. But before doing this, I'll talk about Google Authenticator app over here. Okay, Google Authenticator app. All right. So if you Google Authenticator app, you'll see this app appear on iPhone as well as iStore, as well as on Google Play. Okay, so whichever device you are using, just download this app. All right. If you come over here, you're going to see, I'll just explain things using the screenshots. Okay. What this application does is it gives you a secure code or unique code that you can use it for sign in. Okay. And this is for two-step verification. Okay. And you can see this is the interface over here. Okay. So here you can see for this particular account, this is the code and it expires in like few seconds, I would say. Okay, and then a new code is generated. So it's a very secure way of adding additional layer of security to your account, and it is being maintained by Google as well. Okay, you can see over here it's from Google. Okay, and by clicking on this plus icon, you can add or you can scan QR codes or you can add an account over here during the setup. And how you can do that, I'll show that to you. Okay, so if you come over here, you can click on enable two-factor authentication. Okay, now the moment you do this, you will get a QR code to scan. Okay. Now what you have to do over here is you have to go to your Google Authenticator app. Okay. And you have to click on this plus. Now when you click on this plus, you will be asked to scan the QR code. So you need to select that option and you need to come over here and you need to scan the QR code. So as I'm saying this, I have scanned the QR code. Okay. I'm not able to record my phone over here, mobile phone. The reason is this application does not allow screen recording because it's a secure app from Google and it's just not allowed. I tried recording it, but the output was only a blank screen. Okay, because I'm also using this application for a lot of my personal stuff like my bank accounts, my personal emails and all of that. Okay, so I thought I'll blur out and cut out some information and I'll show how you can use it, but I was just not able to record it. Okay, because of the security measures implemented by Google. Okay, but I'm showing you screenshots and I've scanned the QR code and I got this sort of a code over here on my homepage within the application. So I'll enter the code over here. So the code over here is 046 and I'll say verify. Now the moment I say verify over here, you can see two-factor authentication is enabled or activated. All right. Now let me demonstrate how this works and how this thing adds additional layer of security to your application. So if I log out now, okay, I'll enter my password, credentials, I entered that. Okay. Now this username and password is one layer of security. Okay. This username and password is one layer of security, and the authentication code from Google Authenticator app is the second layer of security. That is what I have configured, right? So if I say login, I will be asked for my verification code over here. Now, what is my verification code? I have to open the Google Authenticator app. So this app on my phone. So you can also open it on your iPhone. There is an app for that as well. Okay. And you'll see a code appear against your account details. So I'll enter. My code is 775407. Okay. So I'll say 775407 and I'll say verify, and then I'm logged in. Okay. But let me tell you, if I enter a wrong code, okay, if I enter a wrong code over here, so let me see the code again. Okay. So it's refreshing. So the code now is 131669. Okay. So if I enter 131668, let's say it's 669, but if I enter 668, okay, let me show you what happens. If I say verify, you will see invalid two-factor authentication code. If I enter the right one, it will take you in, right? So this is very secure. Even if your passwords are leaked online, let's say if you're building a service, if you're implementing a security measure in your personal application, and let's say if there's a data breach and your passwords were leaked online, then too the hackers cannot gain access to the account because you had two-factor verification enabled. Even though he had the combination of username and password, the second layer, which is the two-factor authentication from Google Authenticator app, that is something which is configured on your phone, right? So the hacker won't get access to your account. That's the security measure that we have implemented over here in profile. Okay. You can choose to disable this as well. If I disable this, okay, you can see like it's asking me to enable again. And of course, when I enable two-factor authentication, it is only enabled for this user that I'm logged in with, not with the other user or any other system user that exists in the database. All right. So that's the multi-factor authentication, and that is how it's being managed here in the UI application. Okay. I'll also talk a bit about password security over here. Okay. But before jumping over to password security, I'll talk about the admin section over here. Okay. So let's explore this admin. Now this admin section is only for admins, the site admins. Here you can see all the users. Okay. So all the users that have been created in my application, I'll see all of them over here. So you can see these are all the applications. This is when they were created. This is their status, and I can click on view and I can view the information to profile, of profile. All right. Now as an admin, I have the authority to change the password or any sort of information of any user. Okay. So if I want to edit the password, I can click over here. Okay. So keep in mind, I have not given direct edit access over here. Okay. So that I don't want admins to edit the passwords accidentally. So it should be intentionally. So they have to click over here, then they have to enter the password, and that is when the password is entered. Okay. I'll say cancel. You come over here, you can change the role over here. So if I want to update or upgrade this user to role admin, I can do that. And tomorrow, if there is any other role that is being added into a system, that will also be reflected over here. Okay. I can lock the account, mark the account as expired. I can expire the credentials. All of this I can manage from here as an admin. Okay. And I can do that for any sort of user over here. You can see. Okay. So that's something you need to understand over here. All right. So this is about admin section. And if you go to audit logs, here you will see what all is happening or what sort of actions users are doing in your application. So you can see username admin updated this note with note ID 2, and this is the content that he updated. Okay, you can click and go to the note as well, and you can see what all logs have happened against this note. Okay, so all of that can be done. Okay, you can see this note 32 was updated on July 9 over here by admin. I can go over here and see what all updates have happened for this particular note over here. Okay, so this is kind of a log or a security feature that I've added over here. Here you can see the pagination also being implemented. All right. So yeah, that's about the admin section over here. Now I also want to talk about that whatever functionality we saw in the front end, of course you will be building the APIs for that. Okay, and you can see these are the APIs that we will be talking about and will be building. Okay, And all the APIs over here are authenticated. You can see we are making use of JWT authentication. We are also making use of CSRF protection over here. So our application is CSRF protected. If you don't know what CSRF is, if you don't know what JWT is, that's completely okay. If you don't know what OAuth is, that's completely okay. It's all covered. But I just want to tell you that it's a kind of security attack against which we are protecting our application. So here you can see every API request over here will need a CSRF token. It will need a authorization token, which is a JWT token. Okay. And all of this will be building over here. You can see update notes. It needs these kind of tokens. Without this, the application is not going to function. Okay. Now the thing is, this is needed by backend. Now from front end, how can you make sure that these two things are passed with every API request? How can you make sure that? So that is exactly what we are going to learn, how things work when React comes into picture. Okay. With backend, you will build all of this, but how do these things function when you have a front end in place? All right. So that is what we are going to cover. All right. I also want to talk about password security. So here I'm here in the database. Okay. You can see my passwords are encrypted. They are hashed. You can see over here, they are encrypted, and you can see these are not in human readable format. So this is how we are securing our passwords. Ideally, it's best practice that you should not store passwords in plain text format in your database. But what happens is normally system admins and database administrators, they have access to database and they can gain access to all the credentials. They can know all the credentials. Or tomorrow, if your database is hacked, then the hacker will have access to the plain text passwords, right? And it's in human readable format. So the best security practice is to store them in hashed or encrypted format, which we are doing over here. We are going to cover all of this as to how this can be done with the help of Spring Security. And yes, over here, I'm showing you the demonstration of MySQL, but I've also shown you how things work with Postgres. So if you want to update the database tomorrow to Postgres or any other database, you should be happily able to do that. All right. So yeah, that's about the entire application. All right. I hope you have a clear picture of what we are doing, what we are going to build, and how this application secure nodes is going to function. All right. Now, I would like to also mention that this application is hosted on this website over here that you're seeing on the screen. Okay. So if you want to play around with the application yourself, you can head over to this website and you can take a look and play around with the application before you enroll into this course. So yeah, I hope this was useful and I hope you are excited. So before moving any further, I would like to show you a couple of settings that you can enable in IntelliJ for better experience. So we are going to refer to a lot of inbuilt classes, inbuilt documentation, and so on. And it's best if you have access to all of that within IntelliJ IDEA. So I would request you all to head over to the main menu. Okay. If you're on Mac, you're going to see main menu like this. If you're on Windows, you'll see this over here. Click on this, head over to preferences over here. So you'll see the option of preferences on Mac, but on Windows, you'll see settings over here. Okay. So go to settings over here. And here under settings, just scroll down, go to build tools. Okay. Under build tools, build execution and deployment, you will see build tools over here. Under build tools, go to Maven over here. So since we are making use of Maven, select Maven and here select importing over here. Okay. So once you select importing, you'll see the option over here, automatically download. So automatically download sources, documentation, and annotations. Okay. So I would say check all three. Okay. With this, you will ensure that all the sources like the source code, the documentation, and the annotations are downloaded for your reference and you can refer to them within the IDE itself. You don't need to switch over to the browser and head over to the documentation. And this would help a lot. Okay. So I would say apply over here. I would say okay over here. Okay. Now, if you're doing this in an already existing project, you should head over to Maven and reload Maven changes. But if you have not created the projects, that's absolutely fine. Okay. Don't worry about that. And you can see over here, the moment you do the reload Maven, you can see the library sources documentation is being downloaded over here. Okay. The moment you hit this. All right, so if you have already created the project, be sure to reload the changes. Otherwise, that's completely fine. Whenever you create a Maven based project, make sure that setting exists, and at that time you can refresh. Okay, so yeah, that's about configuring IntelliJ for better experience. Well, I know most of you want me to go hands-on directly and show some code, right? But to implement Spring Security into production grade applications, you need to understand some concepts that are important. And I'm going to talk about those concepts because once you understand these concepts, then you will be ready to implement Spring Security into any of your Spring Boot applications. So please bear with me for a while. I'm also excited to teach you in a hands-on way. This is a hands-on course, of course, but yes, some concepts we need to touch upon, and for that we need to touch the slides. Okay, so first thing, I want you to know that security is important. Of course, you understand this, and that is why you are here watching this. Okay, now what is security? So security is securing something. Okay, and you have a house, right? You have doors, windows, you lock your door if you're out, right? Spring Security does something similar for your web application. It's like a sophisticated security system that you implement in your application, and that system ensures that only the right people can access certain parts of your application. And this helps you keep your data safe and sound. Okay, so in case of your home, why would you lock your door and windows when you're going out? Of course, so that no one can come in and access your personal things, right? Similar way, it works with your web application. Okay, and Spring Security helps you with that. All right. Now, if I have to talk about the importance of security, number one important thing is privacy protection. So just like you won't want strangers peeking through your windows, your users don't want unauthorized people seeing their personal information as well. Okay, so protecting user data prevents identity thefts and fraud. This is something that you need to understand. Trust. So if your house is known to be easily breakable, people will be wary of leaving their valuables with you, right? In a similar way, if an application is known to be insecure, users and client will not trust it with their data. Okay, so if you're building something, then having that credibility, having that trust is really important in the market. Integrity. Imagine someone sneaks into your house and replaces your important documents with the fake ones. Okay, so in the digital world, application security ensures that the data remains unchanged and trustworthy, preventing from unauthorized modification. Okay, compliance. This is also important. So there are laws and regulations about building security in real world. Okay, and there are also legal requirements for data protection in digital world. So security helps ensure compliance with these laws, avoiding legal consequences. Okay, so this is the importance of security. Now, let's talk about role of Spring Security within the Spring ecosystem. So we have Spring Framework. It's like a foundation, like the structure of your house. Then you have Spring Boot, and it's a module that makes easy to set up and run Spring applications. It's kind of like having a house built with all the utilities connected and ready to go, right? So there are a lot of features of Spring Boot like auto configuration and all that make your life a lot easier. Okay. Then you have Spring Data that help you manage data access. Okay. And then you have Spring Security. Okay. Now, Spring Security is a key player in the Spring ecosystem. It's a collection of tools and frameworks for building Java applications. And using Spring Security means that you're protecting your application's data, like you would protect assets in a company safe or anything personal. Okay, so there are two important things that you need to understand when it comes to security and when also it comes to Spring Security. So number one is authentication. We will take a look at what authentication is. Okay, and then we'll talk about authorization. So most of the people I speak to, they get confused about these two terms. Okay, so I want some clarity around this first. And then when we head over to implementation, you will have a clear understanding as to what we are doing and why we are doing. Okay. So talking about authentication and authorization. Authentication. What is authentication? Authentication is proving who you are. Okay. So if you are going into a restaurant or if you're going into a hotel, okay, you'll have a security person or someone at the reception, whoever, who will ask you for your membership card or how you are entering, any sort of authentication that authenticates that you're allowed to enter. Okay. And showing that thing proves that you are a member, and that's the authentication that you do, right? In your computer, when you log in, you're entering your password, your username and password, or if you're using Mac or any other laptop which has a fingerprint scanner, you will scan your fingerprint, right? And it authenticates that it's you who are supposed to use the system and you are using the system. That's authentication. What is authorization? Authorization is about what you're allowed to do after you have proven who you are, right? So you have proven who you are. Now, if you enter a hotel, okay, you enter as someone, right? You show the identity card and you are allowed to enter. You enter. But now you might not be allowed to enter every place of the hotel, right? You might be allowed to access certain rooms or certain facilities, and there will be specific permissions that will be with you. Okay, you cannot enter, for example, a security zone. You cannot enter a particular area, or you cannot enter someone else's room. You are not authorized to go there, right? You're authorized to use your own room. So that is nothing but authorization. Okay. And in a computer system, authorization decides what actions you can take after you have logged in. Okay. So let me reiterate over here. Okay. What is authentication? Authentication is like you are entering your username and password. Okay. You enter your username and password, you get access to the system. Okay. What is authorization? With authorization, okay, so if you are having an application, you're going to have roles, right? So user A will be allowed to do a certain thing. User B will be allowed to do a certain thing. Okay. User C cannot delete a certain thing. Okay. So this authorization, so you authenticate user A. Okay. User A will enter username and password and he'll say, all right, I'm user A. So he's given access to the system. Now, after getting the access, he cannot delete a particular record. That's authorization. Okay. So stopping him to delete a particular record is authorization. Okay. So there are two aspects of security over here that you need to understand. Authentication. Authentication is gaining access and it's proving who you are. Authorization is about what you are allowed to do after you have proven who you are. Okay. So in a sense, as a developer, you need to implement authentication in your application, and you also need to control the authorization. Okay. So if you are implementing something, if you're building a simple application and if you don't need authorization, like everybody is allowed to access everything, that's absolutely fine. Authentication is what you need to deal with. But normally in every application that at least I have seen, authorization is really important. Okay. So there will be an admin. So if you're building an e-commerce store, there will be an admin, right? Who can create products, who can view orders, who can view customers' phone number. There will be a customer support executive who cannot view the revenue, who cannot create a product, right? He can view the support tickets, right? So that's authorization. All right. So this is something that you need to understand. Now let's talk about some key security principles. Okay. First principle is least privilege. Okay. So users and processes should have the minimum level of access or permissions that you should assign to perform the necessary task. Okay. So whenever you are assigning something to anyone, make sure you give them the least level of privilege to complete the task. Okay. Secure by design. Now, what does this mean? So security consideration should be integrated into the design phase of software development rather than adding it as an afterthought. Okay. So what happens is, I'll tell you, normally we developers, we get requirements from someone in the company, like let's say a manager or a product owner, someone, depending on how your hierarchy is designed. Okay. Security is not given a thought at that time. Okay. So whatever requirements you're getting from the client or whoever, okay, he's going to give you all the functionality he wishes to have, right? People normally don't mention security as an aspect. Okay. It has to be considered by default by you as a developer. Okay. And you have to think of security into the design phase itself. So when you're designing your application, thinking about different components, you have to think of security. That's the best approach. Okay. Normally what happens is developers build the system and then they implement the security and then they start thinking about security. Okay. So this is not good, but it has to be secure by design. Okay. Fail-safe defaults. So systems should be designed with secure defaults, meaning they should operate securely out of the box without requiring additional configuration. Secure communication. So whatever communication you're doing, transmitting data over the network, it should be encrypted and you should prevent any interception over there. Okay. And it's essential that you protect all the secure information that you are transmitting. Input validation. So all the input data from the external APIs and everything should be validated to prevent any sort of attacks like SQL injection and so on. Okay. This is also important. Auditing and logging. So you should have logging and auditing mechanisms to record the events related to security and all the actions that are being performed in your system. So normally what happens is there is a separate logging module that is built in if you see or you work in a production grade environment. So logging module, what logging module will do is who is doing what in the system, that is being logged into a separate table. Okay. So for example, if you're an admin and if you're creating a product, changing access roles, so all of that is being logged. Okay. That this user at this time, he did these things. So that whenever there are any security incidents later on or any sort of breaches, so team can then investigate as to what happened and what led to this breach. Okay. So this is one aspect. Regular updates and patch management. This is important. So you need to keep software dependencies, libraries, frameworks up to date with latest security patches and fixes. Because in the latest updates, normally the latest vulnerabilities or the new vulnerabilities have been fixed. So that is something that you need to keep in mind. All right. So this is about some of the key security principles that you should be aware of. Hey there. So it's time that we talk about how Spring security works. So in a normal Spring Boot application, you will have your controllers over here and you will have requests coming in and response going out. Okay. So this is the entire diagram that explains the working of Spring security. Don't get overwhelmed by the diagram. It's actually simple. I'll break it down for you. Okay. So like I was saying, you have controllers here. Okay. And you have request and response going out. Okay. Request coming in, response going out. Now, when your request comes in, it first goes through a series of filters over here. Okay. So here you have filters. This is one filter, second filter, third filter, so on. There are many filters, okay, depending on what you have configured, okay. And your request has to go through this series of filters known as filter chain, and then it reaches the controller, okay. And controller is where your actual application code resides, okay. Now these filters have a specific job related to their own configuration, okay. And if you have Spring security configured, then you will have a filter called as authentication filter. Okay. So without security, you will also have filters exist in your application, but these won't be the security related filters. Okay. But when you configure security, you will have some filters added, which will be the security related filters. Okay. And one of these security related filters, like I said, is authentication filter over here. Okay. Now, what is authentication filter? So authentication filter will be intercepting the requests that are meant to do login. Okay. So there are login requests, and these requests will contain username and password or any sort of authentication information that needs to be validated. All right. So far, what are filters? Filters are nothing but some code, okay, that reside before the controller, and your request has to pass through it. Okay. They will intercept your request for some sort of processing. And you have authentication filter if you have Spring security configured in your project. Okay. What does authentication filter do? Authentication filter will intercept the authentication request, and what it will do is it will grab the username and password and create authentication object from them. Okay. And this object is basically a way to package the credentials. Okay. So first the authentication object is created. Okay. Because everything within security works in the form of the authentication object. So that object is important first, okay? And that is being created here. Once the object is being created, the object is being handed over to the authentication manager over here, okay? Now, authentication manager is someone who decides what to do with these credentials, okay? So what this authentication manager will do is it will delegate this task, okay, of authenticating the user to someone else, okay? So authentication manager, like I said, it decides what to do with these credentials, okay? And it will say that, hey, what should I do with the credential? I should authenticate. Now, to authenticate whoever has sent this request, I need a authentication provider, okay? So authentication manager decides that, hey, he needs to authenticate, and for that, he'll need a authentication provider. Now, authentication provider. What is authentication provider? So authentication provider is someone who is responsible for checking whether the given username and password or whether the given credentials are correct or not, okay? And for authentication provider to validate the credentials, it needs two things. One is password encoder, and then it needs UserDetailsService. So we'll talk about each one of them. So we'll talk about password encoder first, okay? What is password encoder? So what happens is whenever the password is passed in or whenever the user credentials are passed in, okay, they are always encoded, right? They will be encoded using some form of encryption, right? And to decrypt the password, you need to do some sort of like processing over there. And that is what password encoder helps you with, okay? So it helps you encode the entered password, and it will help authentication provider with the same, so that authentication provider can take care of the rest, okay? So this is about password encoder, okay? And what is UserDetailsService? So this is called by the authentication provider to load the user details, and it can call methods like load by username and all, and it will load the details like username, password, and what all roles does this user have in the system, okay? And it will load it from a source of data, okay? So if your data is being stored in the database, it will load it from there, okay? And what happens is this particular service will load the user information, okay? And it will return this particular information, which includes everything that system needs to know about the user, including their stored passwords, roles, and all, okay? It will get this user object and it will convert this object into user detail object, okay? So the object that is returned by user details service is user detail object, all right? And then this particular thing over here, authentication provider, will have the user details. So authentication provider will confirm if the username and password are correct, okay? And once it is validated that the username password are correct, it will create a complete authentication object, okay? So authentication object earlier that existed, which was created by the authentication filter, that might not have some information like roles and all, okay? So once the authentication is successful and it's confirmed by the authentication provider, the authentication object is populated with more details like roles and all, okay? And then this object is handed over back to the authentication manager here that, hey, this is the object, updated object, and this is the user that you wish to authenticate, and this user has been authenticated, okay? Then this object is returned to authentication filter, and then the security context is set, okay? So what is security context? So security context is a sort of context that is available throughout the duration of the request, okay? So it's a context wherein the information about the authentication is stored. So where does the detail of the authenticated object reside now? It resides in the authentication object, right? So this authentication object was created by filter, and the details, more details were populated by authentication provider. So then this object is set into security context and it will be available throughout the request, okay? And throughout the request, this object is referred as to what the user is allowed to do in the system and what it's not allowed to do in the system. Okay, so like I mentioned that when the authentication is being done, the authentication object is being populated with what? With roles, right? And these roles are being used by the application to dictate as to what the user is allowed to do and what the user is not allowed to do. Okay, so this is how the entire flow works. Okay, here how the flow works is, if I have to reiterate, you as a user enter the username and password. Okay, and it goes through a series of filter chains over here. Okay, filters over here, and one filter will be authentication filter. Okay, and then an authentication object is created here. Okay, authentication manager takes this object and asks authentication provider to verify it. Okay, then authentication provider will use UserDetailsService and password encoder to fetch your details, and password encoder will compare the passwords and everything. If everything matches, okay, the authentication provider will confirm and your details are saved in the authentication object. Like the authentication object is updated with the rules and all, and the security context will be populated with the authentication object. And then you are allowed to access the controller and the code executes, and during the request, this context is referred as to what you're allowed to do and what you're not allowed to do. Okay, so I hope this is making sense. Now, when we talk about authentication provider, here I've mentioned DAO authentication provider. Okay, so this is one of the common authentication providers used, and this is used when you wish to validate the users against a database. Okay, so normally you have a database where the user details are stored, and if you want to do that, you can make use of DAO authentication provider. Okay, and it relies on this particular service here, UserDetailsService, to fetch the user details and then compare it with the provided credentials against these details. Okay, so this is one kind of provider, but there are many providers. Like in-memory authentication provider is one of the providers. Okay, so if you're storing your data into memory and not in the database, okay, then you can make use of in-memory authentication provider. There is LDAP authentication provider. Okay, LDAP, if you're aware of, lightweight directory access protocol. Okay, so if you wish to integrate LDAP security, then you have to make use of that provider. You have JDBC authentication provider. Okay, so there are a few authentication providers that exist. So depending on where your user details are coming from or where they are stored, you will use the appropriate authentication provider. Okay, and you can see the methods over here. So authentication manager will call the authenticate method. Okay, you have matches method to match the password, load by username. These are all methods, find by username. Okay, these are all methods that exist that are called by the respective components. Okay, so this is about the overview of Spring Security. One crucial thing to remember over here is the concept of filters over here. So you're going to see filter, authentication manager, authentication provider, password encoder, user details service, all of this in the code. Okay, so it's important that you understand these and the roles. And if you still have any confusion, don't worry. Everything will be clear once we start coding things. Okay, but it's important that you understand the concepts at a high level. So that's about the working of Spring Security. I hope this was useful. So now it's time that we begin setting up our Spring Boot project. So what I'm going to do is I'm going to head over to our favorite website, which is start.spring.io. And this is a Spring initializer. And here I'm going to create the project. So I'm going to select Maven over here. I'll select Spring Boot over here, the project metadata. I'll select group as secure, and you can say .notes over here. Okay. Or I'll change this to com.secure, okay, so that I have a decent package name. And here, in case of artifact, I'll mention notes, okay. So you have the package name as com.secure.notes. Of course, you can go and edit this as well, okay, but I don't want to do that. Okay, so I'll say secure notes project over here. All right. I'll select the relevant Java version. You can select 21 or 17. That's perfectly fine. These both versions of Java are the LTS versions. I'll stick to 17. That's okay. You can even select 21 if that's something that you want to use. All right. Now this is done. Now what I'm going to do is I am going to select a dependency from here. I'm going to select web over here. That's the dependency that we are going to need. And I'm going to say generate. And the moment I say generate, I'm going to be asked as to where I want to download this. So say generate and save it onto your folder wherever you will be working on this project. Okay. So I have it downloaded on my local machine wherever I wish to code. And I'm going to extract this over here. Okay. And once we have extracted, we have this folder notes. And I'm going to come over here to IntelliJ. So I have IntelliJ open. I'm going to say open over here and just navigate to where you created that project. Okay, so I created this project in Spring Security and I have this notes folder as you can see over here. And I'm going to just select form.xml over here. Okay, and you can see it's a project file. So would you want to open the project? I'll say open this as a project and I want to trust all the projects in this folder because this folder is 100% in my control. I'll say trust the project and it opens up. Okay, so you can see over here you have the entire project being downloaded. All right. Okay, so it will take a bit to set up the Maven dependencies over here, but it should not take a lot of time. Now we have this project up, okay, and set up. What I'm going to do is I'm going to create a controller over here. Okay, so I can say controller or I can say hello controller. Let's call it hello controller. And here I'm going to name this as REST controller here. And I'm going to have a very simple mapping over here, get mapping. And I'm going to say, okay, I don't need to mention this. I'll say public string and I'll say hello over here. Okay. And this is a very simple mapping that I'm creating, which is just going to return hello. Okay. So I'm going to say return hello. All right. And here you can even add an endpoint. I'll say this is hello endpoint. Okay. And let me run this code. So I'll run this. I've not created any folder where the controller will reside. That's completely fine right now. We are just getting started. Okay. If you wish to have a folder, you can create a folder called controller and move the controller inside. Okay. But this is what I have right now. Okay. And if I head over to the browser here, and if I say localhost :8080, okay, and if I say, okay, 1 second, so it's 8080, and here I need to add hello. You're going to see hello, okay. So project setup is done. We have a project working with IntelliJ. So let's try to understand Spring Security's importance and benefits. So we'll try to dissect as to why it is crucial that any Java application that you're building, why you should consider Spring Security as the most strong option over there to be included for security measures. Okay. So first, let's talk about what Spring Security has to offer us. So number one thing is authentication and authorization, of course. Now, authentication is where Spring Security will help you verify the identity of the user, like who the user is. It's like checking the user ID before allowing them to enter the secure area. And then you would have authorization, where Spring Security can help you determine whether the authenticated user is allowed to do a particular action or not. Okay. And so it's like authenticating users and then making sure that he's only doing those things that he's supposed to or he's allowed to. Okay. So this is authentication and authorization that can be easily implemented with Spring Security. Then Spring Security allows you to protect your application against some of the most common threats in the world. Okay. So threats like CSRF attacks. Okay, CSRF, if you have not heard of, it's cross-site request forgery, where the attackers can trick users into performing the actions that they don't intend to. Okay, so it's a type of an attack that is very common. Then another type of attack is XSS, which is cross-site scripting. And in this attack, the scripts are injected into the web pages that are viewed by user. Okay, and those scripts are malicious and harmful. Okay, so that's one form of attack. Clickjacking is another type of attack where you have like a malicious site, and Spring Security can help you prevent malicious site from tricking users into clicking onto something different than what they perceive. Okay, so these are common type of threats that Spring Security allows you to secure your application against. Password storage. Spring Security also has all the methods and all the tools that are needed to help you as a developer store your passwords securely using the techniques like hashing, salting, and this makes it difficult for the attackers to decipher password even if they gain access to the stored data. Okay. And the last benefit or the last thing that Spring Security offers is a strong integration with the Spring ecosystem. So since it's a Spring product, Spring Security integrates very seamlessly into the Spring ecosystem, okay, which is widely used in enterprise application. And this means that it will also go easily with things like Spring Boot, Spring Data, Spring MVC, and so on. So this is what Spring Security has to offer, okay? Now, imagine doing all of this by yourself. So let's say you don't want to use Spring Security and you decide to not use Spring Security, and you will say, okay, I'll implement my own custom security mechanism. So imagine doing all of this by yourself, like writing the code to authenticate users manually, authorize user manually, and writing the code to protect your users against these common threats that we spoke about, like CSRF attacks, XSS attacks, clickjacking, and so on. Okay. And if there is any new kind of attack in the market, Spring Security team will upgrade the framework. Okay, and you don't have to do anything. You have to just update the version of Spring Security that you are using and you are taken care of. Okay, so the Spring Security team is very active, and like basically there are regular updates for this particular framework. Okay, but let me tell you this. Imagine if you're doing all of this by yourself. Like, it is going to be crazy. You will spend a lot of time doing all of this, and it's best that all of these things are centralized and being done by someone who is an expert at this. Okay, and you just use the things that they have built. Okay, and this way you focus on the business logic of your application and not on the security aspects, because security aspects you just have to tell some configuration to the framework that you're using. For example, here Spring Security is what you'll use. You have to just tell what authorization you want, what authentication you want, how you want to authenticate users, how you want passwords to be stored, and all of that, and rest all is taken care by the framework. Okay, so that is a better approach when it comes to making use of Spring Security. So don't think of doing all of this by yourself. Okay, just make use of Spring Security. It is one of the most advanced security frameworks out there. Okay. Now, the question is, why would you use Spring Security? So number one reason is it's comprehensive and customizable. And like I said, Spring Security offers a wide range of features just out of the box. Okay, so you just configure Spring Security and you'll see a lot of features being made available to you. Okay, and it also allows you to do any sort of customization that you may want to meet your specific security needs. Okay, so there will be a possibility that you don't want what is already there out of the box. You might want to customize this, that hey, I don't want to authenticate users this way, or I don't want to do something this way. Okay, so in that case you can customize that particular portion your way, and you can take it ahead. You can use the rest of the features as it is. Okay, so that's one of the benefits over there. Okay, and it covers many aspects of security, from simple authentication to complex access control list. Okay, it has a very strong community and support. So the community is very large, active, and there is a really good documentation, videos available out there, and this will ensure that you find help and resources easily when you need. Okay, and declarative security. So Spring Security allows you to specify security constraints declaratively using annotations and configurations, and it makes your application easier to maintain and understand. Integration abilities. So Spring Security can easily integrate with various authentication mechanisms like OAuth2, LDAP, and so on. Okay, And if there are any other security standards that you want to integrate into Spring Security, you can do that. Okay. And this gives a lot of flexibility in how you secure your applications. Also, there are regular updates. So this particular thing is being regularly updated. There is a very active team involved over there. And any sort of new security vulnerabilities that are identified are immediately incorporated into the framework and they are released as an update. Okay. And to support the latest security practice and technologies, the framework is kept always up to date. Okay. So regular updates are there. Yes. And it's easy to use with Spring Boot. So if you are making use of Spring Boot for your enterprise grade, production grade applications, then you can integrate Spring Security with very ease. Okay. You just have to do some configurations and you are done. And if you want to extend any sort of if you want to customize anything, extend anything, then you have to write your own custom code, which is very minimal, of course, depending on what your requirements are. Okay. So that's about Spring Security. And yes, I should also mention that Spring Security also makes use of Spring Boot's auto configuration capabilities. Okay. So a lot of stuff is auto configured. Okay. Once you add this dependency into your application. Okay. So in summary, Spring Security is robust, flexible, comprehensive security framework that integrates seamlessly with the Spring ecosystem, and it makes this as an ideal choice for securing your Java web applications. Now, when working with Spring Security, you will frequently hear these terms principal and authentication object. And it's really important that you understand what they are and what they mean. So first, let's talk about what is principal. So principal represents the currently logged in user. So if you're building a web application, you have users who can log in, right? And principal is how they are represented. So the user details like username, email become the principal. Okay. So you can think of principal as who you are. It's basically your identity within your application. And as an example, if you log in with the username John Doe, the principal would be John Doe. Okay. So that's principal. Now let's talk about authentication object. Now what is it? So authentication object is a more comprehensive representation of the user's authentication information. Okay. So it would have details like the principal, which would indicate who the user is, as well as the credentials. And the credential would be present only if the user is not authenticated. And it will also have authorities. Now, what I mean by authorities means the rules or the permissions that the user has in your system, right? So the user might be seller if you're building an e-commerce application. He can even be a normal user, or he can be an admin, super admin, whatever. So that becomes your authority. Okay. So these things will be there in the authentication object. So to summarize, here you have the authentication object over here. Okay. You have the principal. You can see this is the logged in username. And then you have authorities, which is role admin. Okay. So this is the role that the user has in your system. And this together forms the authentication object. So this is the entire authentication object. And this authentication object tells the system as to who you are and what you can do. And it also tells you or gives you the details about the user as to what he can give, what he can do in short. Okay. So that is the concept of authentication and principal. Now, if you're working with Spring Security, you will hear these terms really often. Okay. Like the principal object, I'll also be talking about the authentication object in the code and all of that. Okay. So it's really important that you get a gist of what they are. So now it's time that we talk about filters and filter chain. Now, what I'll do is here in this particular video, I'm going to break down this concept and explain this to you in a very simple way as to what these are. Because when you're working with security, you're going to hear this concept of filters and filter chain very frequently. And it's important that you understand this. Now, before moving forward, I'll also tell you this concept of filters and filter chain is not just a Spring Security concept. This is a concept that also exists in any normal Spring Boot application without Spring Security as well. Okay, so this concept exists in normal Spring Boot application, but with Spring Security, you tend to use them more. You tend to talk about them more because they are important over there. Okay, and that's why some of the people think that this concept is a security related concept. That's not the thing. Okay, so first, before talking about filters and filter chain, let's first take a look at this diagram. Now, what is this diagram? This diagram is a representation of how a request or a typical HTTP request flows through a Spring Boot application. Okay. Now, when I say Spring Boot application, this is a normal Spring Boot application without security. Okay. With security or without security does not matter. Okay. It's a normal Spring Boot application. So here you have client. It is actually sending the request to the server. Okay. Now, server is where your application will reside. And the server can be any server like Tomcat, Jetty, and you'll have your application up and running on the server. And this request is first intercepted by filter chain. Now, what filter chain is? Just hold on for a minute for that. Okay. But this request is intercepted by filter chain, and after doing some processing, it is passed on to the dispatcher servlet. Okay. Now, what is dispatcher servlet? Dispatcher servlet is a servlet, or I can say a central dispatcher in Spring MVC, and it determines the appropriate controller who can handle the request. So once the request is dispatched to the right controller, controller will do the job of taking the request forward. So it will work with the rest of the application. It will call the services will call the repository, and so on. And some interaction with database might happen if it's a database backed request. And then the response will flow back in the same way. Okay. Now, this is a typical request flow in the Spring Boot application, but let's now zoom into this concept of filter chain over here. Okay. Now, this filter chain has two things. Okay. One is this entire filter chain, which I've marked over here like this filter chain. And within this filter chain, you will have this filters. Okay. Now, this is filter 1, this is filter 2. There will be many filters, and then in the end, you will have the last filter. Okay. Now, what are filters and what is this filter chain? So, filters are components that can intercept and modify incoming requests and outgoing responses in a web application. Okay. Now, these are really important over here. Okay. Because they do the job of intercepting the request and doing some additional processing, whether it's a request or a response. Okay. And each filter that exists over here. So you can see the filter exists in filter chain. So each filter that exists in the chain has the opportunity to process the request and response and decide whether to pass it along to the next filter or the next resource in the queue. Okay, so it's the decision of the filter. Okay, and how is that decision done? It's dependent on the logic. Okay, so let me give you an example. Let's say there is a filter. And let's say the job of that filter is to check for usernames. Okay. So let's say we don't want any usernames containing A, B, C or 1, 2, 3. Okay. So what that filter will do is whenever there is an incoming request coming in to the application, which is the create account request. So what this filter will do is it will intercept that request and it will check if these characters or this word is being used in the username. If it's being used, it will reject that request there and there itself. It won't pass it to the next filter. Okay. Because the validation has failed, right? Now, filters can do a lot of jobs. Okay. Like this was one example where this filter was responsible for checking if a particular string of character exists in the username or not. This is one example. You can have more filters, like one filter can do the job of authentication. You can have one authorization filter, and there are several use cases as to why filter might be needed. Okay. So this is filter. Now, what is a filter chain? Now, filter chain is a chain of filters, right? That is what the name says. Okay. So it's a sequence of filters that an HTTP request and response pass through before reaching the targeted resource after the resource has generated the response. Okay, so that is what filter chain is. So this is the simplest explanation you'll find for filter and filter chain. Okay, I hope this is very clear to you all as to what filter is and what is filter chain. Simply put, filter is nothing but a component that can intercept the request, do some sort of processing. Okay, it can either intercept a incoming request or outgoing response as well. Okay, it will do some processing and then it will allow that request to go forward in the queue. Okay, and filter chain is nothing but the sequence of filters. Now, how do filters and filter chain work? Now, that's where the magic happens. Okay, now what happens is the first filter in the chain will receive the request and it will perform some processing. And what processing it will perform, that depends on what filter it is. Okay, and now whatever logic exists in that filter, that is what the processing will be done. Now, after processing, the filter calls this method, which is the filter chain dot do filter request response, and it will call this method to pass the request to the next filter in the chain. Okay, now after this is done, the process continues until the request reaches the final resource, and after this, the response is generated by the resource and it travels back through the chain, allowing each filter to perform any necessary post processing. So this is how the request and response flows through the filter chain. Okay. Now to summarize, filters are components that can intercept and modify the request and responses. Filter chains are sequences of filters through which the request and response should pass. And in Spring Security, filters are used for authentication, authorization, and a lot of other security related tasks arranged in the chain. And this chain is being managed by the Spring framework itself, or I should say Spring Security framework over here. Okay, so understanding filters and filter chain is essential for managing the request and response processing in the structured and efficient manner, especially in these secure web applications. Okay, now let me talk about why filters. Okay, now you would say that why would you use filters? Okay, so there are few reasons as to why filters are always present. The number one reason is cross-cutting concerns. So filters are ideal for addressing cross-cutting concerns like logging, security, compression, any sort of input validation that you want to do. So these are the functionalities that are often needed, and you need to apply these across multiple endpoints in a very consistent manner. And by placing these concerns in the filters, you can avoid duplicating code in each controller, right? So rather than writing all this code in the controller, you can have a filter that will intercept every request and do some sort of pre-processing or post-processing that needs to be done. Another reason is pre and post-processing, like I said. So filters allow for pre-processing and post-processing of responses. Okay. For example, you might want to log all the incoming requests before they reach the controller, and you might also want to log the responses before they are sent back to the client. So filters provide a mechanism to do this in a very centralized way. Request and response manipulation. Now, filters can be used to modify the request responses. They can do some useful tasks like setting up the character encoding, handling CORS like cross-origin resource sharing. If you're not aware of this, what this concept is, don't worry, we'll cover this. And even rewriting URLs. So if you want to rewrite the URLs, you can make use of filters. So these are few things. Also, one is separation of concerns. Okay, so you can make use of filters, and you can have all these logic of doing things with the request within filters, and this way you can separate your business logic, and things like logging, security, data transformation and all is moved to filters. So this leads to a more cleaner and maintainable code. Okay, so yeah, that's about why you should use filters. Okay, I hope this was useful, and I hope you have decent clarity as to why this concept exists in Spring. So now it's time that we understand how Spring Security works. So this diagram gives a brief overview of how the internal working of Spring Security happens and what are different components involved when you are authenticating, authorizing a user. Okay, so this diagram might look a little bit overwhelming, but don't worry, I'll break it down and I'll explain everything to you as to what are these authentication filters, authentication manager, and what all these components are. So don't worry. Okay, and even if you don't understand this right now, like if this seems very overwhelming, don't worry about that. It will all come into picture, or it will all come into light when you start writing the code as to what is happening and how things are working. Okay, so Here you can see you get the request into your application. Okay, so it all starts with the request. Now request is intercepted by filter chain, right? And filter chain has a series of filters within it. Now there will be different filters, and one of the filter is the authentication filter over there. Okay. Now what is authentication filter? Authentication filter is a filter whose job is to intercept login requests. And login request, I mean from where you submit your username and password. And if it detects such a request, it grabs the username and password and immediately it creates an authentication object from that, right? And this object is basically a way to package all the credentials. It also has the principal, which is nothing but the user details. Okay. So far we have the authentication object over here. Okay. Authentication filter does the job of creating the authentication object, and this object does not say that the user is authenticated yet. Okay. Because authentication is yet to happen. We are still at the filter here. Now what this will do is authentication filter will hand off this authentication object to the authentication manager. Now what is authentication manager? So authentication manager is like a orchestra, or you can think of a manager who decides what to do with these credentials. Now authentication manager won't do the verification of credentials itself. Instead, it will make sure that the credentials are verified. So what it will do is it will delegate the task to one or more authentication providers. Now what is authentication providers? So authentication provider is a component that is responsible for checking whether the username and password that the user has entered are correct. Now what it does is there could be multiple providers, right? So provider simply means the way you are authenticating the user, right? So you could have a way of authenticating a user using a database. You could authenticate your users using LDAP, right? So there could be multiple ways in which you are authenticating the user. So what authentication manager will do is, authentication manager is an interface. It has an implementation called provider manager. Okay. Now with the help of the provider manager, it will identify the right provider against which this request can be authenticated. Okay. So it will go through a series of providers that are available in the application, and it will try to authenticate this user. All right. And whichever works the first, it will return that. Okay. Now here I have made use of authentication provider in the diagram, and I have written DAO authentication provider. All right. Now what is DAO authentication provider? DAO authentication provider is a inbuilt provider provided to us by Spring Security. It's the default one. Okay. That is why I've written over here. So what authentication manager will do is it will invoke authenticate method, and DAO authentication provider will be responsible to assemble a team. Now, who are the team members? UserDetailsService and password encoder. So with the help of these two team members, it will do the job of authenticating the user. Okay. So what is UserDetailsService? UserDetailsService is an interface, and with the help of UserDetailsService, the user details are loaded. Okay. And this is called by the authentication provider over here. And the call is done to load the user details into the memory, like username, password, roles, from where they are stored. Okay. And why are we loading the user details? So the credentials have been passed on to us, the application, by the user, right? You need to match those credentials against the credentials in the database, right? And that is why you need to fetch the existing credentials and match it with the one provided. So that fetching is being done by UserDetailsService, right? And it makes use of this method find by username. It finds user by username, and you get the user, and then the credential is matched over here. And you can see the matching happens, and there is a usage of password encoder. Now what is password encoder? Normally what happens is, it is not a good practice to store the passwords in a raw format or in the plain text format into the database, right? Because anyone having access to the database can view the credentials. So password encoder makes sure that the password is encoded and it's in a non-human readable format. And it makes use of this method matches to match the encoded password with the one that has been provided by the user. Okay. So this matching happens, and if this is successful, then the user is marked as authenticated. Okay. And what happens is, so password encoder helped us with the authentication or with the matching of the password. Okay. Now, once the matching happens successfully, authentication provider over here will confirm that the username and password are correct, and it will create a fully populated authentication object. So the authentication object that was created over here by the authentication filter will be updated, and the updates would include roles and other details that we have got from the database. So now authentication object has the request details, the username, the credentials, like whatever the user has passed into the request. Now the credential can be in any form. It can be a password or it can be a JWT token. So that will be populated into the authentication object. Along with that, roles will be added. Okay. So the roles that were fetched from the database, that would be added, and the object would be marked as authenticated. Okay. So there would be a flag which would be marked as that this user is authenticated. Okay. And now once this is done, okay, the object is updated, right? Now what would happen is the security context would be updated. So here you can see the screen color security context. Okay. So the object is stored in the security context. Okay. So once the authentication happens, what happens? The security context is updated to store the authentication object with the updated details. Now, what is security context? So security context is a context that is available throughout the duration of the request. So what happens is, in this first request, this user was marked as authenticated. So any subsequent request from the same user would be marked as authenticated by default, because the user is authenticated now, and all the other requests will be allowed to go to the application. Okay. So once the security context is updated, the request is then forwarded to the dispatcher servlet, from where it goes to your application controllers, and from there it does the processing of the application or whatever the request was. Okay. So this is the entire process of how Spring Security works internally. Okay. It might seem overwhelming if you're seeing this for the first time, but don't worry about this. Okay. It's fairly simple. You just need to understand how things are flowing. Okay. So there is authentication filter, there is authentication manager, then there are providers. Okay. So if you want to create your own provider, like for example, if you have a custom database, you can create your own provider. If you have a LDAP server, you can have your own provider. Okay. Provider helps the application understand as to how to authenticate the user. Okay. And manager makes sure, like authentication manager makes sure that everything is done over here. Okay. It's like a manager, and that's why the name manager over here. Okay. And user details service has their own role, wherein it is used to deal with the user credentials, like how it should fetch the user credentials from the database or from any other data source. And password encoder, like I said, it has a unique role. It does the encoding of the password. Okay. So together, all these components work together. Okay. And they authenticate the user. Now you might ask, hey, it seems very complex. Okay. Like there are so many components. Why can't it be simple? So the reason there are so many components is because of the modularity that the security team wish to have over here. Okay. So you can see every component has their own role. Okay. So tomorrow, if anything wishes to, like, this is a good practice, like from the modularity standpoint. Okay. Wherein you have separate components doing the individual jobs. So tomorrow, if you want to update anything, or if you want to scale up or introduce anything new into Spring Security, it's fairly easy because the code is so much modularized. Okay. So yeah, that's about Spring Security. You will be hearing all these terms like DAO, authentication provider, password encoder, user details service, authentication manager, this authenticate method, all this you will be seeing in the code. Okay. And that is why it's important that you understand how each and everything works together. Okay. You will also be seeing the security context. Once we authenticate the user, we will be updating the context. So all of this you will be seeing hands-on. Okay. So yeah, that's about this internal working of Spring Security. So now it's time that we get started with Spring Security. Okay. We have this application setup, which is a simple application. We have created a Notes app. Okay. I have a controller defined with a single endpoint /hello, which is a get request or a get endpoint. and it returns a string. And if you test this out, you're going to see hello being printed in a nice way. Now, first thing we need to do is we need to configure the dependencies to get started with Spring Security. So as a result, I'm going to switch over to start.spring.io. I just had this tab open, and I'll make sure that I'm selected Maven over here, and under dependencies, I'm going to say add dependencies, and I'm going to say security over here. Okay. So I'll select security, and you can see security, like Spring Security, is a highly customizable authentication and access control framework for Spring applications. Okay. Now I'll head over to explore, and you'll see a couple of dependencies being added over here. So you can see this is the first one being added. This is starter security, and then you have one more over here. Okay. So what I would do is I would just say copy over here. I'll copy this entire file because this is the secure notes project anyways. Okay. I had this endpoint open, or if you don't have that endpoint, and if you just want to take the dependencies, then I'll recommend that you copy the entire dependencies tag over here. Okay. So you see over here under properties, the opening tag of dependencies, and then you have the closing tag of dependencies. I'll copy this, and I'll come over here onto my project, and here I'll paste this thing, whatever I have copied. So here I'll select this entire dependencies here, and I'll paste it. The moment I paste, okay, you would see this Maven reload icon will come up. So I'll just reload all the Maven changes, and you'll see the Maven refresh happening. After Maven refresh is successful, you can head over to the project structure, external libraries, and just to verify, you can see the package over here. You can see these folders being added. Okay, so these are the libraries or the dependencies that have been added into your project. Okay, and we'll be making use of all of this. Okay, so this is configured now. So remember, Spring Boot has auto configure mechanism, and it works with Spring Security. Okay, and this simplifies the setup process. Okay, and let me show how it simplifies. So if you come over now to the endpoint, or before coming to the endpoint, we need to restart the application because we made changes in the dependencies, right? So application is up and running now. If you come over here now, and if you refresh, you'll see a sign-in page. Okay, so I'm zoomed in. If I reset, this is the signing page. I'll just zoom in a bit. Okay, so you'll see this particular sign-in page. So we did not do anything. We just tried to access hello over here. Okay, let us access hello. You'll see login again. It's redirecting us to login. Okay, so yeah, this is the magic of Spring Boot and Spring Security both. Okay, this is the magic of both. So what happens is Spring Boot provides auto configuration for Spring Security, simplifying the setup process, and it automatically configures basic security settings such as requiring authentication for all the endpoint. Okay, you can further customize the security configurations using Spring Boot's properties or by defining your own configurations, and it's totally up to you as to how you want to customize this. But the point over here I'm trying to make is Spring Security integrates seamlessly with Spring Boot, making it easy to add security features into your Spring Boot application. Okay, so you can see this is the default security behavior over here of Spring Security with Spring Boot. So I hope you have been able to follow, and I hope you found this valuable. So we have our project up and running with Spring Security, and when we tried to access the hello endpoint, we saw this login page. Now, by default, Spring Security will authenticate all the endpoints that exist in our application. So even if I duplicate this URL, okay, if I duplicate this to hi, for example, and if I say hi over here, and if I change the message to hi, after running, I would also see that this request is, or this endpoint is also authenticated by default. Okay, so the default behavior of Spring Security over here is to authenticate everything. So if I say hi over here, I'm being redirected to the same login page over here. Okay, now the question is, how do you get past this login page? Okay, so here, if you come, you'd see the logs. Okay, so here on the logs, there is some information. So you should see here web application context being initialized. Okay, and here you would see the information around Spring Security, and here you can see. So you can see here UserDetailsService auto configuration. So this is coming in from Spring Security, and then you can see over here generated security password. So this is a password for us. Okay. And the message over here says that this password is generated only for development purpose. Okay. So this is the password for your application so that you can access it. Why are we getting this password? Because we haven't set any password yet. Okay. We haven't configured. So Spring Security saw that we have not done configuration, or there is no configuration provided. So what it does is it auto configures stuff with some default settings, and it provides you the password here on the console. And it leaves a message over here that this password is only for the development use only, and you need to update the configuration before running your application on production. Okay. And you would see a lot of logs over here are around Spring Security, which you would normally not find without security. Okay. So what I would do is I'll copy this password over here. This is our password. Come over here, paste the password. Now what is a username? So username by default is user. And I can say sign in over here. Now the moment I sign in, you can see hi over here, right? So I'm able to access the endpoint now. And now if I switch over to hello, you'll see I can access hello as well. Okay. So this is how you can get past that login form. Now I have logged in. I would want to log out, right? So we have a login page. So we also have a logout page over here. So if you say /logout over here, you will be shown this page over here, which is, are you sure you want to log out? And you have a huge logout button. So it's huge because I've zoomed in. Okay. It's actually not huge. This is the actual size, but just for the readability purpose, since I'm recording this, I have zoomed in. Okay. So I'll say logout, and the moment you log out, you'll be back to the sign in page over here. Okay. So let's talk about the observations from the default behavior. Okay. Now, what is the default behavior here? The first default behavior that we observed is everything after we add Spring Security into our project. Everything, like all the endpoints, are authenticated. Okay. And the default authentication that we have is form-based authentication. So this is a form-based authentication that we have here. Okay. Let me refresh this. So on refresh, you see this form here, right? Everything is form based. So that is why it is known as form based authentication with Spring Security, right? And these are inbuilt forms. Like, we have not designed this. This is being provided to us by Spring Security after we add the dependency. Okay. So that's the observation number 3. So one is everything is authenticated. Observation 2 is default authentication method is the form based authentication. Third is we have been given access to inbuilt forms for login and logout. Okay. This is the third observation. The fourth observation is there is a default user which is being created by Spring Security on the fly, and the password for the same is provided to us via the console. Okay. And it has a fixed username, which is user over here. Okay. The next observation would be if you try to access any URL, it's authenticated by default, right? And yes, I also want to show you the headers over here. So if you head over to network tab over here, okay, this is a network tab, and here you can see all the requests that are happening. Okay. So let me switch over to hello. Okay. If I go to hello, I'm being redirected to login. So you can see over here for hello, it says 302, which means it is redirecting it, and it's taking me to the login page over here. Okay. Now, if I log in, if I say user, and if I paste in the password, I'll sign in. You can see the headers over here. Okay. If you scroll down here, okay, or let me show you the payload over here, or let me scroll down here only. Okay. So now let me show you the headers. So if you select this request and if you scroll down here, okay, you should see some headers like X content option, X frame option, X SS protection. Okay. So all these are headers, and these are being provided to secure your application. If you go to payload, you'll see username, password, and also the CSRF value over here to prevent the CSRF attacks. Okay. So this is the CSRF value. If you don't know what CSRF attack is, don't worry. We'll talk about everything. Okay. But for now, just remember you saw this value here in the browser under payload. Okay. So yeah, that's the default behavior of Spring Security. And one more thing I would want to talk is here right now, our password starts with 5810. Okay. If you restart the application, so I restarted the application, this password will change. So if you scroll up, you can see the password has changed. So with every restart, since this application is not having a configured username and password, this password is being generated in memory. Okay, and it will change on every restart. So this is something that you need to keep in mind. Okay, so if you restart the application, don't try to use the same password that you had earlier. You should update the password. Okay, so yeah, that's about the default behavior of Spring Security. So I wanted to take a moment and explain what's happening in the logs. And by taking a look at the logs, we would be understanding as to how this entire auto configuration with Spring Security is working behind the scenes. Okay. So if you scroll down over here, okay, you'll see like all the logs around Tomcat server and everything over here. Okay. If you scroll down further here, you'll see something coming in from UserDetailsService auto configuration. Okay. So UserDetailsService is the class, or I should say it is the implementation that makes sure that your user details are being managed into the Spring Security. Okay. And after seeing this onto the console, you'll see the password being printed over here. Okay. And if you scroll down further, here you're going to see like Global Authentication Manager being configured with UserDetailsService bean. So all these beans of Spring Security are coming into action. You can see InMemoryUserDetailsManager, which means that this user that is being created exists in memory only. Okay, and it is being temporarily provided to us over here. Okay, and here then if you scroll, you can see all the filter chains over here. Okay, so filter chain, like it is a series of filters. So you can see a lot of filters being printed over here. Okay, and you can see over here, this is the default security filter chain that is coming in. Okay, you can see disable encode URL filter. There are quite a few. The CORS filter over here, you can see the CSRF filter to prevent any CSRF attacks and intercept the CSRF token value that are being sent from the browsers. You have logout filter. You have username and password authentication filter. Okay, so this is a filter that will do the job of extracting the username and password from the request. Okay, so if I have to talk about the important filters over here, okay, there is a authentication filter. Like there are quite a few. If you scroll down over here, you'll see authorization filter. Okay, this is the authentication filter, username password authentication filter. Okay, and authorization filter and username password authentication filter together, they do the job of authenticating user and also authorizing the user. Okay, and then you have CSRF protection filter, which I just showed you. CSRF filter over here. This is one important one. There should be one around session as well. So if I say session over here, session, okay, session filter, we don't see it being printed. Okay, but that is also a filter that exists. Okay, but these are the list of filters that are being printed. Okay, and there's nothing you can do about it, but yeah, this is just for information purpose, and it validates our learning as to what we are learning is actually what we are seeing over here. Okay, and yeah, rest of the logs are generic Spring Boot application logs. Okay, so yeah, that's about the logs that you see, and I hope this was useful. So when working with Spring Security, you have a password that is being provided to you automatically. Now this password starts with 522D, and if you restart, the password is going to change. Okay, so what is happening is every time you restart the application, a new in-memory user is being created and the password is updated for the same, and that is what is being shared. Now, if I'm doing some sort of development, I don't want to keep changing my password and refer to the console for this, right? So there is one configuration that you can do into your application using which the password will become static. Now to make that change, I'll head over to my application, and here under resources, I'll go to application properties. Okay. Now here, what I would do is I would say spring.security. I can say user.password here. Okay. And I can type in my password over here. So my password is password itself, or password, whatever you want to add over here. Okay. You can even configure your username. So I can say spring.security user.name over here. And I can call this user as admin. Okay. So yeah, let me restart this and let us see how these changes come into effect. Okay. The application started. If you scroll up now, you won't see any default password being printed, right? And the reason for this is because you have provided the password yourself. Okay. There was one log from UserDetailsService into here, into the console. You are not seeing that log as well. Okay. So if I switch over to the browser and if I say admin and if I say password over here, if I say sign in, okay, it failed. Okay, so I re-entered the password and it worked. Maybe it was a typo from my end when I typed in the password for the first time. But let me just clear the cookie over here and let me show this to you again as to what happened. So if I go to, so if I say hi over here. Okay, so the request is authenticated. Let me just clear these sessions over here. Okay, so I cleared the cookie. Okay. And now you would see that I'm being taken to login page again. If I say hi over here, okay, I can say admin and I can say password over here. I can say sign in and I'm being taken to hi over here. Okay. If you go to the root URL, you will see the error that you were seeing earlier, because you are seeing this error because this says white label error page, because there is no way that you're handling this error. So that is why you are seeing this default error page. But here you can access all the endpoints. Okay, you're authenticated. All right. So this way you can configure the static username and password into application.properties. Now, one thing I would like to mention over here, adding username and password into your application properties is not the right way to do things. Okay, there are a few important considerations. This is not the secure way of doing things. Okay, if you're doing some POC or if you're working on a local environment, doing some development, and for the sake of convenience, if you're adding, that's completely fine. But you are not supposed to configure your application username and password this way and push the code to production. Okay, this is not the secure way of doing things. Okay, so just giving this disclaimer over here. I'm just showing you this option because if you're doing development, it's important that you are aware of this option. And if you want to take a shortcut, like quickly check something, you should be able to configure this and have the ability to bypass the login form at least. Okay. So yeah, that's about configuring static username and passwords with the help of security configurations. I hope this was useful. So now it's time that we go through the internal working of Spring Security. So this is a diagram that I have open here, and here you can see like we have filter chain, we have authentication filter, authentication manager, provider, password encoders, and user details service. So this is a diagram and this is a flow as to how it works. But what I'm going to discuss now in this video is we are going to actually take a look at these classes. We are going to take a look at the code and we are going to see the entire flow in action, possibly with the help of a debugger. Okay, so we are going to attach debugger at various parts in the code, and then we are going to run it in the debug mode, and we are going to see how the entire flow happens and what are the things that are happening behind the scenes. Okay, so this will give you a deep understanding of how Spring Security works. So let me give you a refresher of this diagram here. We have request coming in, and this is intercepted by a set of filters within the filter chain. We have one filter, which is authentication filter here, okay, which delegates the job of authentication to authentication manager, okay, and authentication filter will create the authentication object with the credentials, of course, and here authentication manager will get the provider, and with the help of authenticate method, the provider will make sure, like it will assemble user details service and password encoder, and user details service will get the user by username, and password encoder will help us match the password in the encoded format. And then the user is authenticated. If he is, then authentication filter will update the security context over here. Okay. And the user will be authenticated and the request will flow on to the dispatcher servlet or the controllers, you can say. All right. So this is the entire flow. And if you come over here to like the IntelliJ, I have some internal classes open. Okay. So now to open the internal classes, you need to enable a setting here in IntelliJ. Okay. So you need to head over to the preferences here, settings, and under build Maven, and here you need to select importing, and under importing you need to select all these three, like sources, documentation, annotation. And once you have done that, you have to make sure you refresh Maven. Okay. So let us go through this here. So the first class I have open over here is authorization filter. Now what is this authorization filter? You can see the documentation here as well. An authorization filter is a filter that restricts the URL. Okay, so since we are making use of Spring security, it's important that the URLs are restricted. Okay, restricted means they need some kind of access or some sort of authentication to be accessed. Okay, and that is what happens with authorization filter. So here you can see, if you scroll down, okay, in the authorization filter we have this method toFilter. Okay, and it is being overridden. Okay, so it's coming in from generic filter bean. Okay, and here, so if you go inside generic filter bean, let me go inside over here. Okay, so you can see this is a simple base implementation of filter. Okay, so this is simple base implementation of filter. So if you want to create any filter, you need to make use of this generic filter bean. Okay, and that is what authorization filter is doing, because it's a filter, right? And whenever it does that, it needs to override toFilter here. Now if you take a look at toFilter, there is request and response object, like servlet request and servlet response object that is being passed in, and here starts the game. Okay, so from here everything begins, wherein the checks are being done. Okay, and the process is started. Okay, for authenticating and authorizing the request. Okay, now what happens is, first the request is intercepted by authorization filter, and then there is another filter which comes into action. So this is a filter which is the name of the filter is username password authentication filter. Okay, so if you take a look at the documentation over here, okay, so you can see over here it is responsible for processing an authentication form submission. Okay, so whenever you are submitting a form, so form meaning login forms, okay, a username and password it has, right? The login form will have username and password, and that is what is being processed by this particular filter. Okay, and here if you scroll down, you can see you have attempt authentication method, and within that you can see here username is being obtained, password is being obtained. Okay, you can see, and then with the help of user password authentication token, okay, the authentication process is being done. You can see over here. Okay, now if you read this code over here, okay, here you can see this line here in the end. Okay, so first the details are set. Okay, and then you can see this line where the authentication manager is being called over here. Okay, so if you take a look at the diagram, authentication filter. So this filter, authentication filter, is nothing but username and password authentication filter. Okay, and then the authentication manager is being called. So here you can see authentication filter calls the authentication manager. Okay, now authentication manager is the one who is responsible for processing the authentication request, and it delegates the actual authentication to one or more authentication providers. Okay, now if you see over here, it is calling the authenticate method over here. Okay, so if I press control or command over here, then you'll see this turning into link, and if you go over here, it takes you to this particular interface, which is authentication manager. Okay, and if you scroll up over here, you can see attempts to authenticate the past authentication object. Okay, so you know what authentication object is, right? And this would return a fully populated authentication object, including granted authorities if successful. So what this means is authentication manager is responsible for getting the job done for authenticating a user or authenticating a object over here. Okay, and if the authentication is successful, of course it needs to update the authentication object with the authorities. Now what I mean by authority Authority means the roles, like a user might have a admin role or a super admin role. So all of that needs to be populated into authentication object over here. Okay. And here there are more details over here. Okay. But if you see over here, it is accepting the authentication object. Okay. And here you can see here auth request. Okay. So it's passing in the object of auth request, and here it is accepting the object of authentication. So you would say, what is auth request over here? So if you click on this auth request is a object or a type of username password authentication token. Okay. Now what is this? You will ask me question that, hey, you said that the credentials are being represented, or a user is being represented with the help of authentication object, right? But here we are seeing a different class altogether, username password authentication token. So it's not this different class. If you go inside this class, okay, you would see that it is extending abstract authentication token. And if you go inside this, you will see that it's implementing authentication over here. Okay. And what is authentication? So authentication is a way in Spring Security to represent the details of the user, like the principal, whether the user is authenticated or not, or what are details of the role and all. And you can see all of that over here. You can see authorities. Okay. You can see the details of the object. You can see whether it's authenticated or not. All of that you can see. Okay. And it's coming in from authentication over here. And authentication is something that we just spoke about. Okay. So what is happening is this is actually a type over here. So if you scroll down, okay, if you scroll down here, not here, okay, if we were in this class, okay, so if you, I'll just close this, okay, authentication token over here. So if you scroll down over here and if you see this object type, this is being passed in to the authenticate method. Okay, so the authentication manager is being called actually, and it is being called with the help of authenticate method, and it is being given the object of type authentication. Okay, so authentication type is the object because this class is inheriting from the authentication interface. Okay, so yeah, this is how it works. And if you click over here in authenticate, you'll see we are being taken to the authentication manager. Okay, and it needs the object of type authentication. Okay, now if you select this and if I press Control B over here, okay, so this is going to give me all the implementations of authenticate over here. You can see so many classes are implementing authentication. Okay, you can see over here InMemoryUserDetailsManager and so on, Provider Manager and so on. Now what will happen over here is a implementation of Authentication Manager, which is nothing but the Provider Manager. Okay, you can see this Provider Manager is an implementation of Authentication Manager. So this will be called over here. Okay, and what will this do? You can see over here the documentation. It will iterate the authentication request through a list of authentication providers. Okay, now whenever you are building an application, there will be multiple providers. Okay, now what I mean by provider is a way to define as to how the user details will be fetched. Okay, so you might be fetching the user details from a LDAP server, from a custom database. Okay, so depending on that, you will have a provider created, and you will be telling the application that, hey, this is how I'm fetching all the data. Okay, so there is a possibility like there might be more than one provider depending on the complexity of the application. So what would happen is this particular provider manager over here will iterate through the authentication request, and it will check if it can authenticate that request against a list of providers. Okay, and you can see over here authentication providers are usually tried in the order until one provides a non-null response. Okay, so if one provider is able to authenticate it, it will pick that provider and it will go ahead with the authentication. Okay, and you can see all the descriptions as to how this works. Okay, so if no subsequent provider provides a non-null response, the last authentication exception received will be used. Okay, so this is how it works. And if you scroll down over here, this is provider manager class implementing authentication manager like we saw. And if you scroll down, here is the authenticate method that it's overriding. And with the help of this authenticate method, what it's doing is here, if you see, it is calling all the providers. So it's saying get providers. So it gets the list of all the providers, and it is making use of authentication provider over here. Now, what is authentication provider? It's an interface. Okay, so every provider has to implement this interface. Okay, So it's getting the type of all the providers over here, and it is iterating through it, and it is checking if any provider is able to authenticate this object over here. Okay. Now, if you go over here, okay, so if you click on this and if you say Control B over here, you can see Authentication Provider here. Okay, this is the interface that we are in. Okay, and if you select Control B over here, okay, you can see these two are the ones that are implementing it. Okay, Provider Manager and Authentication Provider. Okay, now when you make use of Spring Security, there is a inbuilt authentication provider that is being made available to us, which is known as DAO Authentication Provider. Okay, this is the inbuilt authentication provider. You can see over here an authentication provider implementation that retrieves the user details from the user details service. Okay, and here you can see this is DAO Authentication Provider. Okay, and if you scroll down over here, it has a method. You can see additional authentication checks, and over here it is doing the job. Okay, this check over here is to match the password. Okay, but first it will fetch the user details. So if you scroll down over here in retrieve user, it will make use of user details service, and it will load the user by username. Okay, this is something that we saw over here. Okay, load the user by username with the help of user details service. Okay, so user details are loaded. Okay, and right now in our application, we don't have any database configured. Right, so what will happen is, if you scroll over here, okay, there is a class which is inbuilt. It is known as InMemoryUserDetailsManager. Okay, so if I say Control Alt and P on this method, load by username. Okay, so I'm on load by username. I've selected this, and I'm selecting Control Alt and P. So this is giving me all the implementations of this method over here. Okay, and you can see these are the implementations that are available. Now you can see caching user details service, in-memory user details manager, JDBC DAO implementation, and so on. But we need to take a look at in-memory user details manager. Now what is this? So in-memory user details manager is doing the job of fetching the users from the memory. So right now we don't have any database configured, right? We don't have anything right now. We have just configured the application with Spring Security, and there is a user being created by default. So whenever you create a application, okay, and there is a user created by default, so that is being created in memory because there is no database configured, right? So in that case, what is happening is in-memory user details manager comes into rescue, and the job of this is, if you scroll up, you can see non-persistent implementations of user details manager, okay, which is backed by an in-memory map. So it is making use of in-memory map, and it is creating the user for you in memory itself. Okay, and it is fetching the user from the memory over here. So this class is helping in that. Okay, and then once the user details is fetched over here, if you scroll up, okay, this particular thing happens. Okay, so additional authentication checks, the password is being matched. Okay, so if you take a look at this diagram here, with authentication provider was with the help of password encoder makes sure that the password is being matched. So here you can see that code. Okay, here you can see that this .password encoder. So the job of matching the password over here is being done. So presented password, it is being matched with the password that is being retrieved in the user details object. Okay, and depending on the output is shown. So failed to authenticate since password does not match, and all of that. Okay. And if the password matches, then what happens is the authentication object is being created. Sorry, the authentication object already exists, right? So the authentication object is updated, in fact, and updated with the authentication flag being marked to true, which means the user is authenticated now. Okay. So this is the entire process. Now, once this validation is done, the context is updated, okay, to mark the user as authenticated. All right. Also, I wanted to show you one class over here. So you can see here, this is the class default login page generating filter. So this is also a filter, okay. And what this filter does is, you can see over here, if you scroll up, it is also extending the generic filter beam. And this is a class that is responsible for generating the HTML that you are seeing, okay. So you can see generate login page from HTML. You can see this entire HTML over here. So this is the HTML that you actually see in the browser over here. Okay, so the code is being provided in the libraries itself, and there are filters being written for this. Okay, So if there is no login form that is found in the application, this filter comes into picture and it does the job of displaying the login page. Okay. Now what I would do is let us run this application in debug mode and let us see this entire thing in action. Okay. So I'm in debug mode and I'll come over here. Let me refresh this. So the moment I refresh, you can see here, okay, default login page generating filter. So this is being called because the first thing, okay, it needs to generate the filter. Okay, let me do forward over here. Okay, now you can see this particular authorization filter. We are in authorization filter over here, and you can see we have the servlet request and response over here. Okay, now if you go forward, okay, you'll see this being called a few times. Okay, and yeah, the login page is over here. Okay, so login page is over here. Now what we need to do is let us log in and let us see what happens. So the page is generated with the help of the login page, default login page generating filter.java over here. Okay, and now I can say password over here. Okay, wait a minute. Let me enter the right password. Okay, I've typed it properly. And if I say sign in over here, you can see over here, the first thing happened is username password authentication filter.java is being called. Okay, and you can see here there are two variables. So this is a username and password that I've entered. Okay, and you can see the request and response over here. Okay, so what happened is, you can see, I'll collapse this code a bit. This code is responsible for getting the username. So you can see this is getting the username and this is getting the password. Okay, and we have a breakpoint over here. You can see. So this way password and username are being fetched. Okay, then what happens is the details are being set over here. Okay, and then this authentication manager is being called. So if I go forward again, you can see auth request is being created. So this is the authentication object over here. Okay, this is the type of username password authentication token, and you can see it has a principal. So what is a principal? You can see there's a principal over here. So principal is simply representing the currently logged in user. Okay, so this user is not logged in, but it's attempting to authenticate itself, right? The authentication is not done yet. Okay, you can see this flag over here, authenticated is equal to false, which means the authentication is not done yet. Okay, the authentication object is created, but it's not authenticated yet. Authorities is null, 0 right now, because like since it's not authenticated, there is nothing to be added. Details also null, and credentials you can see over here. The credentials are being added over here as well. Okay, now I'll go next. The next thing over here comes is, so what happens is in this filter, we called the authenticate method over here, right? From the authentication manager. So here we stopped at provider manager directly. Okay, so if you see over here, this is the authenticate method over here. Okay, so this particular thing is being called, and here what will happen is it will iterate through this and it will check that for which provider this will work. Okay, which provider can authenticate this object. That is what it will check over here with the help of for loop over here. You can see. Okay, so here you can see the size of provider is 1. Okay, so if you go over here, since we have not defined any providers, you can see the size of provider is only 1. Okay, and this is the inbuilt default provider over here that is coming over here. Okay, we are not able to see the information here, but this is the inbuilt authentication provider into picture. So I'll say resume over here. Okay, resume again, and now you can see it is, okay, 1 second. So after doing this, it has found a match. It has found a provider that can authenticate this, and it has come inside over here. Okay, so now it's trying to authenticate this with the help of the provider. Okay, and if you take a look at the variables over here, okay, so this is a provider object. Okay, 1 second. So if you scroll down, this is the provider object on which the authenticate method is being called. And if you hover on this provider, you will see it's of type DAO authentication provider. Okay, so if you scroll down over here, provider is of type DAO authentication provider. You can see DAO authentication provider. Okay, and that is the type of object because that is by default available and we have not defined any provider on our own. Okay, so that will do the job of authenticating this. Okay, now I'll say next over here. So one thing is confirmed, authenticate method is being called on provider. Okay, and which is the provider right now in action? DAO authentication provider, which is inbuilt. I'll say next or resume. Now what happens is we are inside DAO authentication provider here. Okay, and you will see here this particular thing, retrieve user is being called. Okay, I'll just collapse this, retrieve user, and with the help of user details, okay, we are trying to get the load user. Okay, we are making this call load user by username, and we are trying to get the user details object over here. Okay, you can see the username is admin over here because that is a username that we have entered. Okay, you can see the authentication object is being passed over here as well. So it's still available. It is being passed to everyone. Okay, whoever is coming in is taking this authentication object and doing their job. Okay, and in the end, this authentication object is being updated, right? Now I'll say resume again. The moment I resume, I am straight away being taken to InMemoryUserDetailsManager over here, where I have a breakpoint. Okay, and you can see load user by username. So this is what is being called. Okay, and here there is a method which will help us get the user details object with the help of username. Okay, and you can see over here. Okay, so this is being called, and I'll say resume. We'll go to the next breakpoint, and you can see over here the next breakpoint is in the DAO authentication provider itself. So here this was the first breakpoint where this particular thing was being called within retrieve user method, and now the user is retrieved. Okay, user is retrieved. Now we need to match the password. So we have two users now. One is from the in-memory user which exists in the application, and the other user credentials are coming in from the request. So now the match would be done. So here you can see the presented password is password. Okay, in user details object you can see over here. Okay, this is not encoded as of now. Okay, ideally the passwords won't come this way, but we need to configure this. But right now the password is readable. Okay, this is coming in from the application. This is the user details object that is coming in from the Spring Security. Okay, you can see org.spring-framework security core user details.user. Okay, so this is the object of inbuilt user. Okay, so you can see different properties over here: username, password, authorities, account non-expire, account non-lock, and so on. There are so many flags as well, so you can make use of these flags as well. Okay, and there is the authentication object which is being marked as false yet. Okay, now if I say next over here, you can see I'm being taken to authorization filter again, but let us see the authentication object over here. Okay, do we have access to the authentication object? Okay, no, we don't have. All right. So right now I don't think we have the access to authentication object, but authentication was done. Okay, and it's successful now. And let me say forward over here. Okay, or what I would do is I would just go ahead. Okay, so this is being crafted, and here if you come now, okay, we are being redirected to the home page. Okay, because so there is no mapping on the home, but if I go to hello, okay, since we are in debug mode, we are again seeing this being attached, debugger being attached. Okay, but here you should be able to access the hello thing over here. So you can see I'm able to access hello, which means that it's working fine. Okay, and I have been authenticated right now. All right, so this was the entire process as to how authentication happened. Okay, there was a reason why I showed you all of this internally, the internal working, the source code, so that you understand how things are working internally. Okay, so I'll tell you one thing. It's important that you understand the internal working over here. Okay, and the reason is all these things that you learned, like the authentication object, the authentication manager, all of this you will be hearing really frequently if you're working with this framework. Okay, provider manager, authentication provider, DAO authentication provider, all of these things you will hear really frequently if you're working with this framework. If you're going for interviews, preparing for interviews, you will be asked questions around these. So it's important that it's clear in your head as to how the entire flow is working. Okay, and I have taken a bit of effort also to put this into diagram. Okay, and also to explain this via source code. Okay, so this is what you exactly just saw with the help of source code. A request coming in, you had authentication filter, which was the username password authentication filter. You had authentication manager. Okay, then with the help of authentication manager, we had DAO authentication provider. We can have more authentication providers as well, but right now by default we had DAO authentication provider, and we saw password encoder, user details service, and we saw the entire flow as to how this entire thing worked. Okay, and based on this, the user was authenticated. So this flow is, it's important that you understand what is the role of whom. Okay, who does what in the entire chain. Okay, once you understand that, like, it will be really easy for you going forward and also for the interviews. Okay, so yeah, that's about the internal workings of Spring Security. I hope you enjoyed this and I hope this was valuable. So now we are able to access the API over here, which is the hello endpoint, and I'm logged in over here. Okay, now if I want to invalidate the session, or if I want to invalidate, or if I want to log out, let's say, I can head over to this URL over here, okay, /logout, and I'll be shown this default logout page, and I can hit logout over here, okay, and I'll be signed out of the session. Now if I try to access hello over here, okay, I should see the login page again, and I will be redirected to login, whichever endpoint I try to access. Okay, and this logout page is being generated using logout page generating web filter over here, which generates the default login page. You can see over here, generates the default login page. Okay, so that's how you can log out from the application. So if you configure Spring Security into this project, you are being presented with this login form, using which you can log in, and you also have a default logout page, using which you can log out of the application or the session in the browser. Now, whenever you are working with APIs, okay, you won't be making use of browsers all the time, right? You'll be making use of a tool or a client called Postman. So in that particular case, how would you get this authenticated API working with Postman? So that is something that I'll show you. So here, if you switch over to Postman, here, this is the interface of Postman. I'll first create a workspace over here. So I'll say secure notes project. So I already have a secure notes project, okay? But I'll create a new one for this video, and I'll say create the workspace. You can see this workspace is created, and it's asking me for how you want the workspace to be. So I'll say blank. I'll say next. Okay, it's asking me for name over here. Okay, and what was that actually? So, okay, that was nothing actually. So if you see over here, this was a search bar. Okay, I accidentally thought it's the text box that is allowing me to create the workspace. But never mind, you just create on this button over here, say next, and enter secure notes project over here. Who do you want to share it with? Okay, depending on your options or depending on your requirement, you can select the options. I'll say only me, and I'll say create. Okay, so we have this fresh new workspace created. Now over here, I'll say create a new collection, and I'll say secure notes API. Okay, I'll say secure notes API here. I'll add a request, and this will be the first request for hello. Okay, so I'm going to say localhost, or let me copy the URL here from here. Okay, I'll copy this URL. I'll paste it over here, and instead of login, I'm going to say hello over here. Okay, it's a GET request, of course. Now, if I say send over here, okay, you will see I'm getting 401 unauthorized. Okay, this would not have been the case if we had not configured Spring Security into the project. Okay, now to get rid of this, what I need to do is I need to authenticate the request. So here there is a auth tab. Okay, so I'll just collapse this. In fact, you can go to authorization over here. Here you'll have different options. Okay, so I'll select basic over here. The moment you select basic, okay, let me hide this. You're being presented with this form over here. Okay, and there's a warning like these parameters hold sensitive data. Okay, so you are entering sensitive data. This is something that you're supposed to keep in mind. Okay, this is not recommended, but I'm just showing you a way. So you're entering username, password over here. This is our username, password, like user and password. And you can then say send over here. Okay, all right, it did not work. So 1 second, let me see what happened. So I'm still getting unauthorized, and let me check what's wrong over here. So I'll head over to application.properties. Okay, so the username is admin, and I forgot that. Okay, so it should not be user, it should be admin. Make sure you're entering the right credentials and password. And if you say send over here, you'll see hello as a response. Okay, so what is happening is you're making use of this form presented to you by Postman, And what Postman is doing is it is creating the authorization header based on these credentials. Okay, and this header is being passed on with the request. So if you want to get into the details of the request as to how that is encoded, you can see the console option over here at the bottom, and you can click on this. So this will open up this console and it will give you the list of all the requests that you have done. So this was the first request. You can see it was unauthorized over here. And then you take a look at the second request, which had 200 success. Okay, here. And you can see over here, authorization header is mentioned over here. So you can see basic, space, and the value over here. So this is being encoded. So the credentials are being encoded and it is being sent this header in this format to the server. Okay. And if you copy this, okay, so this is base64 encoding, which is an algorithm or which is a way to encode things. So here I'm on this website, base64decode.org. Okay, there are many websites. You can just Google around like base64 encode decode and you will see several websites. Now if I paste this thing over here and if I say decode over here, okay, you can see this is my username and this is a password. So admin:password. That is how it's being sent to the server, and server will decode this and it will validate the request. Okay. Now we have not written any code to convert this or to decode this. This is all being handled by Spring Security. Spring Security is smart enough. So you can imagine so many things have been inbuilt and have been given to us in a pre-built form. Okay. We don't have to do anything. We just have to configure and we are ready to go. Okay. So yeah, that's about Postman and how things work with Postman. Now, ideally, this is not recommended sending requests this way, but if you're working on a POC or in some sort of development environment where there's a need for you to make use of Postman and you don't have tokens configured yet, okay, and if you want to make use of form-based authentication in this way, then this is a way that you should know, okay, but keep in mind this is not recommended. You can see a warning icon also over here, okay. So I hope you have been able to follow and I hope this was useful. So let's talk about the filters that you should be aware of. So I'm going to touch upon a few important filters that exist, okay? And this would help you with interviews and the in-depth knowledge about the Spring Security framework, okay? Now, the first filter that I'll talk about is its security context persistence filter, okay? Now, this is a filter that is responsible for managing the security context of each request. So it retrieves the security context at the beginning of the request and stores it at the end. Okay. So you can see over here, this is the package and the class, I should say, where it exists. This filter exists. Okay. Next one we have is Web Async Manager Integration Filter. Okay. So this integrates the security context with the Spring's Web Async Manager for asynchronous web requests. So if there are any asynchronous requests that are coming in, this is a filter that will be in work, and you have the package in which it exists on the screen. We have header writer filter. Okay. Now this particular filter is responsible for adding security related HTTP headers to the response, and the headers that it can add is X content type options, X frame options, and XSS protection. Okay, so there will be scenarios wherein you need these headers to be added, and that is when this filter comes into action. Okay, and you have the package and the location of these filters on the screen for everything that I'm talking about. Okay, CORS filter. So this particular filter handles the cross origin resource sharing, which is CORS, by allowing or denying requests from different origins based on the configured policies. Okay, so if you have a front end being hosted on a different server, then you will get, your backend will get a request from a different origin, right? Because the server would be different, right? So in that particular case, you need to configure CORS settings in your application, and you have this filter that is responsible for working with that. Okay. You have CSRF filters. Okay, so CSRF is a kind of an attack, and Spring Security has an inbuilt protection against that attack. And we have this filter inbuilt, which enforces the cross-site request forgery, which is CSRF protection, by generating and validating CSRF tokens for each request. Okay, so this is automatically done and handled by Spring Security Framework, but this is a filter that you should be aware of. We have logout filter, of course. So you have the logout process whenever you integrate Spring Security into your application without even writing a single line of code. You have the logout functionality built in. So this particular filter manages the logout process by invalidating the session, clearing cookies, and redirecting the user to a configured logout success URL. Okay, so this is the inbuilt filter. Then you have username password authentication filter, and this filter will process the authentication request for username, password, credentials, and all, and it will handle the form-based login process. Okay. So yeah, this is the filter that we have. Then you have default login page generating filter. So this is a filter that generates the default login page if there is no custom login page defined or there is no custom login page provided to your application. So this exists and this is inbuilt. If there is no login page found, this filter comes in action and it gives the default login page generated. You have default logout page generating filter. Okay. So this filter will generate a default logout page if there is no custom logout page provided. So if you configure Spring Security into your application and if you head over to /logout URL without doing any configuration changes, you are going to see a logout page appear. And this particular filter is going to help you with that. Okay. So that page that is generated, that page is being generated by this filter. Then you have basic authentication filter. So this particular filter handles basic authentication by extracting the credentials from the authorization headers and passing them to the authentication manager. Okay. Then you also have request cache aware filter. Now this particular filter ensures that the original requested URL is cached during authentication so that the user can be redirected to it after successful authentication. All right. So that's the role of this filter. Then you have security context holder aware request filter. So this particular filter will wrap the request to provide security related methods. And there are a few methods that I have on screen is user enroll, get remote user, and so on. So these are the methods that are helper methods. And these methods can help you interact with the security context. You also have anonymous authentication filter. So this particular filter provides anonymous authentication for users who are not authenticated. And this is useful. Basically, anonymous authentication is useful to apply security constraints even to unauthenticated users. All right. You have exception translation filters. Okay. So this particular filter will translate authentication and access related exceptions to appropriate HTTP responses. And this particular thing is like there might be different things involved, like redirecting to the login page, sending a 403 forbidden status error or something else. So all of that is being handled by this particular filter. Okay. Then you have filter security interceptor. So this particular filter will enforce the security policies, and whenever you have a request, these policies are enforced on them. Okay. And this is a filter that is responsible for making final access control decisions based on whatever configuration is there. Okay. So these are some of the filters that exist. Every filter, like you can see, has a unique role in this amazing framework. Okay. So I hope this was useful. Okay. Also, I want to talk about why learning these filters are important. Okay. So learning this filter and their roles is important both from an interview and a practical knowledge standpoint, especially if you're aiming for a role that involves Spring security or web application security in general. Okay. Now, this knowledge that you gain can help demonstrate the in-depth knowledge you have. It can also demonstrate the problem-solving skills, because knowing this filter can help in troubleshooting and solving security-related issues. Interviewers will often look for candidates who can quickly identify and fix problems. Okay. Also, with respect to the first point, wherein you are demonstrating the in-depth knowledge. So with in-depth knowledge, you will be able to explain the purpose and the function of each filter. And it shows that you have deep understanding of Spring Security Framework and how it works. Okay. Also, you will be able to do any sort of custom configurations because you know all the inbuilt classes, or major inbuilt classes, I should say. Okay. And also, one of the benefits that this has is security best practices. So understanding these roles of filters means you are aware of best practices in web security, such as CSRF protection, what is course management, how it can be managed, how it is currently being managed in the Spring framework. also proper authentication flows and everything. So all this knowledge is crucial for designing the secure applications. Okay, and this can help you with effective configuration. Like it can give you the ability to configure Spring security applications effectively. It can enable you to make right customizations in your application, and it can also help you with troubleshooting in case anything goes wrong, because you know how these filters interact and where to look for if there are any issues, and this can save you a lot of time. Okay, so that's about some important filters that exist in Spring Security Framework. So let's talk about JSession ID and how Spring Security Framework manages session and how the entire flow works in the browser. Okay, so I have this browser open. I don't have any tabs open over here yet, or I have not loaded anything over here, but I have a incognito mode within Google Chrome over here. Okay, so what I'm going to do is I'm going to right click and I'm going to head over to inspect over here, and within inspect I'm going to click over here. So depending on your settings in the browser, you might either see this pane appear on the right hand side or at the bottom. Okay, and you can click over here, and what I would do is I go to application, and here I will have the cookies tab selected over here. Okay, now what I'm going to do is let me load the URL over here. Okay, so I'm loading this /hello endpoint, which is localhost:8080/hello. Now the moment you go over here, okay, you would see, so now over here inside network, you can select the cookies tab, and under cookies, you're going to see this option over here. So let me expand this a bit. Okay, so here you can see localhost:8080. So if I select localhost:8080, you are going to see a value over here. Okay, so this is not readable much. So let me do a thing. Let me move this to the bottom over here, something like this. Okay, so I have this up here on the bottom. Okay, so if you want, you can change these settings by clicking over here on the three dots, and you can change this dock side over here. Okay, so I've taken this to the bottom of the screen, and now over here, I'll just repeat under application, under cookies, you're going to see localhost:8080. Okay, and under this, you have this value appear suddenly, which is JSession ID. So this value was not there earlier before you load this page. Okay, so this is the cookie that is being created, cookie named JSession ID. Now, what is JSession ID? So JSession ID is a unique identifier that is being used by Java web applications to manage sessions. And when a user interact with a web application, the server creates a session for that user, and the JSession ID is used to identify and maintain that session across multiple sessions. Okay, so this is being created. Now, this is a value. So it starts with something and it ends with something. Now, if I enter my credentials, so if I say, let's say admin, and if I say password over here, okay, and if I say sign in, you'll see that the JSession ID value has changed over here. Okay, and I can see the output over here. You can see hello is being reflected over here. Now, if I go to any other URL over here of the application, if I say hi, I'm not going to be asked for the credential, and that is because of this session, because this session is being maintained over here. Okay, now if I try to edit this value, okay, if I change this value, let me edit any random string over here. Okay, and let me go to hi again. You'll see that I see a login page over here again. Okay, that is because the JSession ID was modified by me. Okay, so this is how the web application along with Spring Security Framework manages the session in the browser, and with the help of this session value that you have over here, which is JSession ID, you are able to access multiple requests without authentication, because once you authenticate, you are in the authenticated mode over here in the browser, is what I could say. Okay, so for example, if you are accessing Gmail, okay, you can open Gmail in multiple tabs and you would be asked for sign in, right? And you can even navigate through multiple pages without signing in. You have to just sign in once, right? It's not like if you try to open a mail, you have to enter username and password again, right? So that's all works on the concept of session and cookies. And with Spring Security and our web application, that is how it's working over here. So this is the value that you will also see in your browser. Okay, so I'll close this for now. Okay, so I hope you have a clarity as to how JSession ID works over here. And I hope this was useful. So now it's time that we talk about basic authentication and understand what it is. So what is basic authentication? Basic authentication is one of the simplest form of authentication supported by Spring Security. It involves sending the username and password with each HTTP request in the form of authorization header. And the credentials that you're sending as a part of authorization header are encoded using base 64 and sent over the network. And Spring Security on the other end will decode this and validate these credentials. Now let us try to understand how this entire thing works. So first, what would happen is you would have the credentials here in this particular format. So credentials are assembled in this format wherein you have the username and password, and they would be concatenated using a colon in this form that you see on the screen. And then what would happen is these credentials in this form would be encoded using base 64. So base 64 encoding would be applied onto this credential. Now what is base 64? It's a type of encoding that exists. Okay. Now after encoding, you will get a value, okay, which will be base 64 encoded. Now this particular value is being passed in the authorization header in this particular format. Okay. So what would happen is within authorization header, basic keyword would be mentioned, basic space, and then this base 64 encoded value would be mentioned over there. Okay. So this is a format in which this header is being passed on to the backend. And what backend would do is, backend, I mean Spring Security or your web application, it would intercept this request. It would look for the authorization header. It would look for the base 64 encoded value. It would check for this value, and it would validate it against the actual password that exists. Okay. And if the credentials are valid, the server processes the request and returns the appropriate response. And if the credentials are invalid, the server would return a 401 status code error, and that error code stands for unauthorized response. Okay. So this is how the entire flow of basic authentication works. Okay. You have username : password, which is passed through base 64 encoding. You get a base 64 encoded value, which is then being passed in this format, basic space, base 64 encoded value in the authorization header to the backend. Okay. And this is being done for every request. So this is what basic authentication is, and it's working. So now it's time that we go hands-on with basic authentication. Right now, the authentication method that we have configured is the form-based authentication, where we are seeing a form like this whenever we try to access any URL in the application. And since this authentication method is driven by HTML forms, it is known as form-based authentication, but we need to switch over to a basic version, like without form-based authentication. And that is where basic authentication comes into picture. Because we are normally working with REST APIs, and form-based authentication is not what you would do when you're working with REST API. So what I would do is I would switch over to IntelliJ, and I would press Shift 2 times. And I'm going to switch over to a inbuilt class. I'm going to say Spring Boot Web Security Configuration. Okay, so you can see this class over here that appears. Okay, so this class that appears in org.springframework boot auto configure security servlet. We'll go inside this class. This is an inbuilt class over here. Okay, and if you scroll down over here, okay, so you can see over here, you can see some documentation. So this is the default configuration for web security. Okay, so this class has the default configuration that is defined by Spring Security team for the Spring Security framework. Okay, so if you don't have any configuration defined yourself, any custom configuration defined yourself, what Spring Security is going to do is it is going to pick up the configuration defined in this particular file. Okay, so here if you scroll down, you're going to see this method here, which is default security filter chain. Okay, so this is a security filter chain that is being created. Okay, so this is a default security filter chain method which accepts one parameter of HTTP security over here. Okay, it throws an exception as well. And over here, you have some code, like just 4 lines of code. So what this code says is authorize any sort of HTTP request. So any HTTP request that comes in, okay, it needs to be authenticated. You can see any request authenticated. So any request that comes onto the server, that hits the server, has to be authenticated. Okay, so anything you try to access, any controllers you create, you will need to pass on your credentials. Then we have over here, we have form-based login, and we also have basic login configured over here. And then we are returning the object using HTTP build. Okay, so what I'm going to do is you can go through this class. You can read more about this class over here. Okay, and you can see this is a configuration class, and this is what the documentation says over here. Okay, and you can see over here, if the user specifies their own security filter chain bean, then this will be backed off completely, and the users would specify all the bits that they want to configure as a part of the custom security configuration. So what this means is if you create your own security filter chain bean, then this particular class won't be considered and won't be used by the Spring Security framework. So everything related to security, you have to configure in your own security filter chain in that case. Okay, so what I'm going to do is we want to create our own custom configuration. I'm going to copy this. Okay, and I'm going to head over to our application over here. And here what I'm going to do is I'm going to create a new class. Okay, and I'm going to call this as security config. Okay, and I can have this in the security package over here in my application. Okay, so this is security config that is being created. Okay, and what I will do is I will paste this method over here. Now, after pasting this method, you will notice like all the import statements are being managed automatically. Okay, there are few annotations that we need to add over here. So the first annotation I'll mention over here is configuration, because this is a configuration class now. And I'll add one more annotation over here, enable web security. So this is one annotation that we need to add over here. Okay, and then we are going to mark this as a bean. Okay, because if you go over here into this class, it says, okay, if the user specifies their own security filter chain bean, then this class will be backed off. Okay, so we need to create our own security filter chain bean for the default one to back off. So I've created my own bean over here. Okay, and if you take a look at the code is really simple. Okay, so it says that all the requests that are hitting the server need to be authenticated with this line. And then you have form-based and basic authentication over here. And then we are returning the object using HTTP build. So since we are talking about the basic authentication only, we will just comment out this code. We don't need this code for form-based login. Okay. And yeah, we are done with the configuration. And this is how you can define your own custom configuration. At least we are starting to define our own custom configuration right now. Okay, so till now we were working with the default one, which was coming in from this class, and now we have switched over to this one. So now since we have the custom configuration created or defined, I'm going to restart our application. And the moment we restart, we are going to see a change in the behavior. So I'll switch over to our browser, and now if you refresh, you're going to be shown a pop-up over here, alert box, and not a HTML form. And the reason for this is we have disabled over here the form-based login over here. You can see over here. Okay, so this is a form-based authentication is what we have disabled. Okay, and now I can enter my credentials over here. Okay, and I can say sign in. Okay, I'm getting this error because there is no I'm not accessing the right URL, so I need to access hello over here. Okay, so you can see I can see the authenticated data over here. So this endpoint was authenticated, and once I enter my credentials in the right way on the alert box, this is what I'm going to see. Okay, so yeah, this is basic authentication where you are working with the endpoints without HTML forms, and it's the most basic form of authentication that exists in Spring framework. And this is something that we have done with the help of a little customization code obtained from the inbuilt classes that had default security configuration inside the Spring Security framework. All right, so I hope this was useful and you were able to follow along. So now let me explain to you the difference between basic authentication and the form-based authentication in a very hands-on way. So here I'm accessing a API where basic authentication is enabled. Okay. Now, if I try to access some other endpoint, I will be able to access it without any further authentication information over here. Okay. So it's not asking me for the authentication information again, which means that the session is being maintained over here. Okay. If I close the browser over here and if I open the browser again, okay, I'm opening it in incognito. And here, if I go to hello endpoint over here, you can see, you'll see that I am again being asked for the authentication information. So I have to enter admin and my password over here so that I can log in over here. Okay. So which means that this is working on the basis of session over here. Also, let me head over to inspect over here. Okay, now in inspect, let me go to network tab over here. Okay, now this network tab will give you a gist of all the API requests that are happening over here in the browser. Now, if I refresh this, okay, let me expand this. So when I refreshed, there was an API call being made and you can see the API call being made over here. Okay, and you can see over here. Okay, so let me expand this a bit more. Okay. You can see all the information about this particular request here. Okay, so this is the hello endpoint. As you can see the request URL. It was a GET request. You received 200 OK. Okay, if you scroll down over here, okay, here, if you scroll down a bit, you can see different headers over here. Okay, you can see different headers being passed in for different sort of security measures. If you scroll down, you can see the authorization header as well over here. Okay, so you have the authorization header here. Basic space the encoded value. So this is your username and password that is being encoded. Okay. And if you scroll down, you're also seeing a cookie over here, which is JSession ID, which indicates that you're sending the value of JSession ID as a header to the server. Okay. And the server is identifying the session based on this value. Okay. If you scroll down, there are other information. Okay. Other information that are needed. Now, if you head over to preview, you are seeing this response over here. This is a response. You have cookies over here, cookie tab, wherein you are seeing the cookie associated with this particular request. And you can clearly see that a JSession ID value is being associated with this particular request over here. Okay. So yeah, this is about basic authentication. If I close this and if I head over to login over here, login page. If I go to login page, you're going to see an error over here because there is no login page. There are no HTML based login pages that are needed over here. Everything is being managed through that alert pop-up that you had. That was the JavaScript alert box, I should say. Okay. You don't have login. You're going to get an error if you try to access this endpoint. And if you try to access logout over here, you're going to see an error again. Okay. So this is something that you need to keep in mind. Okay. Now let me switch over to form-based authentication. So what I'm going to do is I'm going to uncomment this one here. Now let me switch over to the form-based authentication. So I'm just going to uncomment this one and I'm going to comment out the basic one. Okay. And let me run this application again. Okay. Now, if you run the application again, and if you come over here, you will be able to see the logout page. Okay. You can see the logout page appear now. And if you say login over here, you will see the login page as well. Okay. Now here, if I try to access the hello endpoint, it will redirect me to login page as expected. So what I would do is I would right click and I would say inspect. So let us inspect as to what is happening over here under the hood. Okay. And I'll keep my eyes on the network tab because here is where you're going to see all the requests. Okay. What I'm going to do is I'm going to say admin over here. Okay. And I'm going to enter the password. Okay. Let us see how the request goes through. So I'm going to say login. Okay. And if I expand this a bit, okay, you're going to see this login request over here. Okay. And if you go over here, headers, okay, you will see the header information. So let me expand this more. You can see this was the endpoint. You can see we were redirected over here. Okay. If you scroll down, you can see JSession ID being passed in over here. Okay. And we were redirected over here to this particular endpoint. And if you scroll down over here, you can even see the authorization header here as well. Okay. And yeah, other things are there. Okay. These are all the general headers. Now, if you go to payload over here, so this payload tab was not there when we had basic authentication enabled. Okay, so this payload tab has appeared now. We only had preview. So here in the payload tab, since we had sent data using the form, you can see you have form data over here, and you have 3 fields that were sent through the form data. One is the admin. So this is a username. Okay, and this is a password. Okay, and this is the CSRF value. Okay, so like I said, Spring Security enables the CSRF protection by default to all the endpoints. Okay, so this is the value that is being passed in, which is hidden, and it is being passed into the framework to validate the request. Okay, and if you click on preview, there is no preview. Response, there's nothing. If you go to cookie, you can see there are 2 types of cookie: request cookies and response cookies. Okay, so this is being sent in request as well as response. All right, so this is about how it works, how things work when it comes to form-based authentication. The data is being sent via an HTML form over here. So I hope it's clear as to what is the difference between form and basic authentication over here. What I'm going to do is I'm going to undo form authentication, and I'm just going to keep basic authentication enabled over here. All right, so I hope you were able to follow, and I hope this was useful. So now what we have seen is the request and response, like the entire thing is being managed with the help of a session. And we are seeing this in the form of cookie over here. There is a cookie tab with the request, and you're seeing the JSession ID being maintained over here. Okay, so there is a state being maintained. Now there is a way wherein you can disable this and convert this into a stateless API. Okay, so what you can do is you can come over here. Okay, and just with the minute configuration, you can convert this stateful thing into stateless. Okay, so I can say over here HTTP dot, I can say session management over here. Okay, and I can say session. Okay, and here I can say on the next line session dot session creation policy, and I can specify the session creation policy. You can see there are different policies that you can make use of. Stateless, always, never, if required. I'll make use of stateless since that is what we are talking about. Okay, so I'm just trying to show you the power of custom configuration over here. Okay, you can configure things the way you want. And if I rerun this application now, let us see what we see in the browser. So if I come over here and if I hit refresh and if I click over here, okay, so I'm seeing this JSession ID value because we are already maintaining it. Let me close this session and let me restart this session now. Okay, and let me open the network tab also over here. Okay, now what I would do is I would just go to hello endpoint over here. Okay, hello, and here I can see admin and I can see password over here. Okay, and I can see sign in over here. Okay, and if you select this, okay, you'll see there is no cookie information that is being maintained here as a part of the request. Okay, so now we are completely into stateless mode. So just by changing a small configuration over here, with a small configuration change, we are able to change things on our own. Okay, so that's the power of custom configurations over here, and I hope this was useful. So normally when working with APIs, you're not going to make use of browsers always, right? You're going to make use of a tool like Postman. So I have Postman configured over here and I have this request added as well. Now the question is, how can you make use of basic authentication with Postman? So the answer to this is you have to come over here to Postman. You have to add the request over here like this in the form of get. And here, we don't need to add authorization header. Of course, you can do that if you wish to, but like we know, basic authentication accepts headers over here. But actually, a simpler way over here is to go to authorization tab, select basic auth, enter your username, password, and then say send. And if you say send over here, you're going to get the response in the same way as you are getting. Okay, so you can see the response being received over here. Okay, and if you observe this under the hood, so if you click on console here at the bottom left, you can see this is a get request that we just triggered. If you click over here, you can see this get request is being triggered in the same way as it's expected for the basic authentication. So you can see the authorization header over here. Okay. And you can see basic space, and this is the base64 encoded value over here. Okay. It's working in the same way. In fact, what you can do is you can even copy this over here. Okay. So I've copied this, and I can go over here. I can say no auth. I can go to headers, and here I can say authorization. Okay. And I can pass in this value here that I copied. You can say send over here, and you should see the same response over here. Hello. Okay. If I uncheck this, which means if I don't send this, you'll see 401 unauthorized. If you check this, you'll see hello. Okay. So I hope you're getting the difference as to how this is working. So either you pass in the authorization header manually, but this is not user friendly, right? Okay. So we are used to make use of things that are user friendly. So you can like come over here, basic auth, you can enter username, password, and you can say send over here. Now, one thing over here, presenting your password and credentials in this way is not recommended over here. Okay. Because you can see the warning icon over here. Okay. You should make use of variables over here and don't enter your password directly. So this is a demo application that I'm creating. Okay. I don't have any secure or sensitive stuff over here that I would wish to protect. But since it's a video, I'm okay entering the password over here this way. And since we all are learning, it's completely fine. And if you're working on a POC environment, okay, if you're working on a POC project, a very simple development project where you need to test things out quickly, then you can make use of this method. But please don't use this for production grade applications. This is not recommended. Okay. Also here on the left hand side, you will read that the authorization header will be automatically generated when you send the request. Okay. And what is the authorization header? Authorization header is the header that you just saw. Okay. Not over here, but here in the console. Okay. You could see here you had the authorization header, this first one. Okay. And the subsequent request, then we sent with the help of the authorization header directly. Okay. So if you don't add the authorization header manually over here, if you just present the authentication information over here, authorization header is created by default as it is. Okay. So this is something that you need to understand with respect to Postman. Okay. If you watch normal videos, people would show you like this is how you can make use of APIs by selecting basic auth. But yeah, this is also important to know that you can pass, like you can copy the value from here, the base64 value from here that we just saw, and you can make use of that in the header. Okay. So I hope the information was valuable and I hope this was useful. So now it's time that we talk a little bit about base64 encoding. Now, base64 encoding converts binary data into ASCII string format using a specific encoding scheme. Okay. So this is done so that the basic authentication header is correctly formed. Okay. So let me come over here to Postman, and here after you enter your credentials in this form over here, and if you enter console, you will see that the header being passed with the request. Okay. So here if you expand any request, you're going to see this authorization header with this random string. If you copy this over here, and if you come over here, and if you paste this, and if you say decode, you will see the decoded admin. You will see the decoded value. Sorry. So this is admin and this is password. So this is a username colon password, and it is being encoded in that format. Okay. So this is the username and password, which was encoded with a colon separator over here, and the encoded value is being passed in over here. Okay. So yeah, this is base64 encoding, and you can head over to this website and you can check this out, this website if you want to. There are a lot of websites that help you with base64 encoding and decoding. This is one of them. Okay. You can like check the URL base64decode.org. Okay. So yeah, that's about the base64 format. If the password changes, keep in mind the value will also change over here. Okay. So keep that in mind. All right. So that's about base64. I hope this was useful. When working with Spring Security, one observation is that any request or any endpoint that you create is by default authenticated. Now there will be scenarios wherein you might want to permit certain requests depending on what your requirement is, right? So for example, if I have to give you a example of a typical web application, normally in web applications there is a /about page or /contact page. Now to access that particular kind of page, you don't need any sort of account or any sort of authentication, because that's a public page, right? And such pages are known as public, okay? Because they are publicly accessible, there is no need of login, registration, or anything of that sort, right? And one more example, if I have to give you, is take a look at login page itself. If you make login page and the sign up page as authenticated, how will user register? Okay, because for getting authenticated, you need to provide your credentials, and to create your credentials, you need authentication, right? So that's not the right way to do things, right? So there will be scenarios wherein you will need to make certain endpoints publicly accessible, okay? So how would you do so? So you can do in a very simple way with the help of the RequestMatchers, okay? So what you can do is, here in our application, let's say we have a scenario wherein we want to enable the access, like a public access to /contact endpoint, okay? So here I have requests, okay? Here if you see, this is a piece of code that is saying that authenticate every request that comes in, okay? This is the one that we have. Now what I'm going to do is I'm going to say dot any request. So instead of any request, we are going to add one more thing over here. I'm going to say dot, and I'll say RequestMatchers, okay? So I'm going to make use of RequestMatchers over here, okay? And I'm going to say if the request is, so if the request pattern has /contact in the URL, okay? What I need to do is I need to say dot permit all. Now what is RequestMatchers over here? RequestMatchers is a method used in Spring Security to configure which HTTP request should match specific security rules, okay? So if you want to specify any patterns, you can see over here, it's accepting a parameter patterns over here. So if you want to specify any patterns over here and apply any security constraints to those patterns, then you can do so with the help of RequestMatchers, okay? So yeah, that's about this over here. So what we are essentially doing over here is we are configuring the HTTP security object over here, okay? And we are enabling or we are bypassing the security for this particular endpoint over here, okay? So now if I go to Postman, okay, if you duplicate this, let me duplicate this, okay? And let me say /contact over here. Okay, but wait a minute, /contact is not yet created, right? We don't have the endpoint yet. So what I would do is I would go in controller. I would just create a mapping over here, and I'll say /contact here, and I can just print contact over here, okay? We don't need to print any contact information, we are learning, okay? And now I need to rerun the application because I've made changes in the security configuration and in the controller as well, okay? Now the application is up and running, and here I have contact API also, okay? Now let me disable the authentication, okay? There is no header, no authentication, and let me try to access this, and you'll see I'm able to access this, okay? Not only from here, but if you go over here in the browser, okay, if I log out, so here I'm already logged in, so if I say log out, oh, so there is no log out because it's basic auth. So I'll just restart the session here, okay? And let me see if it's asking me for any sort of a login over here. Hello, okay? And you'll see it's asking me for login if I try to access hello, but let me try to access contact over here, okay? So if I try to access contact, you can see there's no authentication needed, okay? So what happened is we are permitting any request that is hitting this particular endpoint, okay? And we are permitting it to bypass the authentication over here, okay? So that is what we are doing over here. Now there will also be scenarios wherein you might want to add additional pattern, okay? So let's say in normal production grade application, what happens is there are multiple APIs, okay? So let me write some comment over here, okay? So there will be API /public, okay? So I can say /public/login, okay? There will be second API which will be /public/signup over here, something like that, okay? So there can be multiple APIs starting with /public, okay? Forgot password also can be public over here, okay? So you can have So there's a pattern over here. Okay. Now, one way is you write permit/login over here, /public/login over here, permit/public/signup over here. You write those many lines of code over here, or what you can do over here is you can say /public over here. Okay, you can say something like this. Oh, wait a minute. Let me just duplicate this line. Okay, you can add multiple request matches as well over here. Okay, you can say /public/ and you can add 2 stars over here. So what would happen is any request that has /public in it, it is going to permit them all. Okay, so if you want to have certain pages in your application without authentication, like they should be accessible without authentication, so in that case what you can do is you can have a URL pattern. So normally production grade applications have this sort of thing wherein they have like /public over here, and under /public all the publicly accessible pages are placed. Okay, and this is for this particular thing over here. So you just mentioned this line of code, and in future also if you add any endpoints starting with /public, then what would happen is it would bypass Spring security. Okay, like there won't be any authentication that would be needed to access them. Okay, so yeah, that's about how you can permit access to certain URLs. I hope you have been able to follow, and I hope you understand the importance of this concept. So yeah, that's about permitting access to certain endpoints, and I hope this was useful. Now, when working on a real world project, you might face a scenario wherein you wish to deny access to certain HTTP endpoints irrespective of their authentication status or roles, okay, ensuring that no user can access them. Okay, now this is where you have access to a method called deny all, where you can reject any sort of request that is coming towards an endpoint. Okay, so let me show you an example for the same. So let's say here, if you say /RequestMatchers, and let me add /admin over here. Let's say we want to reject everything to admin endpoint over here. Okay, and here I can say dot, and here you can see deny all. So I can make use of deny all and reject everything that comes to this endpoint, irrespective of their authentication status, of course. Okay, let me rerun this and let me show the output of this to you. So it's running, and here if I duplicate this, and if I say admin over here, and here if I say /admin, let me send the request. You can see 403 forbidden. Okay, the request was a legal request, but server is refusing to respond to it. So that's the 403 forbidden status. Okay, and this is different from 401 unauthorized response, where authenticating will make no difference. So whether you are authenticated or not, it does not make any difference. Okay, and remember, we have not added any controller for this endpoint. Okay, so it's not even reaching the controller here. Okay, so if you see over here, we don't have any controller handling this endpoint. Okay, so the server is directly rejecting this request. Now, if you copy this, you can even try this in the browser as to how this behaves. Okay, so if I say admin and if I enter password, you can see like this is completely rejected. Okay, so you are not seeing the right status response over here. Oh, okay, so we are seeing over here forbidden status 403. Okay, there is no error page created in our application and mapped to. That is why we are seeing this white label error page. Okay, but this is not how you will be accessing the API. You will be generally making use of Postman. Okay, so this is what you would generally see. Now the question is, why would you want to make use of this in your Spring Boot project? So one use case that I can think of is maintenance mode. Okay, so when certain parts of your application are under maintenance, you might want to temporarily deny access to those endpoints and prevent users from interacting with them until the maintenance is complete. Now in this scenario, let's say /admin is representing our admin dashboard, and we want to reject all the requests coming to our admin dashboard because our admin dashboard is under maintenance. So in that case, you can make use of this line over here. Okay, you can even have certain deprecated endpoints. Okay, so if your API has endpoints that are deprecated, making use of some old methods or old business logic, and you want to ensure that they are no longer accessible, you can make use of deny all. You can even make use of deny all from a security standpoint. Okay, so there might be certain endpoints in your application that might pose a certain security risk or are not yet fully secured. Okay, and until they are fully secured, you might want to deny access until proper security measures are in place for that endpoint. So that's another use case that I can think of. Sensitive data. So if any endpoint has any sort of sensitive data that you are not ready to share with the world or anyone in the application, but you also don't want to remove it from the application, so you might want to deny all. Okay, conditional access. Conditional access is also a thing. So let's say you have some logic over here. There's a very simple configuration class we have written. Okay, we hardly have like around 7-8 lines of code here. Okay, hardly max 10 lines, right? Now in real world project, this security configuration can be complex, and you might be checking multiple conditions within this configuration class. Okay, and let's say if a certain flag is true, you might want to restrict an endpoint. So in that particular case, if a certain condition is met, then you might want to restrict a particular endpoint, and you can make use of deny all in that case. Okay, so you can write a if statement. If this is true, then deny this endpoint. If not true, then permit. Okay, so something like that you can do over here. Okay, so that's what deny all is. And you can, of course, so if you want to duplicate this, let me duplicate this. You can specify patterns over here. So you can say /**. Okay, so if you have a particular pattern in all your endpoints, and if you want to restrict access to all those endpoints, you want to reject all the accessibility to that particular endpoint, right? Or endpoint having that particular pattern, then in that case, you can make use of ** like this over here as I'm using, and you can deny the request to all those endpoints matching this pattern. Okay, so I hope this is understood. Okay, so I hope this is useful, and I hope you have been able to follow along. So it's time that we start talking about the Secure Nodes project, and we start structuring our thoughts. So what we are going to do is we are going to understand what we are going to build. Okay, and this is going to be the first level of building. Okay, like the first set of building that we are going to do, and gradually we'll build upon this code base. All right, so this is what we are going to build. Okay, so we are going to have some functionality in place that will enable us to work with nodes. So since we are building a nodes application, it's a secure nodes application. So we'll need the following endpoints that you are seeing on the screen that will enable us to do more with the nodes. So the endpoints are simple. Okay, like simple to understand. Here you can see we have the post request, which is API/nodes. And yeah, this would be, of course, host name would be followed by this. So you would have host name just before this. Okay, of course. And here is the description. We have request body. So request body is the content, and the content you need to have in the node. Okay, so you're creating the node. This is creating the node, and here you have the content using which you wish to create the node. The request parameters. So there are a couple of parameters that we need, and the response. Okay, in fact, the parameter is only one, not two of them. And here the response is the created node. Okay, don't worry if you don't understand what authentication principle is, why we are accepting user details and all. Don't worry about that right now. It will all be clear when we jump into code. I'm going to explain everything to you line by line. So don't worry about stuff that you don't understand. Just go through it. Okay, so here this is a get request. You have /API/nodes. It's the same endpoint. And if you hit this with the get call, you are going to retrieve all the nodes for the logged in user. You have put request, and here you are trying to update the node, and you're passing in the node ID over here. Okay, so you can see you have the updated content over here. You have the request parameter, and the response is the updated node. Okay, you have the delete request where you're passing in the node ID in the end, and you are trying to delete a particular node. Okay, so it's a simple CRUD operation that we are trying to do over here. And this would be the base on which we are going to build the whole project and learn and explore different features of security. But I'll tell you what this particular thing is going to help you with. This particular thing is going to help you or writing this CRUD operation is going to help you understand how you can perform CRUD operations in a authenticated environment or in a secure environment. Okay, so that is what is going to be different from a normal like CRUD operations. Okay, that is what I can promise over here. You're going to learn new steps or new things in every step. Okay, so have patience and let's jump right in. So now it's time that we go ahead with setting up the structure of node. And what we are going to do is we are going to create model and we are going to add some relevant dependencies that are going to be needed for our project. So here in the notepad, I have added the code as to how our node is going to look like. Okay, so this is all the information that we are going to store around our node. Okay, so you can see like these are like generic annotations, which are JPA annotations. Like I'm marking this particular class as entity, and yes, we'll be using Lombok as well. So we are using this to generate getters, setters and all. And here I have the class node. I'm making use of two JPA annotations, and here I have this ID field. So we have ID field, content field, and owner username over here. Owner username meaning the username of the person who has created this node. Okay. Now you will notice this annotation over here, LOB. Okay. Now what is this LOB annotation? Now LOB annotation in JPA is used to specify that this particular property should be persisted as large object into the database. Okay. So the database should support large object type. Okay. And if you specify this, you can store long strings over here in our content. Okay. So why are we doing this? Because nodes can be long also, right? So with this annotation, we'll be able to store nodes that are longer in length. Okay. And that will be useful for our users who are using it. All right. So this is a code. I won't be typing all of this into the editor. I will be simply copy pasting this because I want to spend more time explaining things and not typing. I want to focus on explanation so that you understand everything. So this is not generic. I think this is, we are using normal annotations of Spring Boot. Okay. So if you are using Spring Boot, you will know what I'm using over here. All right. And now over here, what I'm going to do is here under spring.com.secure.nodes, I'm going to create a class over here. I'm going to call this as node class, and this is going to reside in models package. Okay. And here I'm going to paste this thing, entire thing. Okay. We'll see all the red marks. That's perfectly fine because we don't have the dependencies configured yet. So we need two dependencies. One is the Jakarta persistence and we need Lombok. Okay. So I'll switch over to my browser over here. Okay. And here in the browser, I'll head over to start.spring.io, which is our favorite website. Okay. And here you'll make sure that you select Maven and you need to add dependencies from here. So I'll say Lombok and I also need to add JPA. Okay. So Spring Data JPA, and we are not configuring the database yet. Okay. So don't worry about the database part. We'll get to it soon. Okay. But what we need to do is you can see over here, there are a few settings as well. Okay. So this also needs to be added. Okay. So I'm going to copy this configuration tag over here first, and just under Maven plugin, we need to paste that. Okay. So be sure to take a look as to what all you need to add. So you need to scroll down over here and just under Maven plugin in pom.xml, paste it. Okay. So this is the configuration that we have added. Okay. Which is fine. And if you scroll up, we have this part over here. Okay. So this is the dependency, these two. Okay. So I'll just copy this. We don't have anything else that we need. So I'm going to come over here, and here under dependency, I'm going to paste this. And the moment we paste any dependency or make any changes to pom.xml, of course, we need to, it's a ritual, right? You need to refresh or reload Maven changes. All right. Now, after this, you should see all the red marks go away, which is absolutely great. And we have our nodes ready. Okay. We can also do some sort of restructuring over here if needed, but there's no restructuring needed over here. You can see like, okay, we have controller over here. So this controller anyways, we won't be needing. Okay. So we would be getting rid of this controller, but for controller, we'll be creating a separate package, which is the controllers package. All right. We'll be organizing all our code in the right way. All right. So this is about, the model is pretty clear, I guess. There is nothing much. This is the basic structure of our nodes that our application is going to have. So I hope you have been able to follow, and I hope this was useful. Now, as a next step, our goal would be to set up a service class, and we would also need to set up a node repository. Okay. So we are going to set up both of this. So what I'm going to quickly do is I'm going to move these files first into IntelliJ, and then we are going to talk about it. Okay. So for repository, what I'm going to do is I am going to create a new package over here. I'm going to call this as repositories. Okay. And here within the package, I'll paste this. Okay. So you have this repository added over here. And then for node service over here, what I'm going to do is I'm going to come over here. I'm going to create a new package. I'm going to say services.service.impl. Okay. I believe that's the package okay. Services.impl. So services.impl. And I'll have this created here. Okay. And within this, I'll paste this. Okay. So we have this, and we don't have a node service yet. So what I would do is within this package here, okay, or one second over here, I would create a Java class. Okay. And I would create this under services, and I would call this class as node service. Okay. So this won't be class. This would be a interface. Okay. So yeah. And if you come over here, the error is gone, and I believe we are good. Okay, we are getting errors on this override annotation. And for this, I'll just say pull, and I'll just get everything pulled to the parent interface. Okay. Yeah. So I'll close all of this. Okay. Well, let's go through the code. So here you can see this is a node repository. It's a fairly simple and straightforward code where I have created an interface called node repository, which is making use of JPA repository. Of course, I'm making use of node and long over here. And I have a method defined over here, which is find by owner username. Okay. And what this will do is this will help us get the node by owner username. And we are passing in username as the parameter. Okay. So JPA will take care of generating the queries in the hindsight. All right. And over here, I just added a node service.java, which has few methods over here, method declarations, and this is an interface. Now over here, this is the service implementation where we are creating an instance of node repository. Okay. So first thing foremost, this is implementing the node service interface. Okay. And this is a service component. And then I have auto-wired node repository. And then I have added an implementation of how you can create a node for a user. So creating node for a user is fairly straightforward. We would be getting the username and the content with which we want to create the node from the controller. Okay. And then with the help of that information, we would be making use of this logic. So we are first creating an instance of node. We are setting the content over here. And then we are saving the node into the database with the help of repository. And save over here will return the saved node, which we are accepting over here as saved node. And then we are returning the saved node. All right. So that is what we are doing. And if you scroll down here, okay, here, this is another method that is overridden, and this is for update. So we are accepting the node ID, the content with which it needs to be updated, and the username over here. Okay. So with the help of this information, what we are doing is we are fetching the node first. Okay. And if the node is not found, what we are doing, we are essentially throwing a exception over here. So runtime exception, node not found. Okay. So if the node with this ID does not exist, we throw an exception. If it exists, then we are updating the content over here, and then we are updating the node over here, and then we are returning the node back. So one mistake I can highlight over here we are not returning the updated node. Okay, so we should return the updated node over here. Okay, so that is done. Then delete node for a user. So here we are simply deleting the node by ID. So we are getting the node ID as the parameter and the username, but we are making use of node ID. And if you scroll down, we have one more method, which is get nodes for the user. And here we have username as the parameter. So what we are doing is we are making use of node repository, and we are getting the nodes by the username, and we are getting this as a list, and we are returning the list. Okay, so this is very straightforward. Okay, and if you go through here, this is the create operation, this is the update operation on node, this is the delete operation, and this is fetching all the nodes for a particular given user. Okay, so it's essentially we are doing a CRUD operation over here. Okay, and yeah, if you're familiar with Spring Boot, this should be cakewalk. And anyways, I've given you an overview of this code. You'll see these yellow marks. It's because IntelliJ is telling us that, hey, you can like inline this declaration so that you can save a line of code. If you want to, you can go ahead with this. Okay, so I can select this, or if you don't want to, you can like press Ctrl C and stay as it is. Okay, it's totally up to you. Does not make any difference. Okay, so I hope this is clear to you all as to what repository and service classes would do over here, or the service components would do. Okay, so I hope you have been able to follow, and I hope this was useful. So now it's time that we begin talking about the controller. And controller is where our endpoints are going to exist. Okay, so what I'm going to do is I have this code written here in Notepad. I'm going to copy this code. Okay, I'm going to head over to IntelliJ, and here I'm going to add a new, I would add a new package over here, or new class, let's say, and I can call this as controllers dot, I can say nodes controller, something like that. Okay, so this is being created in the controllers package. Okay, and over here I'm going to paste this. Okay, so it's node controller, so I need to rename the file. Okay, so it's node controller, and I believe the issue should be gone. Okay, there is a package name missing, so I've set the package here at the top, and we are done. Okay, so let's go through the code over here. Okay, so these are all like package declarations and import statements. So far so good. If you scroll down here, I'm making use of a couple of annotations. This annotation is telling Spring Boot that, hey, this particular class is a controller. And this particular annotation is telling Spring Boot that all the requests that start with /API/nodes have to be mapped to this particular controller. Okay, so this is really important. And all the endpoints that we are going to define inside will be beginning with this. Okay, now here within the class, I have service object, which is being auto wired over here. This is node service that is coming in. Okay, and what we are doing is, if you scroll down over here, so here we have a post mapping. Okay, this is create node operation. Okay, and if you scroll down, if you notice, these are essentially CRUD operations. And here, if you see, this particular method is create node, and it is accepting two parameters. Okay, I'm going to explain what these two parameters are and why do we need them. First is the content for the node. Okay, and the second one is the details of the user. Now, this first parameter we are accepting as the request body. Okay, now what is request body? So when sending the request, within the body of the request, we will be sending the content of the node. That is how this API is going to accept the content for the node that you wish to create. And of course, once you have the content, you would be creating a node in the database. But the question is whom you would be associating that node with. For example, if I'm logged in to the application, it's a secure application, right? There will be authentication endpoints and all. So within this application, if somebody is creating the node, that node should only be visible to me and not to someone else. And that can be achieved by associating the node that I'm creating with my account or with my details. And that is the very reason why we are having this second parameter over here. So the second parameter essentially gives us the information about the user who is logged in. How is it giving us that information? With the help of this annotation. So if you are not aware of this annotation, let me explain this annotation to you. This annotation authentication principle is coming in from Spring Security, and it is used to inject the currently authenticated user into the controller. Okay, and we are getting this in the form of user details object. You can see over here. So this is automatically done. Whoever is logged in to your application right now, those user details will be auto-populated over here. And if you hover on this, you'll see it is coming in from the Spring Security package. So org.spring framework security core annotation. So Spring Security is giving us this annotation, and user details is the inbuilt user detail class from Spring Security. You can see. So this is how we are getting the user information and all the information that we need as a parameter to this method. And this is the information that we are going to use to create nodes. How? Let me tell you. So here, first thing, we are extracting the username from the user details. Okay, so if you go over here into user details class, you have get username, which will return the username of the authenticated user. So what we are doing is we are getting the username, and then with the help of username, we are creating the node against that user. And we are also printing it onto the console. You can get rid of this if you wish to, but I have this line over here. All right. So this is fairly straightforward as to why this method exists. It is simply helping us to create a node against the logged in user. If you scroll down, we have a get mapping now. Now, this particular mapping, or this particular endpoint, I should say, is used to get the nodes associated with the user. All right. Now let me go right over here. So here I'm accepting only one parameter, and I'm not getting that through the API, but in fact, Spring Security Framework is injecting that on the fly. So with the help of this annotation, I'm telling Spring Security that, hey, give me the user details of the user who is currently logged in. And once I have this detail, I'm getting the username. And based on this username, I am telling the service class that, hey, I need nodes for this user. And who is the user? The one whose username I'm passing in. And if you go into the service over here, so service implementation, if you scroll down, here we have the logic to get the nodes of that particular user. It's pretty straightforward here. All right. So far, so good. Now we have a put mapping. Now this put mapping is having a parameter. And as you can see over here, let me press enter so that you can see it all in one screen without scrolling. So here, update node method is accepting three parameters. One is the node ID, the node content, and the user details. So user details, again, it is being injected as to whoever is logged in, it's being injected, and those details we get over here. We get content over here, and we also have node ID that we are getting as a part of the URL. Now, why do we need this three information? So first is we need to identify the node who is supposed to be updated. How will we identify a node? What is a unique identifier? A user might have multiple nodes, but the unique identifier for node is node ID, and that is what we are requesting for. Then we have content over here. Okay. Content is nothing but the content that will be updated against this particular node ID. This is the updated content that the user wants. And this is the user details. So first we are getting the username. Then we are passing all this information that we've received to update the data. Okay. And okay, so it is being updated twice over here. So I'll get rid of one over here. We need to update it once itself. All right. So this is done. If you scroll down further, we have a delete mapping. Now, delete mapping is fairly straightforward. We're accepting node ID because we need the ID of the node that we wish to delete. So that is what we are accepting. And then over here, you can see we are having two parameters. One is note ID and other one is the user details. And we are passing this both to service over here. So far so good. So it's a pretty straightforward implementation where we are performing the CRUD operations against note. And we are making use of authentication principle over here. Authentication principle is something new that we saw. It is simply used to inject the currently logged in user into the controller method. And you can make use of this over here in amazing ways. So you can see over here, you have get username. If you say dot over here, you can see what all methods you have access to. So get username will give you the username. Password will give you the password. Get authorities will give you the roles that are associated with this user. So right now we don't have roles in our application yet, but this is something that you can get. You can have is account non-locked, non-expired, and so on. There's so much more. Okay. So I'll stick to get username over here. And yeah, this is how our controller would function. And I hope you have clarity of each and every piece of code that we have written over here. All right. So I hope you have been able to follow, and I hope this was useful. Hey there, welcome to this class. So let us begin installing MySQL on our Windows machine. So I'm going to head over to my browser and I'm going to head over to google.com. And here I'm going to search for MySQL. And you will see this first website appear over here, which is mysql.com. So this is the official website for this particular software. So I'm going to click on this particular website and you will be taken to this website over here. So this is a logo that you should see. So you can go through the official website and the details over here. You can read more about who are the customers that are using MySQL and so on. But since we are here to download, I'm going to click on downloads over here. And if you scroll down here, you will see different download options over here. So I'm going to say MySQL Community GPL Downloads. And I'm going to select this. Now, once you select this, you will be again presented with multiple options over here. So I'll just select MySQL Installer for Windows. So I'll click on this. And you should see this page over here, which talks about the installer version. It talks about the version here, like the drop down, and the operating system. So I'll just keep these selections over here. Now, if you scroll down over here, you will see these two options. So this is Windows x86 32-bit, and this is also a similar one. But the difference is over here. So this says MySQL Web Community, and this says MySQL Installer Community. Now, what is the difference over here? So Web Community version is the online installer, and you need to download to connect to the online server over here with this version. But this is an offline installer. Okay, so I'll go ahead and I'll download this version over here. Now, when you click on download, you will be shown this particular page over here, which is asking you to log in or sign up for a free account. So I don't want to do that. So I'm just going to say no thanks, just start my download. You can alternatively create an account or sign up over here. Now I just said no thanks, just start my download, and I have downloaded the installer over here. It is saved on my desktop. Now to begin the installation, I'm going to double click on this. So this is going to show you such window over here, and it is going to say please wait. And you might see this pop up over here, which is asking you if you want this app to make changes onto your device. So I trust this app, so I'll say yes. And this is going to ask again, so I'll say yes over here. So here now you are going to be presented with the choose a setup type screen, wherein you are being asked to choose the setup type. So you can either install the server only. So this is just going to install the MySQL server, or you can have the client only. So you can have the client only version wherein you can install these three components like MySQL shell, router, and the workbench. So shell is nothing but the interactive command line interface using which you can query the database. You can have a router, like this is like a router daemon for your database, or you can have MySQL Workbench. So this is like a graphical user interface using which you can connect to the database. So with this setup, you install these three components, and with full, you install quite a few components like MySQL Server, MySQL Shell, MySQL Router, Workbench, and so on. Okay, but what we are going to do is we are going to say custom and we are going to go next. And now here we will be asked to choose the products over here. So I'm going to click on MySQL Server here. Okay, and I'm going to get the MySQL Server. I'm going to install MySQL Workbench over here. So let me expand this a bit. And I'll install MySQL Shell over here. So MySQL Server is nothing but the SQL database that we are installing. So this is the MySQL database server that will be installed on our system. MySQL Shell is nothing but the command line interface using which you can connect to the database and write SQL queries right from within the command line. Okay. And MySQL Workbench is the graphical user interface using which you can connect to the database. So I'll say next over here. You will see these three components. Okay, they are ready to install. Okay, if you just don't want these three components and if you want everything to be installed, you can just choose full option on the choose setup type screen. So that is also perfectly fine. Okay, but I have chosen only these three components because this is what we are going to need. And I'll say execute. Now the moment you say execute, you will see the progress happening over here. Okay, and you will see the status like complete. It's saying installing and this is ready to install. So we will wait for a while until this process completes. So the installation for these three components have been successful and complete, as you can see over here. Now we'll click next and you will see that we now need to do the product configuration, and you can see over here MySQL Server is ready to configure. So I'll say next over here and you will see this configuration screen appear over here. So here we are going to select the config type as development computer. You can click on this and see the different options that you have over here along with their descriptions. But we will have the development computer selected over here. TCP/IP is the protocol that we will have checked. So this is by default checked, and we have the default port number as well on which our server will be running. So we'll keep this as it is and we'll say next. Now on the next screen, you are going to be asked to select the authentication method over here. So we'll just select the first option over here and I'll say next. Now here you will be asked to mention the MySQL root password. Okay, now root is like an admin account that you have in the database. So you need to choose a strong password over here. So I'll enter the password of my choice. So I'll say, so you can enter the passwords of your choice and just make sure that they match with each other and they are strong. Okay, so you will see this password strength indicator appear over here. Okay, so my passwords are strong and they match with each other. Then I'll say next over here. Now on the next screen, it will ask you to configure the Windows service to start the server. So I'll keep the default setup over here. And what this means is that MySQL Server is being configured on my system as a service. And the service name is MySQL 80. And it will start the MySQL Server at system startup. So if you're unchecking this, just make sure you go to services and start the service manually. Okay, and I'll say standard system account over here. So I'm just keeping the default selected over here and I'll say next. Now over here, it is asking for some permission files over here. So I'll say next and it will ask me to apply the configuration on the next steps. So if you are okay with everything, you can say execute over here. And once you say execute, it will start executing these steps. So these are the steps that you are seeing on the screen. So it will start writing the configuration file, update the Windows firewall rules, and so on. Okay, it will initialize the database, start the server, and so on. Okay, now if for any reason on this particular screen you said start the MySQL server at the system startup, and if you unchecked this, so if you uncheck this, you need to start the service manually, and for that you need to go to start and you need to search for services, and here in the Windows services you need to search for SQL, like MySQL over here. So right now it's not coming over here because I have not yet installed the service. But once you install it, it will appear over here. Okay, and you need to right click and say start. Okay, so I'll just close this. I'll go next, and I'll say execute over here. So this will take some time depending on your system performance. So we'll wait for a while, and the configuration operation has been completed. So you can see everything is ticked in green and it's all done. Okay, now I can say finish over here, and you can see the product configuration. We will now walk through a configuration wizard for each of the following products. So I'll say next again over here. Okay, so on this particular screen it's telling you installation complete. Okay, and it's showing you two options here which are by default checked. Okay, so I'll say finish over here, and you will see this shell prompt open over here, and also this application opens up, which is MySQL Workbench. So this thing over here, this command line, is the shell prompt using which you can write SQL queries, and this is something that we have installed. So you can see the path over here is C program files MySQL shell 8.0 bin and MySQL sh. So this is a path where this particular file resides. Okay, so I'll just say quit over here, like close it, and you can see this particular interface that opens up, and this is MySQL Workbench. So we have installed MySQL database onto our system along with MySQL Workbench. So MySQL database is a database server, and to connect to the database server, so it does not have a interface. So we need a separate software which is also provided by MySQL, and it is known as MySQL Workbench. So we will be making use of this particular software, and you can read the description here. Okay, so we'll be making use of this software to connect and work with our database. Now MySQL is installed on our system as a service, and to confirm that, you can go to services. In start, you can search for services. You can go to M over here, the letter M, and here you will see MySQL 80, and this is running and this is automatic. So startup type over here is automatic. So during installation, if you have specified that you don't want MySQL to start automatically on system start, you will have to come over here and right click and say start over here. So right now it's started for me, so I don't have the start option, but you will have to come over here and do the start. So I'll close this. Okay, and this is MySQL Workbench. So I'll go full screen with this. Okay, and you will have this software installed, so you can search for MySQL. So you will see MySQL Workbench, MySQL Shell. Okay, so there are different MySQL related tools that we have installed. So we will be making use of MySQL Workbench going forward to connect, work with the database, and also to write the SQL queries. Okay, so now you can see over here, you have an option here which says MySQL connections, is showing you like all the connections that exist onto this particular software. So here you are seeing one default connection, okay, which already exists. You can click on this and it will ask you for the password, and you can see over here it is connecting to the service, which is localhost:3306, which is where we have installed the database. It says user is root, and password, it is asking to enter the password over here. Okay, so if you close this and if you right click on this and say edit connection, you can see all the information about this connection over here. So the connection name is local instance MySQL 80, which is what you see over here. and the connection method, hostname, port, username, and the password that you are entering over here. Okay, so I'll say close over here. You can even add new connections by clicking on this plus icon over here, and it will open like setup new connection wizard. All right, so this is about connections. So I'll just click on this default one and I'll log in using the root user. So here we need to enter the password that you had set when installing the MySQL database. So I'll enter the password. So the password is entered and I'll say OK. So the moment you say OK, you're going to be connected to the system over here. Okay. And you can see over here, like this is the screen that you get after logging in. So with this, we have successfully configured MySQL Server, MySQL Workbench, and MySQL Shell onto our system, and we are ready to write database queries. All right. So that's about the installation process, and I shall see you all soon. Thank you. Hey there, welcome back. So let us take a look at how you can install MySQL on your Mac machine. So here I am in the browser on Google, and you need to search for MySQL over here. The moment you search, you are going to be presented with a list of options with this first website over here, which is mysql.com. Now this is the link to the official website, and you can go over to this website. You will see this official logo of MySQL coming in over here. Okay, so you can go through this website. You can read more about MySQL database here. You can also take a look at like who are the customers who use MySQL today. Okay, you will have all the information appear over here. Okay, but since we are here for installation, I'm just going to head over to downloads, and I'm going to just scroll down a bit. Now here, if you scroll down, you're going to see this option here, MySQL Community GPL Downloads. So I'll just click on this link over here, and you will again see a lot of download options over here. So these are the different tools that MySQL has to offer. Okay, you have Workbench, Shell, Router, Community Server. So what we'll do is we'll click on MySQL Community Server, and you will be shown this particular page where you will see macOS is by default selected under operating system. Okay, so if it's not selected, you can just click on this and select the operating system macOS, and you can have the latest version selected over here. Okay, so now here you can select the different OS version over here. So you have options like macOS 13 ARM or macOS 13 x86. So ARM is for Apple based chips. So if you have your Mac machine which makes use of Apple based chips like M1, M2 and so on, you can select this option. Or if you are using a Mac that is making use of Intel based chips, you can select this x86 option over here. Okay, so based on that, the filter will change. Okay, you can see, and you can also select all, and you can see the different versions that are available over here. So you have ARM version, x86, and then for these two architecture, you have different types of installers. Like you have DMG archive, you have compressed tar archive, and tar files. Okay, so since I'm on x86, I'm just going to download the DMG version by clicking on download over here. Now the moment you click on download, you will be asked to log in or sign up over here. Okay, so I don't want to do that. You can optionally create an account and stay updated with all the information that MySQL has for you, but I would just say no thanks, start my download, and it will begin the download. And I have already downloaded this particular software here, so I'm not going to download again. I'm just going to go to my downloads, and you can see this download happen over here. Okay, so in order to begin the installation now, you need to double click on the installer, and it will begin the installation process. So installing MySQL is pretty simple, like it's just like any other software, but there are some options that you need to select, which we'll take a look now. So once you click on the DMG download, you will see this page open, which will have .package files. And if you click on that, you will see the installer open up and it will ask for permission. This package will run a program to determine if software can be installed. So you can say allow because we've downloaded this from a trusted source on our system. Okay. So you can say allow and you will have a series of steps that you can go through that you can see here on the left hand side, like the introduction, license, destination, and so on. So I'll go ahead. Okay. You have the license agreement, which you can go through if you wish to. I'll just scroll down and I'll say continue. You can optionally read this. And here again, we are getting an agree pop-up, which I'll say yes. Now it will show you the installation type over here. So it is doing a standard install on my computer and it is taking this much of space and I can click install and go ahead. Okay. I can even change the install location by clicking on this button. So you can see different options over here, like install for all users on this computer, install for me only, or install on a specific disk. Okay, so I'll keep this selected here and I'll say continue. You can even customize the installation by clicking on the customize button over here. Okay, so you can see we have MySQL Server, preference pane, and launch HD support by default added over here, like checked. Okay, now I'll say go back. Okay, we'll have standard installation only. Okay, so I'll say install. Now it will start preparing for installation and it will ask for your system password. So you can enter the system password over here and you can say install the software and give this a little bit of time. It will start writing the files onto your system. Now in the next step, it is going to ask you to configure MySQL Server. Okay, so you can use a strong password encryption or you can use a legacy password encryption. So out of these two options, I'll keep this default selection over here, use the strong password encryption, and I'll go ahead next. Now here it will ask you to enter the password for the root user. Now root user is like an admin user in MySQL and I'll give this a password. So I'll enter the password of my choice over here and just be sure to have at least 8 characters and follow the rules that they have mentioned over here. I'll say finish and it will perform some initial setup and again it will ask for my system password. So I'll just enter that over here. Okay, and I'll say okay. So you will see some progress happening over here for a while and it will perform the initial database setup. So we'll wait for a while until this is complete. So the installation is successful now. As you can see, I have the thank you message up here. So I'll just say close and this will simply close and move the installer to the bin. Okay, and we are done with the installation for MySQL. Now, once we are done with the installation of MySQL, we need to install a user interface to connect to MySQL Server. So right now, what we have done is we have installed MySQL Server. It does not have an interface and we need a tool to connect to our database. So we'll get back to the browser. I'll go back over here and this is our downloads page and I'll go back again. So here on the downloads page, like MySQL community downloads, we have an option here, MySQL Workbench. So we'll click on this and we'll have my macOS selected and I'll select the OS version. So ARM again is for macOS chips and x86 is for Intel. So depending on what you have, you can choose. Now I am on Intel chip, so I'll just select x86 and I'll just download this. Now to save time, I have already downloaded this installer. So you can see the installer here in my downloads. And what I would do is I would just double click on this one and I would open this DMG file. Now The installation for MySQL Workbench is pretty straightforward. Like any other Mac software, we need to just drag drop this into the applications folder. And once we do that, we will have MySQL Workbench app into our Mac OS. So I believe it has been copied. Let me go to application and sort by date modified. Okay, it's not yet copied. So how the copy worked is I had to select this MySQL Workbench, drag it to the application folder. And if you drag over here, the application folder will open up and then you can leave it over here. Okay, so this is how I was able to do it. And I'll just stop this one, okay, because I'm already copying this. So it's about 5 seconds remaining now, and I believe it's copied. Okay, so you can see MySQL Workbench appear over here. So I'll just double click on this software and I have it in my application, and let us take a look at the interface of MySQL Workbench. So it'll prompt you whether you wish to open it since you have downloaded this from the internet. So I'll say open and I'll wait for it to open. So you will see this interface, something like this, and you can read the description here. So MySQL Workbench is an official graphic user interface tool for MySQL. Okay, so this is provided to us by MySQL itself, and it allows you to design, create, and browse our database. And you'll see one connection already created over here. So how it works is, since this is a client which you can use to connect to the server, we have to create connections. So you have a connection here already created. If you click on this, you will be prompted for the password. I'll say cancel, and you can even right click and edit the connection. So the moment you edit, you will see different information like host name, the port number, the username, and the default schema here. Okay, and you can even test the connection. So I can say test and it will prompt for the password, and I can just enter the password that I have entered when I had installed MySQL. So that is something you need to remember. I'll say OK, and you will see a connection warning. I'll say continue anyway. And you should see successfully made an SQL connection, which means that the password was correct and all the other details are correct. Okay, so I can either connect this way or I can even create a new connection. So you can say, you can enter the connection name, you can enter the IP over here, the port, the username with which you are connecting, and connect. Okay, so this is about the interface. And if you click on this, since I have already entered my password, it is asking me whether you wish to continue anyway. I'll say continue, and you will be prompted for password which you have to enter, and then you will be taken to this page, which is the main page of MySQL editor. Okay, so this is the MySQL home page, or the main page I should say, where you will start writing queries. All right, so that's about how you can install and set up MySQL and MySQL Workbench on your Mac machine. Hey there, welcome to this class. So let us understand how you can install MySQL onto your Ubuntu or Linux operating system. So what we are going to do is we are going to have two components installed. So the number one component is MySQL Server, and then we have MySQL Workbench. So you can head over to Firefox and you can search for MySQL over here on Google. So I'll say MySQL, and you will be taken to this official website. Now here is where you can read more about MySQL if you wish to. You can see different companies that are using MySQL over here. Now there are multiple products that this particular company has. So you can see we have the Enterprise Edition, Standard Edition, but we are going to use MySQL Community Edition. So if you go to download, from here you can download the files that you need over here. Okay, so you can select the MySQL Community Server and you can download the files for Linux. But we are not going to follow this approach. We are going to head over to our terminal and install it via command line. So we are going to have MySQL Server. So this is the server which has the database up and running, and this is where our data is going to be stored. And then we need a graphical user interface to connect to the database and do the queries. So yes, MySQL community server comes with a shell, which is nothing but a terminal using which you can query the database. But using shell is not that interactive. So we will be making use of a graphical user interface called MySQL Workbench. Now MySQL Workbench is a interface that allows you to define connections and connect to your databases. We are going to see this shortly, and let us begin with the installation process. So what I'm going to do is I'm going to minimize this and I'm going to head over to my terminal. Now in terminal, I'm going to run this command sudo apt update. So first I'm going to update the packages that I have, and I'm going to be prompted for the password which I will enter, and I'll press enter over here. So this will do the updates or anything that is pending on your system. So it will update the packages. So we'll wait for a while until this updates. So the update process is completed, and there will be a possibility that there will be no updates for your system, which is perfectly fine. I had few updates and the updates were implemented. So I'm going to clear the screen and I'm going to write the command now to install the MySQL server. So I'm going to say sudo apt install. I'm going to say MySQL -server, like so. And I'll press enter. Now it will ask you whether you want to continue. So I'll say yes, and I'll press enter again. Now depending on your internet connectivity and your system performance, it will take some time to process, okay? And we'll wait until it installs everything. So the installation process was completed and you won't see any errors usually, okay? So now we need to check the status of MySQL. Now MySQL is installed as a service and we need to say sudo systemctl, and you need to say status MySQL.service. So this will give you the status of MySQL, and if you run this, you will see some stuff being printed and you will see this active status, which is mentioning that it's active and running, okay? And you can see this is the process, and you'll see different information like the memory and CPU information over here, okay? So I'll just press Ctrl C and I'll exit this. So MySQL is running, but for some reason, if it's not running for you, then you can go to the previous command and instead of status, you can say start. So you should say sudo systemctl start MySQL.service, and this command will start the MySQL service that has been installed on your system. Now after getting our service to start, it's time to log in to MySQL shell. Now what is MySQL shell? So MySQL shell is an interactive terminal from where you can connect and query the database. So I'm going to say clear over here. So to access the shell, you're going to say sudo MySQL over here and press enter. Now once you do that, you will see some information being printed. So it talks about the connection ID, the server information, and it is giving you the server version over here. And it talks about some registered trademarks. And then you have some information as to how you can get the help. Okay, so this means that you have successfully logged in and you are able to access MySQL shell. Now after connecting to the database, your database might have different databases inside it. Okay, so you can just say show databases and it will give you the list of all the databases that exist in MySQL. So you can see over here, these are the default ones like information schema, MySQL, performance schema, and SES. All right. Now, after we are done with this, we need to exit the shell. So we can say exit over here and we have exited and returned to the normal prompt. So I'll clear this. Now, after installing and accessing MySQL shell, we need to do some security related configuration. So we need to say sudo MySQL _secure installation, like so. And I'll press enter. So it will print some messages over here. So it will say securing the MySQL server deployment, connecting to MySQL using a blank password, and it's talking about validate password component. And it says that this component can be used to test passwords and improve the security. It checks for the strength of password and allows users to set only those passwords which are secure enough. Okay, so it is telling you whether you would want to validate the password using this particular component. So ideally in production mode, you should say yes. But since I'm doing a local installation and this is for development and learning purpose, and we are not going to store any secure information over here, like any sensitive information. So I'm just going to say no over here. Now it is asking me, like by default, MySQL installation has an anonymous users, allowing anyone to log into MySQL without having to have a user account created for them. And this is intended only for testing and to make the installation a bit smoother. So you should remove them before moving to production. Okay. So do you want to have anonymous user into your account and allow anyone to connect to the database? Again, if you're using production environment or doing a production setup, you should say yes. But since I'm okay, I'll say no over here. Now it's asking you to set the password for root user. Now root user is like the admin user, and root user will be allowed to connect from the local host. So it's asking you whether you want to disable login remotely. I'll say no. And it's asking you whether you want to remove test database. So I'll say no again. Okay. And it is asking me to reload privileged tables now. I'll say no for everything. And we are all done. Okay. So we went through a series of steps over here. So we have completed the security related configuration, but one thing it did not ask us is to set the password for the root user. So we need to set the password for the root user. So if you scroll up over here, okay, we said no over here. We do not want to validate password, but it did not ask to set the password over here. So it says skipping password set for root as authentication with auth socket is used by default. If you would like to use password authentication instead, you can set the password by using alter user command. So we'll go by this approach. So I'll clear the screen here and I'll log in to MySQL shell over here. Okay. So I'm logged in to MySQL. Now I'm going to type in a command over here, which is a alter user command. And that is going to modify the password for my root user. So this is the alter user command that we should be using. So we are saying alter user. This is the user that is root at localhost, and we'll say identified with MySQL native password by you need to enter your password that you wish to set over here. So what I'm going to do is I'm going to remove this part. And I can enter any simple password over here. So I'll just set root over here. Okay. But if it's a production environment, you need to make sure you have complex passwords. So I'll just press enter. So it went to the new line because I have not added the semicolon. So I'll add semicolon and hit enter. Okay. So it says query OK. So we are done setting the password for the root user. Okay. Now what we need to do is I'll say exit. And I'll clear all of this. So now since the password setup for the root user is done, what we can do is we can try connecting to the database with the help of root user. So earlier we just said sudo MySQL and we logged in as anonymous user. But to log in as a specific user, you can say -u root and -p like so. And I'll press enter. So I'll be prompted for the password that I have set. I'll enter that password here and you will see that I have logged in to MySQL instance. Okay. And I can run queries over here. So I'll just exit and I'll say clear. So now, since we are done with the MySQL Server installation, which is the database, and it's a free database, like we have installed the community edition. Now we need an interface for that database. Like we don't want to use shell. So having an interface or a graphical user interface is really convenient. So for that, we are going to head over to Google, and in the browser, I'm going to go to google.com here. And here I'm going to search for something. So I'm going to say snap MySQL Workbench community. So I just search for this. So we are going to make use of Snap Package Manager over here to install MySQL Workbench Community Edition. Okay. And that is what I have searched on Google. So Snap is also a package manager by Ubuntu, and you can happily use this. So you will see this first link of Snapcraft. So I'll head over to this link over here and I'll say accept cookies. And this is what the interface of MySQL Workbench will look like. So I can click on install over here and you will get this command which you can copy. So I'll copy this command and I'll head over back to my terminal and I'll paste this particular command here and I'll press enter. Now, the moment you press enter, you will see all the processing that will happen, and it will download all the dependencies, prerequisites, and even the MySQL Workbench for us to use. So the process will take some time depending on your network connectivity and the system performance. But for me, after a while, it was successfully installed. And after the installation is done, you can just go to your application list and you can search for MySQL and you can open the Workbench software this way. So this will open up the MySQL Workbench. I'll go full screen on this. So you can see this is the software and here you have the list of all the connections. So from here, this is a client and it allows you to interact with the database. And from here, you are allowed to create multiple connections. So you might have different databases, like you might have a database on your local system. You might have a database that is of production and it's hosted somewhere on a cloud. And you might want to connect to different databases. So this way you can create connections from here. You can click on plus arrow, like plus icon, and this pop-up opens up, which enables you to set up and test your connection. And once you say OK, it saves the information over here. So we have a default connection created over here. You can right click and say edit connection and you can take a look at the different parameters that have been set by default. So we did not create this. It is created by default. And you can see over here, this is pointing to the local instance of MySQL Server. You have the host name as localhost. And the default port at which MySQL runs is 3306. And the username is root user. Okay. So I'll just say test connection and it will ask for the password. So I can enter the password that I had set. And I'll say OK. And you will see like a successful connection was made. So the connection is successful. Now what I can do is I can just double click on this and it will open up the query editor. Okay. So this is the query editor and this is the first look of MySQL Workbench. All right. So with this, we have successfully set up MySQL Server Community Edition onto our Ubuntu Linux system. We have also installed MySQL Workbench onto our system and we have successfully created a connection from MySQL Workbench to MySQL database. And we are now able to access the database objects from here. All right. So that's about the installation of MySQL on Ubuntu. Hey there, welcome to this class. So let us do a quick overview of MySQL Workbench interface. Okay. So you're going to see this particular interface when you open MySQL Workbench for the first time. And there are different panes over here. Okay. So on the left hand side, you can see the administration tool over here. Okay, and you can see administration written over here, and you can see different tasks that can be done over here. So you can like get performance reports, and you can check the server logs, startup, shutdown. So all the admin related tasks can happen from here. Now in the same window here, in the same pane, you have this tab called schemas. Now schema is nothing but the databases. So you can see over here, SYS. So it's a collection of database objects. So you have one schema already present over here, which is sys. And you can see the tables inside. So here you can see different database objects like tables, views, stored procedures, and functions. Okay. And this is something that we got by default. All right. And within tables, you can see you have columns, indexes, and so on. Okay. So you can view all that information from here. This is about the two tabs that you see over here. So whatever schemas you create will appear on the side. Now here you have at the bottom, you have the sidebar panel. This is like the information about the object, as you can see, object info at the bottom left. And then you have the information about the session over here. So this is a session, and this is the information about this particular session that I'm having with the MySQL server. Then here, this bottom bar, which we can expand also, and we can reduce the size. This is the output panel, and this is where you will see all the output. So you can see over here, text output, history output, action output, and so on. So you will see time, action, message, and duration. So on the right hand side over here, there is a pane called SQL Additions, and this is the help panel. So you can click on this drop down and you can select any SQL command and you will get the documentation for the same. So any command you can select and you can know more about that particular command. So I'll collapse this a bit. And here in the center, you have the main query panel where we are going to write our queries. Okay, so whatever queries you write in, you'll be writing over here. And at the top, you have different buttons over here. So you can see here, this is the open script file in this editor. So if you have any script file that has been saved on your system, you can like go to that particular folder and open that script over here. You have the save option, which means that whatever you type in over here, you can get that saved as a script to a file. Then here you have execute buttons. So these are two execute buttons you see. So one is execute the selected portion of the script. And here you have execute the statement under the keyboard cursor. All right. So you can see over here, if I type in, let's say show databases, I'll say show databases, and I'll end this with the semicolon and I'll say execute. So you will see the list of all the databases that exist in our system. So you can see these are some of the default databases that we have got. And here you can see the output. So we ran this particular query, we got 4 rows returned and the duration was 0.00 seconds. All right. Now what the difference between these two is, so this will actually run everything. So it will run either the selected portion, or if you have not selected anything, it will run the entire script. But if you want only one statement to run, so let's say if you have multiple statements, so the script file can have multiple statements. Okay. And if you want only this one part to run, you need to take your cursor on that statement and you need to execute this. Okay, you need to say this, you need to press this button. So this will execute the statement under the cursor, and how it categorizes a statement is with the end of the semicolon. So it will execute till this semicolon ends. Okay. Now if by chance, if I press this button, you will see like it was executed multiple times. So since we have written show databases 3 times, it was executed 3 times. So if I right click over here and if I say clear, and if I press this lightning symbol again, you will see it got executed thrice. And if I select this particular thing over here, and if I click this, so it will get executed only once. Okay. So there's a difference between these two buttons. So the first button will execute the selected portion of the script or everything if there is no selection. And the next button will execute the statement under the keyboard cursor. All right.
Then you have different buttons over here, like you have this drop down. So whenever you are selecting data from a particular table, and if that data is in thousands, so here you have this drop down wherein you say limit to 1000 rows, so that you don't end up loading everything into this particular tool here. Okay, so this is for efficiency purposes. If you want to modify this, you can modify this as per your choice, but we'll stick to defaults over here. Okay, then you have multiple options over here. So you can see create a new SQL tab for executing scripts. So this will give you a new tab or a new script file. And here you have a button which says open a SQL script file. Okay. And using this, you can create a new schema on the connected server. And using this, you can create a new table. So there are different options that you can explore over here. Okay. New stored procedure, new functions. So this is just for creating different kinds of database objects like tables, stored procedures, views, and so on, and even functions. Okay. So this is about the interface. At the top, you have different menu options like every software has. Okay. And if you are looking for anything specific, you can just explore these options at the top. So now I can even customize the appearance over here. So you can go to the menu bar over here in edit. You can go to preferences. And here you can see different settings about Workbench. So I'll go to font and colors, and here you can see different font options and different scheme depending on your system. Okay. So I'm having font options for SQL editor, result set grid, scripting shell, and script editor. So I'll increase the font for everything. So I'll increase this to 30, this one to 20, and this one to 20. Okay. So I'm purposely increasing this because since I'm teaching, the font size is pretty less and I want my students to see clearly. Now, you don't see any changes, but if you open a new editor file, you will see the font size has increased. So I can say show databases, and this is like pretty neat. Okay, and I can run this. You'll see this is much more bigger than the earlier one, and this gives a clear view. So this is perfectly as per your preference and choice. If you wish to customize the appearance, you can happily go to edit and preferences and change it. If you don't wish to, that's completely fine. It's absolutely your preference and your choice. So this is about the MySQL Workbench interface. All right. So that's about this class, and I shall see you all soon. So now it's time that we get up and running with our database. So we need to make sure that our application works with this MySQL database. And for that, we are going to need to do some setup over here in MySQL. And also we are going to do some configuration changes to get our app working with this database. All right. So here I am logged into MySQL Workbench. I'm logged in as a root user. And here you can see I already have few schemas databases created on the left-hand side panel in the navigator. What I'm going to do is I'm going to right click over here in the navigator and I'm going to select create schema over here. Now here I'm going to say you can give whatever name you want. I'm giving my database or my schema name as secure notes. Okay, you can give it whatever you want to. I'll say apply, and you can see it will show you the query over here, and I'll say apply over here. Okay, I'll say finish, and I'll close this, and here you'll see secure nodes being created. So I'll double tap on this, and right now you don't have any tables inside over here. All right. Now what we need to do is, since we have the database schema set up, we need to switch over to our application, and we need to make sure that our application makes use of this thing that we just created. So I'll switch over to our application here, and here first thing what we need to do is we need to head over to pom.xml. So I'm going to just say pom.xml over here, and here you'll notice we have the JPA dependency. Okay, I have all the dependency like security, web, everything, but I don't have the dependency added for MySQL. Okay, since that's the database that we're making use of, we need to add the dependencies that will help us with all the configuration related work and all the connectors as well. So I'll switch over to our favorite website. Yes.
Spring initializer. I'll say add the dependency. And over here, I'm going to just type in MySQL. I'm going to make sure that I select Maven because we are making use of Maven and not Gradle. If you're using otherwise, then you can select Gradle over here. And version and all don't matter since we just need the dependency. So I'll go to Explore and I'll scroll down. You'll see MySQL connector dependency over here. So what I'll do is I'll just copy this. I'll make sure that there is nothing else that I'm missing for MySQL, nothing else. I'll just copy this. I'll come over here and here within dependency, I'm just going to paste this. Okay. So this is added. And the moment you update or make any changes to the pom.xml, what happens? You need to reload all the Maven changes by clicking on this icon that appears. If this icon does not appear, of course, you can go over here and reload Maven changes or reload all Maven projects manually. So I'm just going to hit this icon and you'll see some processing here at the bottom, which will fetch all the dependencies, right? So we have the dependencies done right now. And now it's time that we need to tell Spring over here, Spring Boot. Okay, so I'm going to head over to application properties. Okay, now we need to tell Spring Boot the details of the database. So Spring Boot now knows that we want to make use of MySQL database. Okay, how does it know? Because we have added this dependency. So Spring Boot is smart enough. Okay, and it says, okay, this particular person wants this app to use MySQL. But what it needs to do is, where is the database located? What are the credentials? How should I connect to the database? Which database should I make use of? So all of that information you need to provide this application. And as a result, we are going to update the application.properties. All right. And this is the configuration that we are going to need. So I already have this typed in over here. Okay. You can see like this file I'll be providing as resources. So you can get this. And here you can see I have the URL. Okay, so this is the URL of the database. I have the username, I have the password, and I have this DDL auto, and I have this dialect specified. Okay, now I'll copy all of this. Okay, I'll talk about what each property means, but for now I'll copy this. I'll come over here to application properties and I'll add all of this over here. Okay. Now let us go through each thing over here. So first thing is we specify the data source URL. Okay. Now over here we specify the JDBC, which is the protocol. We specify the database type, which is MySQL. And then we have the database URL. So this is a database URL, which is running on localhost 3306. Now localhost because it's running on my local machine, and 3306 because that's the default port as to where MySQL database runs. Okay, so we are clear. It's protocol, the type of database, and the URL along with the port number. And this thing over here is the database or the schema name over here. Okay, so this I've specified the database name. Now here I have the username. So Spring Boot needs to know how it's supposed to connect to the database. So I've specified the username over here, and here I need to specify the password as well. Now you can specify the password you have, okay, but my password is really simple, okay, because this is like a test database that I have locally installed. Okay, so I'll specify the password, and then you need to also specify how the schema needs to be managed. So I've specified update over here. There are quite a few properties that you can specify over here, like create, drop, and so on. Okay, but I'll just stick to update. So what this means is if there is any schema changes into the application, those are being pushed as the update over here. Okay, or those are being propagated as the update to the database. Create, drop, and create means the database will be recreated every time. Okay, but I don't want to recreate because we would lose the data. So I'll just say update over here. And here we have specified the dialect. Okay. So dialect means how the query is to be generated. So since we are making use of MySQL, we need to specify MySQL dialect, right? And we are done with the configuration. Yeah. So our application is now ready to work with MySQL over here, MySQL database. All right. So I hope you have been able to follow, and I hope you have clarity as of the steps that we need to follow. Okay. And I hope this was useful. So now it's time that we get our app up and running and we test everything that we've done so far and see if it works as expected. So I'm here in IntelliJ. What I'm going to do is I'm going to say run over here. Okay. But before hitting this run button, I would want to show you that the tables here in secure notes is empty. Okay. So this does not have anything. Okay. And we have MySQL configured. What I'll do is I'll say run over here. Okay. And if you go to models over here, let me see models. Here you have one model. Okay. So this one model should appear in the database. So the app is running, you can see. Okay. And if you come over here, if I hit refresh, we should see one table over here, which is the notes table. And that is what you see. So if you click on this icon, this table like icon here besides the table, you should see a select star running and you should have the details over here. Okay. And you can see the columns from here also. Okay. So yeah, we are seeing the table being created, and this means that the connection to the database has been successful and our app is able to interact and work with the database. Now what we need to do is we have control over here. So I'll just minimize this. We have controller. We need to test all these APIs. Okay. We'll make use of Postman over here and we need to create every API. So we have like create note. We have get mapping to get a user's note. We need put mapping and delete mapping. So basically CRUD operations. Now creating this API was time consuming. So what I've done is I over here have this notepad open where I have a JSON. Okay. So this is the JSON for the collection of the CRUD operations for the nodes. You can see. Okay. This is a JSON and this will save a little bit of time for us, and I'll have this attached as the resources so that you can also leverage this and save a bit of time. Okay. And you can see this has all the information that Postman needs to create the requests for us. So here we can either create manually, like you can create a new collection from here. Okay. And you can create REST APIs manually like this and save them, or you can import this JSON which has the structure of the API that we need to test. Okay. So I'm going to make use of this over here. And you can see over here, the collection name over here is Secure Notes API. But if you come here in the Postman, we already have a collection with this name. So I'm just going to rename this one. All right. So here, okay, we don't have the rename option. Here we have the rename option. And I'm going to say Secure Notes API course, you can say. Okay. I'll just have a little bit of distinction. And what I'm going to do is I'm just going to copy this. You can open this in any text editor. I've opened it in Notepad++, but you can open it in normal Notepad as well. So Notepad++ just formats it and shows the color coding here. So I'll copy this, everything, and I'll come over here. I have my app running too. I'll say over here, you can see this import button. So I'll just click on this. And you can see here you can paste the curl in the request part to import, or you can even paste the raw text or the URL. You can see. So I'll just paste the JSON here. And the moment I paste, you can see the pop-up that we had went away. And here you can see 2 imports completed. All right. I'll just dismiss this and I'll collapse this and I'll open this. This is the one that we imported just now, and you can see the request endpoints are now created. All right. I'll just close all of this. Okay. So here we have this request. So I'll just close all the tabs. And now I'll just click on create note over here. Okay. You have get user notes. You can see get request. You have headers. You don't have anything in headers, but you have nothing in body as well. Okay. So get request does not need anything in body, but the endpoint is set. So I hope you get how this is saving time for us. So I'll just say get user notes. You'll see we get unauthorized. Of course, we will get this. So what we can do is we need to pass in the authorization information here. So I'm going to come over to the auth tab and I'm going to select basic over here, and I have my admin and password as password being entered over here. I'll say send. Now the moment you say send, you can see like there is no note being created into a database. What you can do is I'll click on console. I'll go over here. And I can even copy the authorization header from here. You can, if you see the authorization header here. Okay. So we see the header over here. I'm just going to copy this header. Okay, this entire piece, so that we don't have to enter the credentials here. So I'll say over here no auth, and I'll come over here. I'll say authorization, something like this, and I'll pass in this over here. And this will also work fine. You can see 200 okay over here. Okay, so this is the get user nodes. I'll just save this since we made the change. I'll go to create node. Okay, so user node is empty. But here I can say, so if I try to create the node over here like this, I'm going to get 401 unauthorized, of course. We need to pass in the authentication information. And if you see the body of the request, you can see we have the body over here. Okay, and this is a body that is being expected by the create node endpoint over here. You can see request body has content. Okay, and that content will go and sit over here as string. So what I can do over here is I can go to header. I can say authorization, and I can pass in this information here, and I'll say send. Okay, I'm still getting this error here. If I go to auth, I'm getting 401 unauthorized, and you need to make sure that auth type is disabled over here, no auth. You should not have inherit auth from parent. So I'll say no auth, only then the headers will pass in. Now if I say send, I'm still getting this error. So we are getting 401 unauthorized despite everything being okay, and even me entering the credentials from here. Okay. Now why is this error over here? So for that, I'm going to head over here, and you will see like I'm not getting anything on logs as well. Okay. So what I'm going to do is I'm going to enable logging over here, and we'll see what is the issue that we are facing right now. And logging will help us understand what is the issue. So I'll say logging. I'll enable logs for the Spring framework, Spring security. Okay, so I'm going to say framework.security, and I'm going to enable debug over here. Let me rerun this. Let us see what the output looks like. So you'll see a lot more logs now. Okay, now if I say send, and if you come over here, okay, you will see some logs over here. So you're seeing, okay, you're seeing over here that invalid CSRF token found for this. So we are not passing any CSRF token right now. Are we passing any additional token? No, but still we are getting this error. Okay, and this is a feature of Spring Security wherein it expects a CSRF token for any sort of request or that is trying to modify something in the database. And right now this post request is trying to modify things in the database. So it's expecting a CSRF token to validate that this is not a attack. Okay. So what I'm going to do is I'm going to come over here in the security file, wherever our security config is. So our security config is over here, and I'm going to just add a single line of code here. Okay. So I'm going to say over here, we have all of this, okay, and we need one line which says that we want to disable CSRF. So I'm going to say over here, just after this line, I can say http.csrf, you can see here, and I can say CSRF and something like this over here, and I can say CSRF.disable over here. I'll end this with a semicolon. And you might see this warning, okay, you need to replace lambda with a method reference. That is what it's suggesting you. I can do that. Or even if I stick to that, what I typed in, that's perfectly fine. Now I'll rerun this application. Let us rerun. All right. And this should work now. So it's running. And now if I come over here, okay, if I say send, you can see the note is created because we have disabled the CSRF now, right? And you can see over here, okay, the user detail is also being printed, you can see, and this is coming in from the controller. So if you come here to the controller, you can see the user details as username. Okay, and where are we getting this from? You're getting this from the authentication principle, like using this annotation and with the help of user details object. Okay, so you can see all of that being printed, and we are able to identify. So you can see all of those being printed, and we are able to identify who the user is who is sending is the request. Okay, and we can just say no auth over here. we can pass in the header and we can create one more node. So I can say your node content here 2. I can say send. You can see the content is created. Okay, and if you want to verify this, what you can do is I'll hit save over here. I'll go to get user nodes and I'll say send. You can see like the user nodes appear over here. You can see the first node, the second node, and the owner username is also set to admin. You can see over here everything, right? So this is awesome. You can even update the node over here. You can pass in the node ID. So here you will have the variable. I'll just replace with node ID 2. I'll head over to body and updated node content here, which is fine. I'll just go to header and we'll copy the header. Okay, whatever header we passed in over here. I'll just copy this. I'll come over here. I'll say authorization and here I'll paste this and I'll update. You can see it's updated now. Okay, and we can even delete the node. All right. For deleting, we also need to pass in the node ID over here. I can say node ID 2 and I can pass in the header here. Okay, I can say authorization and I can pass in this. Okay, but I won't delete right now. We'll check the details in the database. I'll just run this query again. I'll run this and you can see the data being populated here. Okay, so it's interacting actually with the database, and our database is storing all the data in the persistent way. Okay, so we have the APIs working with Spring Security, as you can see, and I can delete node 2 over here. I can just say delete. I can try getting the user nodes and you will get only one node now, right? If you come over here, if you run the query again, there will be only one node. So I hope this is working fine, and I hope you have some clarity as to how this entire piece of code is working. All right. So I hope this was useful. And if you come over here, you will see the logs as well. These logs are telling you as to who the user is. Okay. And this is because we are printing this over here. You don't need to print actually. If you go to production, you need to remove all these logs. But right now we are developing and we are building, we are learning. So it's absolutely okay to print this information to get a sense as to what is happening behind the scenes. So I hope you have been able to follow, and I hope this was useful. So now it's time that we should update our security configurations for our nodes project, secure nodes project, in fact. So right now we have a lot of stuff here, like which we don't need. Essentially, we are like rejecting all the requests on this admin endpoint, right? We don't need this because we just added this for learning purpose. So what I would do is I have a set of here. So I have a set of updated configuration, which I'm just going to copy here. It's the security config class. I'm going to come over here. Okay. We don't need these things like having session as stateless and all. So I'm just going to replace this entire class over here. And I'm just going to paste this, something like this, right? So the update is done. You can see like the config is straightforward, pretty straightforward. First, what we are doing is we are saying that we want to authorize every request. Okay, we are disabling the CSRF checks, which is fine. We need this because we have not implemented the CSRF protection yet. So I'll just disable this for now. And we have the basic authentication enabled, and we are returning the object using HTTP build over here. Okay, so this is the updated security config, and this should work going forward for our project. So I hope you were able to follow, and I hope this was useful. So now let's talk about authentication providers and understand what they are. So authentication providers in Spring Security are components that are responsible for processing authentication requests. So essentially what they would do is they would handle the actual verification of credentials provided by a user during the login process. Now, these credentials would consist of usernames and password or any form of authentication means, and the providers would do the job of verifying them. Now, an authentication provider is an implementation of an interface that exists, which is Authentication Provider Interface. This is inbuilt, And multiple providers can essentially be configured in the application to handle different types of authentication. Now, let's talk about the key responsibilities of authentication providers. Now, number one responsibility is to authenticate the user. Now, what this means is the verification part of the user credentials against a particular data source, such as the database or any external authentication service or something like that, would be done by the authentication provider itself. That is one key responsibility of the authentication provider. Now, I'm telling like the credentials would be verified against the database or external authentication service because depending on your requirement, you might implement different things. So for example, if you're building an application, at times you might have the credentials residing in your database. So essentially you are authenticating your users against the database. Sometimes you might have one more mode of authenticating users. You might have multiple options given to users. So user can also authenticate himself with providers such as Google, Facebook. So you can log in using Google, log in using Facebook, and so on, right? So in that case, the verification that is being done of the credentials is against something else and not the database. Okay. So depending on what you're building, the authentication provider would come into action, and depending on your configuration or the code that you have written as per your requirement, the authentication of the user would be done. So this is one responsibility wherein the authentication provider is responsible for authenticating the user. Second responsibility is to create an authentication token. So once the authentication is successful, the authentication provider would be responsible to generate an authentication object that would encapsulate the user credentials and authorities in it. Okay, and this would be set. So these two are the key responsibilities of authentication provider. And this is something that you need to understand, okay? Because normally if you are going for interviews or if you are building stuff, it's best that you understand who does what, okay? So this is the clear responsibility of authentication providers. Now, there are a few things that I want to talk about in the context of the importance of authentication providers with respect to Spring security. The number one important factor over here is flexibility. Okay. Now, Spring security allows you to configure multiple authentication providers. This enables you to support various authentication mechanisms such as database authentication, LDAP, OAuth, or any sort of custom authentication logic. Okay. So the point I'm trying to make over here is configuring your own authentication provider is really easy depending on what you're configuring. And you can have multiple authentication providers as well in a single application. So imagine this, you must have seen or visited a web page wherein you are being presented with multiple login options into a website. For example, you can log in using your email and password. You can log in using login with Google. You can log in using GitHub, Facebook, and so on, right? So similar way, if you're building an application with Spring Boot, you can have an authentication provider to authenticate users with email and password. And of course, this would be matched against the one in the database. You can have an authentication provider written separately to authenticate users against, let's say, OAuth2 providers. And if you're using LDAP system or something like that, you can even have authentication providers for them as well. So number one thing is flexibility, because Spring security allows you to configure multiple authentication providers in your application. Point number two is separation of concerns. Now, by using authentication providers, the authentication logic is actually decoupled from the main application logic, right? So you are decoupling the authentication logic, and this simplifies the maintenance and enhances the security of the application. The third important thing over here is extensibility. So you can easily extend and customize the authentication providers to meet specific requirements. For example, if you're integrating with third-party identity providers or implementing custom authentication rules and so on, then you can extend and customize the authentication providers to meet your requirements. That is also possible. Security. Now, authentication providers ensure that the credentials are validated securely and consistently, right? And the centralization of the authentication logic also helps mitigate security risks such as unauthorized access or any sort of credential thefts, right? So this is about the importance of authentication providers and a general overview. So I hope you all enjoyed this and found it useful. So now it's time that we talk about some different authentication providers that exist. And we'll talk about each one of them and why they exist. Because if you're working with Spring Security a lot, then it's likely that you will hear about these providers over a period of time. And this knowledge will help you understand what they are in future. Okay. So here, the first one I'm going to talk about is DAO Authentication Provider. Now, this is the default authentication provider that exists in Spring Security. And whenever you don't have any authentication provider defined by yourself, Spring Security is going to make use of DAO Authentication Provider. And like I said, this is the default one that exists. Okay. So if you head over to IntelliJ, here you'll see this DAO authentication provider. Okay. And you can see this is an authentication provider implementation that retrieves the detail from the user details service. Okay. So every authentication provider that we talk about is an implementation of authentication provider interface that exists over here. Okay. So this indicates that a class can process a specific authentication implementation. Okay. So you have to implement this if you want to provide an authentication implementation to Spring Security. Okay. And you can see there are two methods here. One is supports and one is authenticate. And you can see over here, this particular method authenticate will perform the authentication. So the authentication provider is inbuilt one that implements these two methods. Okay. So if you scroll down over here, okay, here you should see authenticate a method here. So authenticate method is not present over here, but in fact you have to go to abstract user details authentication. Okay, so this is the one that that is being extended, okay, by DAO authentication provider. This particular class, which is marked as abstract, this actually provides the implementation or the definition for this. Okay, so yeah, we have DAO authentication provider, and this is a default one that exists, like I said. Then we have in-memory authentication provider. Now, what is in-memory authentication provider? This provider is used to authenticate users against in-memory credentials. Okay, so credentials are not persisting in the database, but they are held in memory. Now, there is no class for this. This has to be directly configured into the code base. All right. Then you have LDAP authentication provider. Now, this also does not exist as a separate class, but this need to be configured through LDAP authentication provider configurer. So if you come over to IntelliJ, if you search for, or let me go over here, authentication provider, and if I say control P over here, this is going to give me all the implementation of this interface. And here you can see LDAP authentication provider configurer. So using this, you can configure the LDAP authentication provider. Okay. And we don't have a class for this. Okay. To configure LDAP as the authentication method, you also need to add a few dependencies. And that is something that we have not added right now because we are not making use of LDAP yet. Okay. But this is a provider that you need to know. All right. We also have Active Directory LDAP authentication provider. Okay. And this is used for Active Directory authentication. And we won't find the authentication provider for this as well, because this also comes with a separate dependency. Okay, we don't have it right now. And then we have pre-authenticated authentication provider. Now, this exists for single sign-on, okay, or any sort of external pre-authentication. And it exists here. If you scroll to the right, you can see it exists over here. It has its own version of authenticate method as well. Okay. And you can see it implements authentication provider over here, authentication provider interface. And you can see over here processes a pre-authenticated authentication request. The request will typically originate from this filter. You can see. So this filter is what will be the source of the request over here. Okay. You can see over here, this authentication provider will not perform any checks on the request as they are pre-authenticated. Okay. So yeah, this is one more provider that exists. Then you have OAuth2 authentication provider. And this particular provider is used to authenticate users using OAuth. So if you have Google sign-in, Facebook sign-in, GitHub sign-in, all of that is being managed by this provider. I don't have the class for this right now in the project. For configuring OAuth2, you need to add a few dependencies. And that is something we have not added yet because we are not making use of this provider. But this is something that you need to know. Okay, so these are a few authentication providers that you need to know and why they exist. Okay, so this gives you a brief overview of what they are and why they exist. So I hope this was useful. So now it's time that we talk about authentication provider, and authentication provider over here is an interface in Spring Security. Now, it's a key component in Spring Security's authentication framework as it's responsible for processing the authentication request, verifying the provided credentials, and so on, right? So I'll talk about a few details which will help you understand more about this interface. So first thing to note is the package it exists in. Okay, so this is where this interface exists. And if you take a look at the structure, so I'll press Control F12, or if you're on Mac, you can press Command F12, and you will be shown the structure of this class over here. Okay, it's not a class, it's an interface, but you'll be shown the structure. So you can see over here that it has two methods in it, Authenticate and Supports, right? Now, what is Authenticate? So if we go to the Authenticate method here, this is what the Authenticate method is. Okay, so you can see this method is responsible for performing the actual authentication. And if you see this method signature, it takes in the authentication object as a parameter, and this particular parameter contains the credentials of the user, like the username and the password that the user has provided along with the request. And if the authentication is successful, it returns the fully populated authentication object. And this is typically an instance of username password authentication token. Okay, and this would return the fully populated object of authentication. Now, what I mean by fully populated is it will have all the other details like user authorities, roles, permissions, and all. Right. So after the authentication, the details are populated into this object and they are returned from this particular method. Now, if the authentication fails over here, so it will throw this particular exception, authentication exception over here. Now, one thing to make a note over here is there is one more method over here, which is supports. Now, what is this supports method? Okay, so there is some detail about this particular method here. So it returns true if the authentication provider supports the indicated authentication object. Okay. So this method, what this method will do is it will check if the authentication provider can handle the type of authentication passed to it. It returns true if the authentication provider supports the specified authentication class, or else it will return false. Now this allows the authentication manager, who is calling this, to determine which provider should process a given authentication request, right? So you know, like there can be multiple authentication providers defined in a particular project. So you might have an authentication provider for OAuth2, you might have an authentication provider for username password. Now, depending on the type of request, the authentication manager will check if the authentication provider supports the authentication object. If it supports, it will go ahead with the authentication, else it will return a false. So that is how things work over here. Okay. Now, what happens over here is, so if you go to DAO authentication provider, okay, so this is the authentication provider, and if you press Control F12, you won't see supports implemented over here, okay, but in fact you will see support over here in this parent class. So if you go over here, which is, it's an abstract class, and if you press Control F12 here, you should see supports over here. You can see supports. So this particular method is implemented and overridden, and it's coming in from, of course, we know where, authentication provider. Okay, so over here, if you scroll up, authentication provider. Okay, so yeah, that's about the authentication provider interface. Just to reiterate on the flow, this is the flow that we have been talking about. So what happens here is when the user attempts to log in with their credentials over here, the authentication object is created and then it is delegated to Authentication Manager, and Authentication Manager calls the Authenticate method on each authentication provider it manages, and it passes the authentication object to each one until each one of them successfully, until any one of them, I should say, okay, not each one of them, until any one of them successfully authenticates the user. Okay, and once it finds the authentication provider that can authenticate the user, what it's going to do is it is going to load the user details, and it is going to match the password using the password encoder. Okay, and this is going to be done by authentication provider over here. Okay, so yeah, this is the entire process. So in the end, if the credentials are valid and the authentication has been successful, then the authentication provider will return a fully populated authenticated object, or authentication object I should say, which will contain the user details as well as the roles that the user has, and that would be used for authorization. Okay, and if no provider can authenticate the request, the authentication exception is thrown. Okay, so I hope this clears out the entire process. So you have authentication filter, authentication manager. Authentication manager will call the authentication provider's authenticate method. Okay, so it will look for every authentication provider that exists, and it will check using the authenticate method. It will also check using support. And so first it will check using support method whether it supports or not. If it supports, then it will call the authenticate method, right? And then the process finishes of authenticating, and then the details are returned to the security context. So understanding this process is really important. I'm stressing on these minute details, I know, and this is being done purposely so that you understand this entire concept. Many students or many people who go out for a job, looking out for opportunity, working on real world project, they don't understand these internal workings. It's important that you understand these internal workings so that in real world hands-on project, you are clear as to what is happening, where it's happening. If there is any issue, you should be able to debug it. Right? So that's the capability you should have, and that is what I am working to provide you. So that's about the authentication provider interface. I hope this was useful. So now it's time that we start talking about in-memory authentication and understand what it is. So what is in-memory authentication? In-memory authentication is a method of storing and managing user credentials directly within the application's memory rather than in an external database or directory service or something similar. Okay. Now, this approach is commonly used for small applications, prototypes, or during development and testing phases of the apps. And within in-memory authentication, the user details like username, password, roles are hard-coded in the application configuration. And when the user tries to log in, the application checks these in-memory credentials to authenticate the user. Okay. Now, let me explain this to you with the help of this diagram that you see on the screen. So here you can see you have authentication provider. Okay. Now, let's say we are working with DAO authentication provider. And this provider will do the job of getting the user details with the help of UserDetailsService. And UserDetailsService will call load by username, right? Now, this load by username is being called, and this will internally use find by username. This is a repository method. Now, this particular method is being called, and the data is being fetched from the memory and not from the database, as you can see. So within the application memory, this data is residing. It's not persistent in the database. So if the application stops, the data is gone. That is how it works. Okay. So the data is preserved only until the life cycle of the application, right? Once you stop the application, the memory is cleared. And this is then matched using password encoder, and the rest of the process continues. All right. Now, you might say, what could be the use case of this? Okay, now there are few use cases that I can think of. First thing is development and testing. So I personally use in-memory authentication a lot whenever I am testing something or building something really quick, right? And I need to test a couple of concepts. So in that particular case, it's very obvious that developers will make use of this kind of authentication. And the reason is because it allows developers to quickly set up test authentication without needing a full-fledged database or any sort of external user management system, right? And this is also useful for small and simple applications where the number of users is limited and the security requirements are not too stringent, right? So in-memory authentication can be a straightforward solution over there. So these are a couple of use cases, and then you also have prototyping. So when you are working on certain small prototypes or proof of concept applications, wherein you just need to create the applications to present it to the client, right? It's not going to go to production, but you need to convince the client that you are capable of doing this particular job, or your company can take up this project. So in that particular case, you are just presenting it as a POC and you don't need a full-fledged database, right? So in that case, you can make use of in-memory authentication, and this helps in quickly demonstrating the functionality without the overhead of setting up the database. It's quick as well, right? So these are a few use cases, and the benefits, of course, you can easily guess the benefits. Simplicity, right? It's easy to set up, requires minimal setup compared to configuring database, integrate with the external authentication providers, and so on, right? So it's simple, speed. It's really, really fast because user credentials are stored in memory. Okay, there is no database interaction. Authentication checks are very fast, and there is no need to query the database or an external service. Convenience. Yes, it allows developers to hardcode multiple users within the memory itself with different roles and permissions quickly, making it convenient for testing different scenarios. So if you are testing different scenarios based on roles, you can quickly hardcode a few users with different roles and test it out, right? So these are few benefits, and I should say these are few use cases, benefits of in-memory authentication, which can give you a hawk-eye view of what this is exactly, right? So I hope you have been able to follow, and I hope this was useful. So now it's time that we head over to security configuration of our application and set up the application for in-memory authentication. So what I'm going to do is I have some code pre-written over here, as you can see. And here, this is the code that will help us set up the in-memory authentication for our application. So I'm going to copy this. We are going to understand every bit of this code. Don't worry about that. But for now, I'll copy this and paste it over here. And here then in the IDE, I'll talk about everything. Okay. So here, first thing you need to know is we need to get the imports done. Of course, that's obvious. So I'll get all the imports here. I'll just start importing everything. Okay. And there are 3-4 imports that we are going to need. Okay. Let me take this to new line, something like this, so that we have everything in one screen without a scroll. Now let's understand what we are doing over here. Okay, so what we are doing is we are creating a bean, okay, called UserDetailsService, that is returning the type of UserDetailsService over here. Okay, and within this we are creating an object of in-memory UserDetailsManager. Okay, and with the help of this in-memory UserDetailsManager, we will set up the in-memory authentication. So what we are doing is, within this manager, we have this method called createUser and userExist. Okay, so first we are checking if the user exists, right? So if you look at this code, we are creating two users actually. So one with this username and the other user with this username and password over here. I'll explain everything, Noop and everything, what this means and all. But for now, just focus that we are creating two users with these usernames. Okay. So our application is now turning out to be a multi-user application, people. Right now, we had only single user configured. So if you come over here, we had only single user configured over here, right? If you want multiple user, you cannot configure that over here, right? But generally or normally, if you see any application running on a server, they would have multiple users. So this is the first thing that we have achieved here. We have multiple user, which means we have multi-user application now, right? Now we are making use of in-memory user details manager. We are checking if the user exists with this username. If it exists, we are not creating the user. If it does not exist, then we are making use of this manager again, and we are saying create the user. Okay. So what it's going to do is it will create this user, and you're specifying all the details here. Okay. You are getting the user object first. Okay. So you're saying user. So this user object is being created over here. You're saying user dot with username, with this password, and with this role, build this user object for me. That is what you're saying over here with this entire piece of code. Okay. And then this user object is passed on as an input to create user. So if you hover on create user, let me hover, you'll see that it accepts the type of user details object over here, right? And we are passing in exactly that over here, right? You can even cut this code here, and you can create a user over here as well. So you can create user details here, something like that. And you can say user one. Okay. And you can create user something like this as well. It's totally up to you, but I'm just showing different ways of doing things. Okay. You can then pass in the user one here. Okay. This is also right. There's nothing wrong in here. Okay. But we are creating the user details object first, and then we are passing in over here. But I don't want to do that. I'm just showing you different ways of doing things so that it's clear for the explanation standpoint. I'll just do Control C, and I'll get everything as before. Okay. So user detail is being created here on the fly, and it's being passed to create user, and create user will create the user. And this is being created in memory like the name of the class says. Okay. So if you hover on this, you can see over here, it is in memory user details manager, right? And you can see it's backed by in-memory map, mainly intended for testing and demonstration purpose. Okay, you can go to this class and you can read more about it. You can see the documentation here. Okay, so this is what it is. We are making use of this, and we are creating the user, and we are returning the manager. That is it. Okay, with this, the users will be created within the memory. Okay, and one more thing I want to talk about is this noob thing. So what happens is we are ideally supposed to encrypt the password and not store the password in a plain text format, right? We are not supposed to store the passwords in a plain text format. Why? Because any developer who has access to the database can read the passwords in that case, right? Of all the users. So it's a production grade practice that you should always encrypt the password and store it so that nobody can read it, right? Now over here, we don't want to apply any encryption. We are learning, and we have not learned about encryption yet. Okay, so for the purpose of demonstration, I'm saying NOOP over here within the pair of curly braces, which means that I'm not performing any encryption over here. Okay, so these are supposed to be stored as plain text password is what I'm telling Spring Security. Okay, and with the help of this, Spring Security will know that these are supposed to be stored in plain text format with no encoding, and I'm aware of this as a developer. That is what Spring Security will understand. Okay. And I'm doing the same for admin as well. Okay. So I hope this is clear, and I hope you have been able to follow as to what we are doing and how we are doing things. So you can imagine how easy things are with Spring Security. You are just creating bean and everything else is taken care of. You just specify the what you need, and you specify the details of what you need, and how part is taken care by Spring Security and the entire framework out there. Right? So I hope this is awesome, and I hope you have been able to follow along. All right. So now it's time that we test our changes, right? So what we would do is I would start the application, and we would see if everything works perfectly fine, whether we see any sort of errors or no. So we don't see any errors. You can see the application is up and running. Now I'll switch over to Postman, and what we would do is we would query, or we would send a request, in fact, to our application. All right. So I would come over here, create node. Okay. And here, if you go to body, we have the body, which is in the form of JSON to create a node. We'll go to header. So now I will just uncheck this for a while. Okay, I won't send this authorization header because I want to test with the new users that have been created. So I'll select basic auth over here, and I'll say user one. and the password is password1. Okay, just make sure you enter the right credentials over here, user1 and password1, and then over here admin and admin pass. Okay, I'll come over here and we are creating the note against this particular user. So I'll say send, and you can see there is a note created now, right? ID is 5. You can see the content, and you can see the owner user name over here, right? And if you go over here, right, on MySQL, and if you run, you can see that the note has been created, and you can see the username of the owner is user1 over here, which is absolutely great. And you can come over here. I'll change this to admin, and you can also change this to admin pass, something like this. And you can say send over here. You can see now the note is created against admin user because you are authenticated using that user credentials. If you come over here, you can run this. Okay, and you should see one more node being added, right? So you can imagine, like, we are now able to in fact create nodes against those users, and we are able to authenticate the users. Until now, you're not seeing the users being stored in the database. So if you refresh over here, if I say refresh, you will see there is only one table, and we are not storing the user credentials into the database. We are storing them in memory. And what we have done is we have upgraded from a single user application where we had a single user configured in Spring Security to a multi-user application where we have multiple users using which we are authenticating the API over here. Okay. We can also test out the other API, like for example, here you can see get user nodes. So I can disable the authorization header here, and I can say basic auth over here, admin and admin pass. Now if I send this, I'll only see the nodes against the admin user. Okay, you can see there is one more node with the ID 5 which exists in the database, but that is not being shown because that is being created by user 1, right? And we have been authenticated using admin credentials. So if I say user 1 over here, and if I say password 1, and if I say send over here, you'll see you get one node over here, right? So it's making perfect sense over here. You can even test out the other two APIs. It should work without any hassles. So the application is working absolutely okay, and there are no issues as such. All right. I hope you have been able to follow, and I hope you are also seeing the same output. And it was pretty simple as to how we have got the in-memory users being created and configured into a Spring Boot application, or at least I've made sure like I have been able to break it down and make it super simple for you. So I hope this was valuable, and I hope you have been able to follow along. So now it's time that we get started by talking about the classes and interfaces that help us manage users when we work with Spring Security. Now, when it comes to user management is the core of Spring Security, because whenever you are implementing security in your application, there is no way that you won't be managing your users. Okay, you have to manage your users, you have to do authentication, you have to do authorization and all. And it all boils down to how you are saving your user details, what details are you saving, how are you saving, and all of that, right? Now, when it comes to Spring Security, there is a set of classes and interfaces that are inbuilt, provided to us by this amazing framework, and we can make use of them into our application. So there are quite a few. Okay, we are going to talk about them all, as you can see on the screen. This is the hierarchy that we are going to discuss. So we'll be discussing each and every component that exists, and we'll also be talking about as to what is the role of that particular component. Now, throughout this journey, please be patient, because we'll be taking a look at a lot of inbuilt classes, inbuilt methods, why they exist. We'll be questioning why, what, and how, all of that. So I'll tell you the reason over here. I know you are curious as to directly jump into the code and try out some examples, but understanding the concepts at the core is really helpful, because tomorrow if you're going for any sort of interviews, then this is a knowledge that is going to help you navigate, right? And if in case you're working on a project And let's say if you get a project that involves Spring security, like usage of Spring security, then in that case, if you find any issues or anything, any sort of debugging you have to do, you would be able to debug things easily because you know the internal workings of this framework, right? So it's important that you have patience and you go through every minute details that I explained to you, and you understand every component that is involved in managing your users. All right. So excited? Let's jump right in. So now it's time that we begin talking about a bit of this hierarchy. So you can see this entire hierarchy. You have user details service, user details manager. These are the interfaces. And then you have user details or JDBC user details manager, and then in-memory user details manager. Okay. Now, throughout this entire hierarchy, you can see on the left hand side, user details interface is being used throughout. All right. Now, what is user details and why do we need to know about it? So user details is an interface in Spring Security, and it is a core component in Spring Security that represents a single user in your application. And it provides the necessary information about the user, like the username, password, and authorities, and all other information that you would want to store around a particular user. Okay, so you can think of it as a standardized way for a Spring Security to interact with various other classes and interfaces. If you want something to represent a user, you are going to make use of user details interface over there. All right. And whenever a user attempts to authenticate, Spring Security internally uses the user details interface to access the necessary information about the user. So that's the importance of this particular interface. And this is a structure of this interface. So you can see it has a method like get username, get password. Then it has a method called get authorities, which will help us get the roles that the user has access to. It also has is account non-expired, is account non-locked, is credential non-expired, is enabled. So all these methods exist within this particular interface. Now, there are key features that I would want to highlight about user details interface. First thing is, remember that this is a standardized user representation, like a standardized way to represent a user. Okay, so if you want to represent a user anywhere, okay, with regardless of the underlying data source. For example, you might use multiple types of data sources like database backed authentication, LDAP backed authentication, in-memory authentication. So irrespective of from where you are fetching the data, if you want to represent a user in Spring Security context, you are going to represent it with the help of user details. So coming back to the point, it provides a standardized way of representing the user information. Okay. Second point is it provides all the essential user information. So like all the standard information like username, password, the roles, all of this is encapsulated into this particular thing over here. Okay. It also gives you an access to account status, which I'll be talking about shortly and I'll be showing you as well. And also it has integration with the authentication thing over here. So it is being used by Spring Security, like I said, to authenticate and authorized users. And that integration is already present. So if you head over to IntelliJ over here, I already have this interface open. Okay. So I have this interface open and you can see over here, the documentation says it provides the core user information. Okay. They simply store the user information, which is later encapsulated into authentication objects. Okay. So that's the thing. And yeah, there you can see over here, see user for the reference implementation. So there is an implementation of this interface, which is a user class, which I'll be talking about shortly. So there is an implementation of this particular interface over here, which is the user class, which I'll be talking about shortly. But for now, I'll scroll down over here and you can see this interface. It extends serializable. Okay. And there's an interface again. And if you scroll down over here, you can see you have access to authorities, which is nothing but the roles, right? And it cannot return null over here. You can get access to the password, get access to the username, check whether the account is expired or not. Okay, now if the account is expired, it cannot be authenticated. That is what it means. Okay, so there are flags for this as well, inbuilt flags. Is the account locked? So if the account is locked of a user and if you want to implement such a functionality, then you can make use of this flag, and it tells or it signals Spring Security that this account is locked and it cannot be authenticated. Okay. It also has is credentials non-expired, which means like if the credentials are expired, then of course he cannot be authenticated. Is enabled. So is the user enabled or not? If the user is disabled, you cannot authenticate the user. So these are some of the flags and some of the details that this interface helps us with. Okay. Keep in mind, okay, this interface is used to represent the user information across your application. Now, this is irrespective of what underlying data sources you're making use of. All right. Because if you're working with Spring Security, this interface becomes really important because you'll be seeing this interface a lot in your code. All right. Coming back to our presentation, we'll talk about the next thing over here, which is user. Now, what is user? So user, as you can see, user is the concrete implementation of the user details interface, and this is provided to us by Spring Security. Okay. And it is often used to create the user details object. So it is used to create a object which is of type user details, which is what the interface is that it implements. And it comes with predefined username, password, and authorities as well. So take a look at this piece of code. Okay. So normally if you want to create a user, you can make use of this code over here, as you can see. So what we are doing is we are saying, I want user over here, like user object, which is of type user details. And I'm saying user dot with username. So I'm creating a user with this username, with this password, with this role, and I'm saying build. Okay. So this will give me, or this will return a object, which is the user object of type user details. And this is representing a single user in your application. Now, this class over here, user class, is a concrete implementation of the user details interface, like I said, and it represents a basic user with some basic attributes like username, password, roles, and so on. Okay. And this class is used to store and retrieve the user information that is needed for authentication as well as authorization. Okay. Now, few things that you need to keep in mind is, number one, it implements user details. Okay. User details is an interface, and user class implements user details. Okay. And since it implements the interface, if I take you to IntelliJ, I have this class open. You will see it implements the interface, and it has to provide the implementation for all the methods that exist in user details. Okay. So here below it will provide all the implementations, as you can see over here. This is all overridden. Okay. It also makes use of builder pattern. So if you're making use, or if you want to create object of user details, you have to make use of builder pattern over here. It makes use of builder pattern to create the user instances. All right. And it also gives a way to store like enabled and disabled attributes, like attributes about the users, like is the account expired, is the credential expired, is the account locked, what are the roles, is the account enabled, and all of that. Okay. So you can take a look at this entire class. It implements user details and credentials container. Okay. And this is credential containers is being implemented because in order to allow the password to be erased after authentication. So that is what credential containers helps this class with. But we are talking about user over here. Okay. So it models the core user information retrieved by user details service. Now, what is user details service? It's another interface, I should say. Okay. If you open this, let me open this. So it's an interface, you can see. Okay. We'll talk about that. But for now, we are just talking about user. You can see all these are the attributes, and it's a long class if you go through it. Okay. And you can see builder pattern being used over here. Okay. You can see, okay. So it's a fairly long class. Okay. And you can build a object of type user details if you wish to. All right. So this is the user class, which is an inbuilt class. All right. And if you have to see the hierarchy, this is what the hierarchy looks like. It's a simple hierarchy. You have user details as the interface and user class implementing this interface and providing all the implementations that are needed to represent a single user in your application with respect to Spring Security, of course. And if you take a look at the entire hierarchy, this is how it looks like. So user details is being used across the hierarchy, okay, to represent user information. So yeah, that's about user and user details. Remember, these two classes and interfaces, they are fundamental to Spring Security, because that is how the users are represented when you're working with authorization and authentication within this framework. So I hope this was useful, and I hope you have been able to follow along. So let us dive deep further into this hierarchy, and let's talk about the other classes and interfaces that exist here. So first we'll talk about the user details service. Now, what is user details service? So user details service is an interface, of course, which is responsible for retrieving user related data. Okay, so we have user details interface, which is representing a user within the Spring Security framework, and it's being used to authenticate and authorize users. But this interface is responsible for retrieving the user related data, right? And it has a single method. So it has a single method that loads the user based on the username, and it will return the user detail object. So you can see over here, this particular interface is making use of user details object over here. And it provides the core user information that can be utilized by AuthenticationManager further and the other Spring Security components. So this interface is also really important when it comes to Spring Security. Now, this is the syntax of the method that exists within this interface. And if I head over to IntelliJ, you can see that I have this interface open here. It exists in this package. You can see the package name here. And here are the details that I just told you. Okay, so you can see it is used throughout the framework as a user DAO, and is the strategy used by DAO authentication provider. So this is the default authentication provider that exists. And if you scroll down here, you can see it will locate the user based on the username, and yeah, it will fetch the user details object and it will return it to you. And this is the method that I was talking about. So you can see load user by username, and it accepts a string parameter, which is the username itself, and it returns user details. And here you can see username not found exception. So if the user is not found, we are going to see this error here. Coming back to the presentation, let's move forward. So after user details, we have another important component over here, which is the user details manager. Now, what is user details manager? So user details manager is an interface in Spring Security, and it extends the user details service and provides additional methods for managing the user accounts. So user details service, of course, provides one method, but if you want multiple methods, like you can think of this like an extension. Okay, so it provides additional capabilities, you can say, for managing user accounts, such as creating, updating, deleting users, as well as changing passwords and checking for users' existence. All right. And you can see this is a list of some methods that exist in this particular interface. And if you head over to IntelliJ, you can see user details manager over here. So you can see this is an extension for user details service, which provides more abilities like to create new users, update existing ones, and so on. You can see the methods here. Okay. You can see, and depending on from where you are fetching the user, these implementations need to be provided. All right. I hope this is making sense. Now, we spoke about user details manager. Okay. Now, if you head a little bit further over here, you can see two more classes over here. So these two are the interfaces. User details service helps you fetch the user information. User details manager is an extension to user details service that helps you do more, right? And then you have these two implementations of user details manager. Now, what are these two implementations? So first, let's talk about JDBC user details manager. Okay. Now, JDBC User Details Manager is a Spring Security implementation of UserDetailsManager interface that manages the user details using a JDBC-based data source. Now, what does this mean? So there will be scenarios wherein you might be saving your user information into a database, right? You would be persisting the user information into the database, and your application would be a multi-user application which would have n number of users that might use the application. So all those users are being stored where? In the database. Now, how would you connect to the database? So of course, for a Java-based application, you would make use of the JDBC to connect to the database and retrieve the information. So this particular User Details Manager, which is JDBC User Details Manager, it helps you make fetching and managing the user detail information using JDBC based data source. So database is a JDBC based data source, right? So if you're making use of a database, you have to make use of this manager, which is User Details Manager. Okay. And this will help you manage the users. So it provides the methods to create, update, delete, query user accounts, and it interacts with the database using SQL queries. And these are few methods that exist in this particular class, and I'm going to show this class to you. Okay, so if you head over to IntelliJ, I actually have this inbuilt class open. Okay, you can see over here it provides CRUD operations for both users and groups, and you can see JDBC User Management Service. So it's based on JDBC, right? If you scroll down, you can see over here it implements User Details Manager over here, right? And you can see over here, these are different queries that exist. So it has SQL queries predefined. You can see create user SQL, delete user, update user. So it is interacting with the underlying database with the help of SQL, and it has predefined SQL queries within itself. Okay, you can see over here, a lot of SQL queries have been defined for all the operations, right? And what happens is if you scroll down over here, okay, once the data source is set, then if you scroll down here, you can see it is providing the implementation as to how the user details should be loaded. It is providing the implementation for the same. Why? Because this is of type JDBC, right? So since we are implementing User Details Manager, we are also implementing User Details Service, right? Because User Details Manager is extending User Details Service. So we have to provide the implementation for this. We have to provide the implementation for map to user. So it's fetching the user and mapping it to user details. You can see it's creating the user. You can see over here. Okay. And you can see it's making use of this SQL that we saw at the top. If you scroll down, update user, you can see how the user is updated. That logic is there. And if you scroll down, insert user authorities. This is like when you want to insert roles inside user. Delete user. So there are lots of methods over here. You can go through this. All the operations has the method, and every operation makes use of SQL. You can see these are variables that have SQL queries in it. Okay. So yeah, if you're working with a database and you need a way to write SQL or a way to use SQL, this will be the class that you'll be making use of. Okay. So this is about JDBC User Details Manager. Now let's talk about in-memory User Details Manager. Now what is that? So in-memory User Details Manager is another implementation of User Details Manager interface. It's provided by Spring Security Framework. Of course, JDBC User Details Manager was also provided by Spring Security Framework, and it manages, like this particular class, manages the user details entirely in the memory, which means user data is not stored inside the hard disk or like the database, right? There is no persistent storage. It's just stored in the memory, which means RAM, right? And if it's stored in memory, what would happen? If you restart the application, the data is lost. And these are few methods that are much more similar to JDBC User Details Manager. Okay, so if you come over here, you should see in-memory User Details Manager. Okay, so you can see non-persistent implementation of User Details Manager, and it makes use of in-memory map, and no persistent storage is being used over here. Okay, and if you're making use of this, you're not storing your user details into a database, then it means that you are testing and demonstrating something. Okay, So it's not recommended to use this for a production grade application, but it still exists because sometimes you might want to do a quick POC or a quick test of something. You might want to create quick users in memory itself to test out something. And you can see the map is being created over here. Okay. And all the implementation exists. So it will be a fairly less complex code would be written over here. Okay. As compared to the JDBC User Details Manager. Okay. So yeah, these are the couple of implementation that we have, which are provided to us by Spring Security when we talk about this hierarchy. Okay. So if you want to store the data into the database, you will make use of this. If you want to store the data into memory, you will make use of InMemoryUserDetailsManager. Okay. So I hope this hierarchy is clear to you as to what happens where and how the entire system, which means which consists of classes and a couple of interfaces, come together to work with the user that is being represented within Spring Security. And make a note that all these classes interfaces are making use of user details, which is again an interface. Okay. So everywhere you'll see user detail is being used throughout. All right. So that's the standard. So I hope this was useful. I hope this is clear to you all, and I hope you have been able to follow along. So let us do a quick review of how we have implemented the in-memory authentication in our application. So we are going to take a look at this particular bean that we have created within security config. So I'm right now in the security config, as you can see over here. Okay. It's the security configuration for my application. And if I scroll down here, I am first making use or creating an instance of in-memory user details manager. Now, what is in-memory user details manager? It's the class over here, which will help us create and manage the users in memory. And you can see over here, it will make use of in-memory map over here. Now, I'm making use of inbuilt methods that have been defined within this particular class over here to check if the user exists with this username. If the user exists, I'm not creating a new user. If it does not exist, I'm going ahead and creating a user. Now, over here, if you hover on this, you will see that when you're creating a user, it needs a object of type user details. Okay. So if you go over here, create user, it's needing or it's wanting the type of user details over here. And using this, it is creating the user. Okay. Now, if you come over here, we are actually making use of the user class over here. So if you go over here, user is a class. If you scroll down, okay, it is a class with a lot of stuff, a lot of attributes over here. And we are making use of the same to get the object of type, which is of its parent. Okay, so the parent, which means user class over here, implements user details. So what is happening over here is this is returning the object of type user details, which is being passed on as a parameter to create user, and the user is created. So all of this is happening in a single line. Okay, if you scroll down, we are repeating the same process again. And in the end, we are just returning the manager over here. So since we are creating this as a bean, okay, Spring Security understands that we are making use of in-memory authentication over here because the object that we are using over here is of in-memory user details manager. Okay. And you can see this method is returning not in memory, but it's returning user details service, right? So yeah, that's about the entire process over here as to how in-memory authentication worked. So it's time that we move forward and move towards the database-backed authentication from in-memory authentication. So right now, what we are doing is we don't have any user table or any way to store user credentials into the database, all right? And if we want our application to make use of tables which are created within this MySQL database, then we will have to have a structure over here, right? So the question is, how do we get the table structure over here, and what sort of table structure are we going to need? So I'm going to switch over to IntelliJ over here. And here we have in-memory user details manager, which means we are making use of in-memory authentication. There's no database in picture. But if you head over to JDBC user details manager, of course, this is a class that we are going to make use of instead of in-memory user details manager. So we'll make use of JDBC user details manager to make our application talk to the database, right? And if you come over here, if you come to this class definition, you will see that there are a few extensions and implementations that this particular class is doing, and it has all the SQL that it needs, right? But the question is, of course, if I make use of this particular class, it will make use of the SQL against the MySQL database that we have. But the question is, we need to have a structure, right? So what is this users table? We don't have this users table into our database. We don't have this authorities into the database. So where do we get this structure from? So if you come over here, there is a JDBC DAO implementation over here. Okay. So if you go inside this particular class, you can see over here, this is the class that is an inbuilt class. Okay. And we don't need to get into details as to what this class does, but here there is a important, important property or a field that is defined. Okay. So this particular class has a variable which has the definition of user schema location. Okay. Or it has the path as to where the user schema is located. So you can see over here, this is the default user schema DDL location. And this is what the path is. What I'm going to do is I'm going to copy this file name. I'm going to hit shift 2 times and I'm just going to search for this. The moment I search for this, I'm going to see this result over here, which is org spring framework security. And I'm seeing this in the core package. Okay. So I'll select this, and this is a file that this particular class is referring to. Okay. Now, if you take a look, it's org spring framework security core user details JDBC. Okay. And this is where it's coming in from. Okay. So if you're working with JDBC, then this is the schema definition that you need to have. So you can see over here, you have users table, you have authorities, and then you have index being created. Okay. Now I can copy this directly and make use of it, but it threw some error with MySQL. So what I've done is, it had some syntax which was not recognized by MySQL. So what I've done is I have modified this version of query, okay, in a notepad, and let me pull up a notepad for you. So here you can see, so this is the exact same stuff, but being converted into what MySQL can understand. So here varchar ignore case, I got an error when I use this with MySQL because MySQL does not recognize this. Okay. So I got this converted into the format that we can make use of with MySQL. And you can see we are making use of varchar. It's the exact same schema. You can see we need users, we need authorities, and we need this index. So what I'm going to do is I'm going to copy this entire thing. Okay. And you can see over here, it is creating table users with username as a field, password, and whether the user is enabled or not. There is authorities table, which will help us store the authorities or the rules against the user. And you can see it has username, authority, and username is a foreign key to the username in the users table. Okay, so that's a relation that we are creating, and we are creating a unique index over here. Okay, so I'll copy this. I'll head over to the database. Okay, and here I'll have a query tab open. You can open the query tab, something like this. I'll open a fresh one. You can say use secure nodes first because that's the database where you want to trigger this query. So I'll execute this first, and then I'll paste this SQL that I've created. Okay. Now I'll just press enter so that you get a clear picture of what is getting executed. All right. We have these queries. So what I'll do is I'll create user table first. This is created. I'll create authorities then next, and then I'll create this index. So all three are created. You can see I've got success. I can refresh and I can see all the two tables, and index will be created, but it won't be shown over here. Okay. So we have this schema working for us. Also, if you head over to IntelliJ, before we make a connection to MySQL database and start using these tables for authenticating and authorizing users, you need to make sure that the application that you have is also configured to work with MySQL. So I already have the configuration in place. You can see this configuration is in place. And if you head over to pom.xml, I have the MySQL connector as well. Okay. If you don't have this, make sure you configure these and also get the schema created. Okay. I hope this is useful because this is the schema that we'll be using when we'll make use of the database to store the users that Spring Security will make use of. So I hope this is useful and I hope you have been able to follow along. So now we have the schema created. What we need to do is we need to head over to IntelliJ and instruct our application to make use of JDBC. So we have the database already configured and we are making use of in-memory over here. So instead of in-memory, we need to say make use of JDBC. So what will happen is Spring Boot's auto configuration will come into picture. The database is already configured and Spring Security will understand by default that by JDBC, the developer wants me to make use of the MySQL connection. Okay. So what I'm going to do for that, I'm going to just change the type of the UserDetailsManager that I'm using over here. Yes, you are right. So in order to work with JDBC, we have JDBC UserDetailsManager, right? And that is what we are going to make use of. So I'm going to say JDBC. Okay, and you can see this suggestion, UserDetailsManager, and I'm going to just get this object created. Rest of the steps remain absolutely same. There are no changes. Okay, but with this single change, what will happen is instead of making use of in-memory UserDetailsManager, JDBC UserDetailsManager is used and the user will be created within the database, and everything that we need for authentication we have in the database already set up, like we have the schema set up, and Spring Security will make use of this to authenticate users. So I hope this is useful and I hope you are able to follow along. Once we are done with the changes where we mention the JDBC UserDetailsManager, it's time that we rerun our application and see if we are able to get everything up in the right way. So I don't see, okay, I get one error. Let's see what this error is. So if you see the error, we are seeing this error which says unsatisfied dependency exception. Okay, so there's something wrong in our code. Let us check that out. Okay, I understood the error. So here we need one more parameter that we need to pass in to the JDBC UserDetailsManager. We need to pass in the data source instance. Okay, so what I need over here is I will accept data source here. And I'll create an instance of data source and I'll pass in this data source as the parameter to JDBC UserDetailsManager. Okay, so if you go over here, this is needed over here to set the data source, and this data source is the data source against which the users are being authenticated. Okay, so since we have configured, so if you come over here, we have configured MySQL right into application properties and pom.xml. So this is automatically injected over here and it is being passed in over here. Okay, so the source over here is the source that you have configured in your application. Okay, we should not get any errors right now, and you can see the application is up and running. Now what we would do is we would switch over to Postman and let us see if we are able to authenticate. But before switching to Postman, I would also want to show you over here as to how data is being stored over here. So if you come over here, if I say select rows in user, you can see two users being created over here, right? And these are the two users that are being created from here, like because of this code, right? And this is the reason why we are seeing these two users here in the database. So admin and user one are being created. Okay, are we seeing anything in authorities? Let's see. Yes, admin has the authority of admin and user one has the authority of user over here. And that is because we have set all of this within the source code, as you can see over here. Okay, so this is done. Now let us try to authenticate. So I have user one, password one, I'll say send, and you'll see it works absolutely fine. I'll create a note, admin and admin pass. Okay, so you can see a new note was created, and if I try to get the user note, I can say admin, and here I can say admin pass, and I can say send. You can see we have notes being created here. Okay, so everything is working as expected, and this is working with database now, right? Now, there are a few questions that I would want to address over here. Okay, before that, I hope the flow is clear as to what is happening. So we are making use of JDBC UserDetailsManager, and we are taking the data source which is being injected because we have pom.xml and application.properties configured, and Spring Boot is aware as to what data source we are using. So it is injecting this object here, and we are making use of this object and passing it to JDBC UserDetailsManager. Okay, so this is absolutely clear. Now there will be a few questions that pop up in your mind. Okay, if you have understood everything correctly. So if you see over here inside user details and user over here, user has a lot of fields like authorities, account non-expired, non-locked, credentials non-expired. Okay, but when we are creating the user over here, if you see, we are not setting all of those fields. We are just setting the username, password, and then we are just specifying the roles, and then we are just building this user object. Okay, and the current setup that we have with JDBC UserDetailsManager works over here without specifying those additional fields as well. And the reason for this is because the user class which JDBC UserDetailsManager uses to create the user provides default values for the account expiration, account locking, and credentials expiration as well. And these defaults ensure that the users are always considered as non-expired, non-locked, and with non-expired credentials unless explicitly specified otherwise. Okay, and this design allows Spring Security to function correctly with minimal schema, leveraging default assumptions for properties not explicitly stored in the database. Okay, so we are not storing any of these properties in the database like you just saw in the user class over here. Okay, but we are making use of this user class itself, if you see. Okay, but these are not being stored in the database, and the reason for that is because of how it's designed. You can just take the minimal schema and get the user or the user class to work with the database backed authentication just by having the essentials, and the essentials here are username, password, and the role. Okay, so I hope this is clear. This is a question that often pops up that, hey, user class has so much of details, but our database does not have. Why so, and how does it work? Okay, so I hope this is clear now, and I hope you are also clear on the flow. Now, what is happening is, how this entire flow is working is, whenever Authentication Manager wishes to authenticate, okay, what it's going to do is it is going to make use of DAO Authentication Provider, which makes use of UserDetailsService, and then JDBC UserDetailsManager will be used because that is what we are using over here, and that will be used instead of InMemoryUserDetailsManager like we had earlier on. Okay, so this is being used since we have replaced InMemory with JDBC, and then the user will be used to authenticate against the data source specified. So I hope this is useful, and I hope this is absolutely clear. So now let's talk about custom user model and understand why you should make use of custom user model and how would you make use of it in your Spring Boot application. So first, let's talk about the why part. Okay, so there are multiple reasons as to why creating a custom user model is beneficial. I'll list a few. Number one is, of course, extending the user information. So if you have extended user information that you wish to store, okay, of course, you have the default user details interface that is being provided by Spring Security. But this may not cover all the user information that might be needed for your application. For instance, you might want to store additional attributes like first name, last name, email address, profile picture, or URL, and so on, right? So in that case, this does not suffice, and you might want to think of something custom for your application. So this is the reason number one. Second reason could be domain specific requirements. So different applications have different requirements. A custom user model allows you to include domain specific attributes and logics that are essential for your business. For example, if you're building an application for a medical domain, the user information that you want to store for a user belonging to a medical application would be different. A user information that you would need to store for an application that is a game would be different, right? So different domains have different requirements, and depending on your domain, there would be some domain specific requirements for which you might want to customize things. Custom authentication and authorization logic. Now, sometimes you'll need to implement custom authentication or authorization logic that requires additional attributes or methods that are not provided by default, right? So in that case, you might have to customize this. Integration with other systems. So if your application integrates with other systems like CRM, ERP, you may need to store and manage additional user related data to facilitate these integrations. And in that case, custom user model could help. Enhanced security. So custom user models can help in implementing enhanced security measures such as multi-factor authentication. Okay, this is one of the popular things today, wherein a lot of applications force their user to have two-factor authentication enabled. So if you want to implement that in your application, you will have to customize your user model, right? Also, you might want to store the account verification status. So is the user account verified? Or custom password policies. So is any sort of custom password policies that you might have for your application, you might want to store that. So these are few reasons as to why you might want to customize the inbuilt default user model. Okay. Now there are several benefits that come when you customize the user models. Of course, I'm not saying that you should always customize, but customizing is better because you might have some different requirements. And in future, if you want to scale your application or if your application grows big, then you might have to configure this. So number one reason is flexibility. So a custom user model will give you the flexibility to adapt the user schema to fit the unique needs that your application might have, right? So you can add, remove or modify fields as required, whereas this is not possible in case of an inbuilt user schema, right? Better code organization would be another one, because you are encapsulating all the user related logic within a custom user model, and you can keep your code more organized and maintainable, right? And this separation of concern makes it easier for a user related functionality to exist in a single file or a single class, right? Easier testing. So custom user models can be easily mocked and tested as compared to the default user details, right? And this facilitates unit testing and integration testing. Improved user experience. So having custom user model allows you to store additional user preferences, personalization settings, or any sort of things that could improve the user experience. And you can use all of this data to personalize and improve the user experience within your application. Now, you can see over here, this is how you would normally implement a custom user model. Okay, so you have user details here, which is an interface. You have user as the class. So you would have a custom user model that would inherit or implement the user details interface over here. Okay, and this would have all the required attributes that are needed. Okay, now this custom user model is necessary in several scenarios, like I discussed, like complex user attributes. If you want to manage any sort of complex user attributes, like for example, you might want to store multiple email addresses of a user, or if you want to store physical addresses, right? So you create custom user model. Advanced security requirements, integration with external system. If you want to have custom roles or attribute based control, then all of this requires custom user model. Okay, so this is the diagram as to how the implementation would work. You would have a custom user model class that would implement user details from here. Okay, so I hope this was useful, and I hope you are clear as to why and what's of custom user model. Okay. So now it's time that we go ahead and start creating our own custom user model. So what I'm going to do is I'm going to right click and close all the tabs over here. And I'm going to add some code into IntelliJ which I have already added here in Notepad. Okay, so here you can see this is app role.java. Okay, and this is enum over here. Now, whichever role we have in our application, so we are going to have custom rules, right, in our application. So whichever roles we have in our application, we can create those roles using this app role class, or sorry, not class, it's an enum. Okay, so you can have role user, role seller, role admin. We don't need seller over here. Okay, so I'll remove seller, but you can have role user and role admin over here. Okay, a user can be a user, normal user, or a user can be an admin. Okay, in future, if you want to add more roles, this is where you will add more roles. If the roles in your application grows, for example, if you have a role manager, so you can add that role in this enum, right? And it will be available for use in your application. The next thing that we are going to have is the role class. Now, this is a class that will help us manage roles. So you can see here, I'm making use of Lombok annotations. Okay, and I have some fields over here. Okay, we'll talk about these fields in detail shortly. Then I have the user class. This will help us manage the user, of course, and it has a relationship, if you see over here, with role. Okay, and then if you come over here, we have user repository, and this will help us find the user by username or interact with the user model. Okay, what I'm going to do first is I'm going to move app role into our application. So I'll head over here. I'll come over here under models. I'm going to start pasting this code. Okay, so I've added app role here. Now I'll move the role class over here. So I'll just paste this over here. And then I need to add, so this is another one that I need to paste. This is user, and then I'll make use of, or I'll add user repository. Okay, so this is a repository and it has to go under repositories here. Okay, so this is added. All three are added. We are getting an error over here. Okay, 1 second. So here under users, we are getting error. Okay, so we are getting an error for validation. Okay, we are validating over here, and these annotations are not identified, of course. So we need to add a dependency as well. And there's a dependency that is going to help us validate. So in order to get that dependency added, okay, since we have to add that dependency so that we get rid of these errors that we are seeing over here, right? So we need a dependency. So what I'll do is I'll come over to start.spring.io. I'll select Maven and I'll say add dependency, and I'll select for validation over here. Okay. And I'll get the bean validation with Hibernate validator. And if I scroll down over here, okay, I'll get this dependency copied. Okay, so I need to just copy this, and I'll come over here to my project. Okay, and let's head over to pom.xml. Okay, so I'll just press pom.xml and I'll paste the dependency here. So this is done. And I'll reload the Maven changes. Now, once we reload the Maven changes, you'll see the dependencies are being resolved here. And the error that you see over here should also go away. Okay, so the error disappeared, and I believe we are all now good to go. Okay, so let's go through the code now. So app role is the enum that has the list of roles that we want in our application. Okay. Then we are here in role.java. Now this is the class that will manage the roles. Okay, so it is managing with the help of table roles over here. I'm making use of Lombok annotations. If you scroll down, you can see I have role ID. Okay, I'm marking the column name in the database. I'm specifying the generation strategy over here, and I'm marking this as ID. If you scroll down, role name. Okay, I'm specifying the validation here. Okay. If you scroll down, so this is not validation, this is actually I'm specifying the column length and the name of the column. Okay, if you scroll down here, I'm specifying the users. Okay, so I'm which users have this role. Okay, so I'm adding that as a set because this is one-to-many relationship. Okay, and here you'll see that the fetch type is lazy, Cascade type is also something that I've specified. And yeah, this is users over here. Okay, I've added JSON back reference so that there is no circular dependency when we query this in JSON or in Postman. Okay, I have this over here, which is the constructor. Now here, coming to user over here, I have like the table level constraints here. You can see unique constraints that I've specified. Okay, if you scroll down, I have fields like user ID, username, I've specified email, password, account non-locked, non-expired, credentials non-expired, enabled or not. Okay, I'm also keeping a track of credentials expiry date, account expiry date. I'm also keeping a track of two-factor secret, is two-factor enabled, and the sign up method. Okay, so if the user has signed up using Google, you will have Google stored in over here. If the user has signed in using GitHub, you will have GitHub over here. So this is to keep a track of how user has signed up. You have two-factor secret, and you have a flag which maintains if the two-factor authentication is enabled for this user or not, right? If you scroll down here, we have many-to-one relationship with role. Okay, and I have different parameters specified over here, like the fetch type, the cascade type, and all. Okay, so that is something that I'm specifying over here. Then what I'm doing is, if you scroll down over here, I have created date, and I have this annotation creation timestamp. I have updated date with the update timestamp. Okay, and whenever this record is updated, you can see, you can read the documentation. The timestamp is regenerated every time an entity instance is updated in the database. So whenever you perform update to any of the entity in the database, this field will be populated. And if you see over here, creation timestamp, okay, the timestamp is generated once when an entity instance is inserted in the database. So whenever you create an entity instance, this is populated with a value. So we don't have to do anything, literally. We have a couple of constructors here, okay, that we are actually making use of. Okay, and then if you scroll down, we have equals over here and hash code. So these all things are being overridden. Okay, and if you scroll up over here, okay, this is user. Okay, so this is the user model over here. Okay, so this is how we are representing the user into the database. Okay, so I hope you have been able to follow, and I hope this was useful. Also, I'll talk about user repository. It has just one method, find by username. Okay, so if you want to find the user from the database by username, you can make use of this, and this is going to return optional of user type. Okay, so I hope this is clear, and I hope you have been able to follow along. So we have come very far with our application, and we have our own user model along with the roles class, using which we'll be representing roles, users, and everything that we need for authentication. Okay, that is something that we have already created now. Now, the thing is, this user model, role, app role, all of this exists in our application, and these entities are being created into the database, right? But this is not yet integrated with Spring Security Framework. Okay, so right now this is working in silos, right? This is separate, and the Spring Security Framework is separate. There is no integration or a sort of link, I should say, between these two, where we mentioned that we want Spring Security to make use of these custom user model, role model, and so on, right? So we need to still complete that particular loop, and that loop we can close by creating a custom user details and user details service. Okay, now what these two classes are and why do we need them is something that we will be taking a look at. So what I would do is I would switch over here to Notepad. Okay, I already have these classes that will be created in this package here at the top. If you see com, secure, notes, security, and under security, I have services package where I'm creating user details implementation, and this is implementing user details. And then you have another class which is implementing user details service. It exists in the same package. So first thing, we'll move this two classes to their relevant packages in IntelliJ, and then we will discuss what these classes do. Okay, so what I would do is I'll copy this here. Okay, I'll come over to IntelliJ, and over here, let me collapse everything. And I don't have, okay, I have services over here, but I don't have services under security. So over here, you need services under security. Okay, so what I'm going to do is under security, I'm going to say new, and I'm going to say here, I'm going to say services. Okay, something like this. And within this package, what I can do is I can paste this entire piece of code. Okay, so I pasted user details implementation. And if you come over here, I'll copy this part as well. Okay, this is user details service implementation. Okay, I'll copy this and I'll move this to the same package. I'll paste it over here. Okay, so we have these two classes added over here, and this is under security to identify that these are services that are related to security. So far so good. I'll collapse this. Now let's take a look at these two classes, right? Now, even though we have a custom user entity with additional attributes over here, okay, we have created a custom user entity with additional attributes. Spring Security requires a way to understand and use this custom model during authentication and authorization. Now, this can be achieved by, of course, creating a custom user details class. Okay. Now, what this custom user details class does is, so one way is by doing this custom user details class, and also we need to add a custom user details service implementation. Okay. So first we'll talk about user details. Okay. Now this particular class implements user details, which is coming in. So if you go to this class, it is coming in from core security package. Okay. And you can see over here, this particular class provides the core user information. Okay. And we need to implement this so that this will allow Spring Security to interact with our custom user model by providing the necessary user details required for the authentication. Okay. Now what this class does is, if you see, first of all, it implements this user details over here interface. Okay. Then it starts with storing all the user information that is needed. Okay. So I have like my ID, username, email, password. Okay. I have like is two-factor enabled here. I've added this JSON ignore over here because when we'll be working with the APIs, I don't want password to be part of API. Okay. So I've added JSON ignore over here. Okay. Now I have this granted authority over here, right? So I'm creating a authority object. Okay. And if you scroll down here, you have a constructor, and then over here you have a build method over here. So a static build method which converts the user entity into a user details implementation object. You can see over here. So this is a user entity and it returns the user details implementation object. So this is a sort of converter which will map the user roles to and other attributes to user details implementation object type. Okay. And then it includes a lot of overridden methods over here. You can see get password. So this is get password coming in from user details, like the inbuilt user details, which we are implementing over here. And that is something that we are overriding over here. Okay. So when we say get username, we'll return the username over here. When we say is account non-expired, we'll return true. So you can customize this over here. We are returning true right now. Okay. Because we are saying nothing is locked and nothing is expired and everything is enabled over here. Okay. But if you want, you can customize this in future with the help of flags. All right. But this is something that we have set right now. All right. And this particular class is a custom implementation of user details. As you can see, it adapts your user model. So this user model that we have to the user details interface required by Spring Security. That is what it is doing right now. Okay. So this is about user details implementation. Okay. So the representation of user is done with the help of this. Okay. And we have created a bridge between our user model and the user details within Spring Security with the help of this class. Now the question comes is, how do we tell Spring Security as to how we want the user data to be loaded? Now, why we need to tell that first of all? So because we have created a custom user model, we are storing it in a database, right? We have some database connections configured in application properties. Okay, so I don't have application properties open, but we have MySQL configured and the data is being stored and saved in MySQL database. So we need to tell Spring Security that, hey, here is how you will load the user data, right? And what we are doing over here, this is the class that will help us specify or define that information. So what this class is doing is it is implementing the UserDetailsService interface that allows you to load user specific data from your custom user model during the authentication process, right? The bridge is created by this, but how should the user details be loaded is what is defined by this class over here. Okay. And if you go inside this user details service, you will see this is a core interface which loads the user specific data within Spring Security Framework. All right. So we are implementing this and we are saying, hey, this is my implementation as to how I want the user data to be loaded for my custom definition. And here, the method that we are overriding, you can see over here, we are overriding load user by username. Okay. Why we are doing this? Because this is coming in from here. Okay. We need to specify how the user is supposed to be loaded. Okay. If you come over here, we have a very simple logic over here. So we are saying if user repository find user by username, and within repository, you have this method defined, and we are loading this particular user information with the help of this method here. And we are throwing an exception if this user is not found. And then we are simply building that user and we are returning the object of user details over here, as you can see. Okay. So this is what the entire thing happens. Okay. And fetched user entity that we get over here is converted to a user detail implementation object using the build method over here, as you can see. Okay. So this is something that is being done, and this object is of type user details implementation here. Okay. But since this is implementing user details, we are representing it as user details, which is coming in from the core security framework. You can see over here, right? So I hope this is making sense and what is happening over here. Okay. And what would happen if these two classes are not defined? Okay. So first thing that will happen is Spring Security will not be able to understand the custom user attributes that you have defined over here. Okay. So Spring Security relies on user details interface over here. And it relies on this because it wants to retrieve the user information, right? And without a custom implementation, it will not know how to access additional user attributes like email, two-factor authentication status, and all. Okay, so this is a custom attribute, right? This does not exist in inbuilt implementation. So how should it access this? That is something that you should know, right? And that is what is being helped by this particular class over here. So first thing will happen is if you don't have this, the custom user attributes is not understood by Spring Framework, Spring Security Framework, I should say. Okay. And a second thing that will happen is it won't know how it is supposed to load the user information, because everything is custom. We are creating custom things. It does not know how it should load the custom user data. Okay. It does not know what query it is supposed to trigger. It does not know which repository is responsible for giving us the data. So all of that we are defining over here. Okay. And the user details service over here, this one is essential for loading user details from the persistent storage like database. And without user details service implementation, Spring Security cannot fetch user data, which will prevent users from being authenticated. Okay. Also, so these are the two things. First is it won't be able to understand, without these two classes, it won't be able to understand the custom user attribute. It won't be able to load the users from the database. And the third thing is we won't be able to customize the authentication logic. So custom authentication logic, like if you want to implement things like what would happen if an account is non-expired, if the account is expired, what would happen if account is locked, what would happen if the credentials are expired, all of that. What would happen if two-factor is disabled? So all of that can be controlled from here, and you won't be able to customize anything of that sort. Okay. And your application might lack necessary security checks without this. Okay. So to summarize this, these two classes are important and they're crucial. I'm reiterating over here. They are crucial for three things. One is integrating your custom user model with Spring Security. 2, for fetching and converting user data from the database into the format that Spring Security can use. Okay, and we are doing that over here. Okay, here, sorry. Okay, so we are giving the data to Spring Security in a format that it can use. And you can see this is an internal format of Spring Security. Okay, this is the second part. Third part is implementing additional security logic and handling custom user attributes that we saw over here. All right. So without these custom implementation, Spring Security will not be able to manage custom authentication of user and authorization based on our application specific requirements. All right. So I hope you have been able to follow, and I hope why, what, and how of these two classes are very clear to you all. It's important that you understand every bits of this code and why we are doing things. And that is why I'm stressing a lot on explaining things rather than typing things. Okay, you can copy this code yourself and you can take a look at that. But I don't want to waste time typing things. I want to spend more time on explaining, because these things require some in-depth explanations. All right. And if you understand this, it is an understanding for life. So I hope this was useful, and I hope you have been able to follow along. So now it's time that we get the role repository created, because we would be creating our own roles, our own users and everything. We have roles using which we are representing role information into the database, right? But we need a repository using which we can work with it. So what I'm going to do is, I already have this repository defined. I'm going to take this and it will come in the repositories package in our Notes application. So I'll come over here. And here under repositories, I'm going to paste this. Okay. And you should see this being created here. Okay. And you can see it's pretty simple repository, pretty straightforward. We're making use of role entity, and the primary key or the ID field is long. And we have one method here, which is returning the optional of role. And it says find by role name here. You can see, and it accepts role into it. Okay. Role as the parameter. Okay, so it's a pretty straightforward repository that we have got created for further use. Now it's time that we observe and test the changes that we have done so far into our application with respect to making use of custom users model. So first thing that I'm going to do over here is I'm going to head over to securityconfig.java. So open this class here. Okay, and just as a refresher, we have some configurations defined, and we have a bean wherein we are creating few users. Okay, now this was done when we were making use of JWT UserDetailsManager, and when we were making use of inbuilt user and authorities. Okay, now we have our custom role and user. So this we no longer need. Okay, so I'm just going to get rid of this. Okay, I'll just delete this. Okay. And what I would do is I would rerun our application. Let us see how our changes are being reflected onto the database. It's likely that we'll see an exception over here. Yes, we saw an exception in the stack trace. Okay, I'm purposely generating these exceptions, showing you why we are getting this, how you can fix this, so you get a better picture of the hindsight. Okay, so here if you see, it clearly says at the top that error executing DLL. Okay, so it's trying to modify this table users, but it's not able to. There is an error. Okay, now I'll tell you what happened. So here we have a custom user, okay, which is being marked as entity, and this is a table name, right? Users. Now if you come over to our database here, you'll see we already have this user table over here. Okay, you can see, right? So this user table is already existing, and this was created by us using this script. This was manually created. Okay, so we had created this because we wanted to save our user information from using the inbuilt users model that exists within Spring Security into a database, right? That is why we had created these tables, right? And also we created the indexed. Okay, now what is happening is it is trying to create and modify this users table, but it is not being able to. We are getting an error over here. So in order to get the current code working, we'll have to drop these tables. Okay, so I'll first go ahead and drop the user table. I'll say drop now. Okay, and we'll get an error. Okay, we first need to drop authorities. So I'll say drop now. We don't have to truncate, we'll have to drop. So we were able to drop it very easily. Okay, now there is no users, no authority inside, right, inside our database. I'll rerun this application, and ideally this time we should not get any errors. Like, it should work very smoothly, right? You can see over here, there are no errors that you can see, right? So it has been able to create the user model and the role entity, okay, into the database. So I'll switch over here and I can hit a refresh. I'll say refresh all, and you can see users and roles are now being created. Okay, if you go to users, you'll see this user table. Okay, everything. This is user ID, account expiry date, account non-expiry. You can see every field that we have defined. Two-factor secret. We have roles. Okay, so here you can see role ID, role name. Of course, we don't have any data here. All right, we need to add some data. Now, what we would be doing is, if I come over here to Notepad, I have a bean, a code to create a bean, which will initialize some dummy user credentials for us, okay, on the application start. So I'll copy this and I'll come over here. I'll get this pasted into security config. So head over to security config, and here we just have one security configuration. I'll just paste this code over here. Okay. Of course, a lot of red marks. That's absolutely normal, but we'll begin by importing things. We are getting these errors because we have not imported a lot of stuff. Okay. We need to add import statements. That should take a minute. I'll just add these import statements. Okay. Now app role. What is app role? So I'll import this. Okay. We need role as well. Right. Now which role? Be sure you're importing the right role. This is a role that we have created. Okay. And yeah, I think we are done. Now here we are getting these red marks for user. Now because this user is pointing to the inbuilt user, right? We need to make use of custom user model over here. So I'll go over here. I'll get rid of this import statement for user, which is like the inbuilt user object or the inbuilt user class. I'll say I need my custom user, and all the errors go away. You can see. I'll import this as well. Okay. Everything is done. Okay, we don't have any errors except this one. We need to check if a particular user exists or a particular username is being used already. So I'll create a method with this, okay, and I'll make sure it returns a boolean, right? And this is username over here, right? So also we need to call this as username, something like this. Okay, I'll save this and come back over here. Okay, so all the errors are gone. Now taking a look at this code, what we are doing is we are making use of command line runner interface here. Okay, and we are creating this bean called init data, and we have a couple of dependencies being injected here, which is role repository and the user repository. And then what we are doing is we are saying check if the role exists. If the role exists, okay, get this role. If it does not exist, then create a new role. You can see over here. If it exists, get the role. If it does not exist, create the role. This is for role user. Same for role admin. Okay. Then once the roles are created, because these roles need to be used against the users. So first we are creating and making sure the roles exist. And then with the help of user repository, we are seeing if the user with this username exists. If it exists, then we are not creating a user with that username. If it does not, we are creating a user over here. You can see a new user object with these dummy credentials. Okay. We are making use of Noop over here because we are telling Spring Security that we don't want to encode the password here. Okay. We want to store it as plain text. This is not a production recommended standard, but hold on for a while. Okay. We are still learning. So we'll go step by step. We'll learn about password security as well. But for now, we are storing password in plain text. Okay. And now over here, you are setting all the fields and then you are saving the user data. Same goes for another user. Okay. So this will make sure that user is created into the database. I'll restart this. Let us restart. Okay. we should see no issues. So if you come over here, if you refresh, so if I refresh this roles table, you should see role user, role admin. Okay, this is done. If you go to users and if you run this query, you should see a couple of users being created. Okay, you can see over here. All right, so all the details have been set, and I hope you have been able to follow along. Now, what we need to do is we need to test our APIs with these new user credentials, of course, to ensure that everything is working fine with this custom user model, right? So what I'm going to do is I'm going to minimize this. So the detail is user1 and password1. Okay, the simple credentials, user1, password1. So what I would do is I would come over here and I would try to get user node. I would say user1 and I would change this to password1. Okay, you can keep any credentials that you want. I'll send this. You can see response 200. Okay, if I make this password11, this is incorrect and I get an error saying unauthorized. Now same goes for creating the nodes as well. So I can say user1 and I can say password1. Okay, if I say send over here, you can see that the node is created, and the same goes with incorrect password. It won't work. 401 unauthorized. Okay, so this is indeed working absolutely fine. As you can see, we are making use of Spring Security over here, and we have been able to authenticate users. All right, and yes, everything is being done with the help of custom user model, and even we have created our custom roles. So tomorrow, if you want to add a new role, you can add a new entry into this table over here, and a new role will be created. Okay, and you can have the logic set for that particular user. Okay, so I hope you have been able to follow along. Okay, and you have understood as to how things are working so far. Okay, so I hope this is valuable, and I hope you enjoyed this. So I just wanted to highlight the behind the scenes of how the application would function. Okay, so this is the diagram of the entire flow, and you'll see the changes would happen here at the bottom left. So the request flows in a normal way, like user submits the login request. It is intercepted by the filter chain. It is intercepted by username password authentication filter. This is a filter, and this filter would create the username password authentication token, which is a type of authentication object, right? And then it would be delegated to the manager. Now manager would be responsible for assembling the provider, and the appropriate provider would be chosen. Okay, so over here, DAO authentication provider would be coming into picture, and it would call user details service. Now here the user details service is, we have an implementation of the same, right? So what we have done is in our code, if you see over here, okay, here we have a user details service implementation, which is of type user details service, right? So object of this would be of type user details service, right? And here we have the logic as to how the user details are to be loaded. And this is exactly being shown over here. Okay, so find by username is being used over here. You can see find by username is being used, and using this, the user is fetched from the user repository, and this repository is talking to MySQL database that we have within our application, right? So this is how the entire flow would work, and our custom definitions would come into picture over here, because we have connected these definitions with Spring Security, right? And we have done this with the help of this user details service implementation, as to we have defined how to load username. Okay, and we are also mapping this username into user details object, which is of inbuilt type, right? So you can see it's coming from the core package. So we are mapping this user to user details, and that is how Spring Security is being able to work with our custom implementation. And that is what is being depicted over here. You can see user details service, and find by username is being made over here. So this is user details service implementation would be called over here, which is of type user details service, right? since we are implementing UserDetailsService interface. And load by username is what we have implemented. And this entire process will work and the details would be provided to Spring Security. So this is the entire flow as to how it will work with the help of custom definitions that we have in place. So I hope this is clear and I hope you have been able to follow along. So now it's time that we get started to talk about role-based authorization. So let's talk about what role-based authorization is first of all. So it's a method of restricting access to your application resources based on the roles assigned to your users. So in a system, your users is going to have a sort of role assigned to them and they will map to the permission, and these permissions will define what they can perform. So basically what sort of operations they are not allowed to do. These all things are assigned or mapped to a particular role. And based on this, you decide as to who has the authorization to do a particular thing or not. Okay. And this approach simplifies the management of user permissions and make it easier to enforce security related policies. Let me give you an example. So let us say we have a online banking system and there are different roles. So we'll talk about 3 different roles and what they are allowed to do. So the first role we have is a customer. Okay. Now a customer role is that he can view account balance, can transfer money, can pay bills and so on. But his permissions are limited to accessing personal account details and performing transactions. So these are his permissions. He cannot do anything beyond this. Then we have the next role, which is of a teller. Now, a teller will manage the customer accounts. He can view transaction history. He can even approve loans, and his permission is restricted to accessing any customer information. He can even modify the accounts and he can approve the transactions. Then we have an admin who sits above all. An admin can create or delete user accounts, manage rules, oversee the entire system operations. And the permissions this person is going to have is full system access along with user and role management. So if you take a look at this banking system, different users have roles assigned to them. And based on what role is assigned to them, they can do some actions into the system. If they try to go beyond what their role has to offer, they are going to see errors and system is not going to allow this to happen. Okay. So this is an example of online banking system. Now let us talk about the importance of role-based authorization. So number one importance that we should talk about is security, of course. So this ensures that only authorized users can access sensitive information or perform certain actions. Manageability. So it simplifies the administration of user permissions by assigning roles rather than individual permissions, right? So for example, if there are 10 users and if you want 2 people to be admin, rather than checking if a particular person is trying to do a specific stuff and validating that on the fly, what you can do is you can simply assign the role to that person and system takes care of it. So tomorrow, if someone new joins in and if we have a third admin, you just have to assign a role to that third person and everything is taken care of, right? Scalability. So this is easily scalable. Like whenever number of user grows, like I said, new users can be assigned existing roles without redefining the permissions. Okay. So having roles is a scalable, secure and manageable approach. Now it is also flexible because dynamic permissions can be created, assigned based on organizational needs, and they can be removed as well. All right. Now, since we have understood what role-based authorization is, let's talk about how things are going to work in our application. Now, you can see over here a list of APIs that we are going to need along with the endpoints and the other details that we'll see. Okay. Now, here we need a API, first of all, which is a GET request. And this API will allow us to get all the users in the system. Okay. And the parameters that this API needs is none. And the response is the list of user objects and the status code of 200. Okay. Now, all these APIs, that I'm talking about is going to be admin actions. Okay. So what the idea is, the admin should only be allowed to do certain actions, right? So here, this endpoint of getting all the users, a random user shouldn't be able to see what are the users exist in the system, right? Only the admin should be able to see. So these APIs will have a restricted admin access in our app. So get users is one such endpoint where the admin can see the list of all the users in the application. We have update role, wherein you can update the user's role. So you can pass in the user ID as a parameter and the role name. And depending on if there is a new role, the role against this particular user ID will be updated into the system. So if you want to perform any role update, you can make use of this API. It's a put request and you get response as HTTP 200, which is a status code and a success message. Then you have a get API where you can get a user by an ID. All right. So you have to pass user ID as the request parameter, okay, in the URL as a path variable, and then that is accepted by the method, and you get the output, which is the UserDT object. Okay. So these are the admin actions that we wish to define in our applications. Now, like I said, of course, these actions should only be enabled for admin and not for anyone else. So normal user should not be able to see the list of all the users. Neither he should be able to access any user information with the help of ID. So these are all restricted APIs, and they are restricted only to users who have admin assigned as their role. All right. I hope this is making sense as to what we are trying to do. All right. So yeah, these are the APIs that we are going to need, and going forward, we are going to build this. Let's talk about the inbuilt classes and interfaces for authorization in Spring Security. Now, Spring Security provides a couple of inbuilt classes and interfaces, I should say, that will help you manage your authorization and roles within an application. So this is the hierarchy that you need to understand. So you have granted authority, it's an interface, and you have simple granted authority, which is an implementation or a class, I should say, of granted authority. Now, what is granted authority? So granted authority, like I said, it's an interface, and this is typically used to define user roles. And simple granted authority represents a role or an authority that has been granted to a user. Okay. So they both have their own structure, the list of methods. Okay. And since a simple granted authority is implementing granted authority, it will be implementing the methods that exist in granted authority. Okay. So let me head over to our project here. And if you press shift 2 times, and if you say granted, or let me say simple granted authority. Okay. So if you click over here, this is what simple granted authority class is, and it is implementing granted authority. Okay. So you can see this is an interface here. All right. And you can see represents an authority that has been granted to an authentication object. Okay. And if you scroll down, you can see granted authority. If the granted authority can be represented as string, and if that string is sufficient, okay, then you can see here, you can get the authority, and you're getting string over here. Okay. So if it's a string, it will be represented over here. But if it's not, then you'll get null over here. But normally, you get string as a response. All right. And yeah, these are some additional details. It extends serializable. And if you come over here to simple granted authority, okay, here you can see you have the implementation. Okay. And here you'll have all the code around how roles are being managed. Now here you can see the implementation of get authority, where it is returning the role from here. Okay. This role is being returned, and you have some additional implementation like equals hashcode and toString, which is fine. Okay. But yeah, these are the two, I should say one class and one interface that you should be aware. They are inbuilt, and we as developers, we just have to make use of them. Okay. So I hope you're clear about the two components, like the classes and interfaces that exist to support authorization in Spring Security. So now it's time that we talk as to how we are making use of simple granted authority and granted authority in our code base. So here, if you see, we are making use of a role model. Okay, and this model is responsible for representing a single role into the database within our application. And you can see over here, we have role ID, role name. Okay, it has a length, and we have a mapping of role with users, because every user is going to have a role associated with it, and one role is going to be associated with multiple users. So this is a mapping that we have created, and within users.java, we have a mapping with the role as well over here. All right. Now talking about authorities over here, if you go to user details implementation, we are making use of granted authority over here when we are building the user details implementation object. So here you can see in this build method, which is a static method, we are making use of simple granted authority and assigning the list of authority to the user detail implementation class. And if you go over here, you can see how this is being used over here. Okay, so it's being used over here and it is being assigned to authorities, which is of type granted authority. So we are absolutely making use of these two classes in our code, and this enables Spring Security, I should say, to identify the roles that user has in your application. And this is a way in which you can make use of custom roles that you create with the help of a role model. Also, what we are doing is in securityconfig.java, here if you scroll down, we are creating the users and the roles. And we are first creating the roles over here, and we are making use of the role model over here. Okay, so this is one way to create roles in your application which persist inside the database. This is one way. Another way would be like to make use of queries. Okay, so here you can see few queries, right? So here there are insert statements. So I can directly insert into roles, and I can insert role name, user admin, and I can insert users as well this way, where the role is being mapped to a role ID. You can see. Okay, so this is another way of doing the same thing, where with the help of queries you are setting things up. Okay, and this won't be deleted. The reason for this is because you have set. So if you go to application properties here, you have the schema management, which is TDL auto property for Hibernate, selected to update. So update means it will just update and won't delete anything. Okay, so if you are directly inserting into a database, it won't impact because your schema is intact and it's not being deleted or dropped at any time. Okay, so either you create roles from code or you may create it via insert queries manually like this using SQL. Okay, so yeah, these are different approaches of doing the same thing, and I hope you have been able to follow along. So now it's time that we begin setting up the admin controller and all the related functionality that will help our endpoints function in the right way. So the endpoints we are going to need are these endpoints, and these are the endpoints that are only accessible by the user with the role admin, because these are all admin actions like getting all the users. So calling this endpoint, you would get the list of all the users and their information. Updating roles of any user, you pass in the user ID and the new role name and it gets updated. Getting any specific user information detail. So as you can see, it's all the admin related functionality. Okay, so first we'll build the functionality. So what I will do is I have Notepad open over here with all the code in Spring Boot that is needed over here. So I have the admin controller. Okay, and you can see the URL to which this controller maps. I have service over here. This is a service implementation. I have the service interface, and I have the user information. Okay, and this is going to be a part of the response. So what I'm going to do is I'm going to start moving files one by one. So I'll copy this admin controller first. I'll come over here, and within controller I'll paste this. So we have the controller added. Of course, we are going to see red marks like user service and all, because these classes don't exist yet, but we'll start moving everything. So this is user service implementation here. So this will come in the services over here. Okay. And then I have admin service interface. So this is just the interface. And here under services, I'll paste this. Okay. In the end, we have the DTO. Okay. This is how our user is being represented in the response. So what I will do is I have created a package over here. So you can come to com secure notes and you can add a new package here. You can call that package as DTOs. So I have it created already. Okay. So here come and here say DTOs. This is how you will create a package. Okay. So this package is created and you can paste the code over here. And once you've done this, you'll see all the errors disappear and everything is looking good. Now let us go through this code and let us understand what is happening right now. Okay. So first thing, we have the list of users. Okay. So this is the endpoint. So first thing you need to understand is we are making use of request mapping and REST controller over here. REST controller tells Spring Boot that, hey, this is the controller, and request mapping tells like all the requests that is coming onto this URL is being addressed or handled by this particular controller. And within this controller, we have individual mappings like get user, update role. So get users is going to simply return us the list of all the users. Okay, you can see over here. Okay, and it is calling user service.get all users. We'll take a look at this method shortly. And you get this as in the form of response entity, and you're getting the list of user. Now, which user is this? This is the inbuilt custom user model that we have created. You can even pass in the user DT over here if you want to decouple the presentation and the database layer. Okay, you can do that as well. I'm making use of user over here, and if you head over to get all users over here within service implementation, if you scroll down, get all user is simply returning the user repository.find all. So all the users, it's simply returning. Now, if you scroll down, update role. So this simply updates the role with the new role that you have passed in. So it takes user ID as a request parameter and role name. So you can see over here, what is happening is we are saying update user role. And if you go to this particular method here, update user role, we are just taking this user ID. We are getting this user. You can see over here, we're getting this user in this way. Okay. Once we have the user, we are getting the role of the user, current role. We are getting the role object. Okay. And then we are setting the role over here. We are updating the role in a way. And then we are saving the user using the repository. So this app role is the enum, which is representing a single role in our application. And then we have this role model of which we are creating an object to get the role details. Okay. So we are performing this operation and we are updating the user. Now, if you come over here, getting a single user detail. So this is also straightforward, wherein we are just passing user ID in the form of path variable and we are getting the user data. And we are returning this in the form of DTO. Okay. Now, if you come to implementation, this is the implementation of getting the user detail by ID. It's pretty straightforward. You can see we are getting the user, okay, from the user repository. We are saying find by ID. And then we are converting this user into a DTO. And I have a method over here, which is mapping the user to user DTO. Okay, this is also done. Pretty straightforward and pretty simple implementation over here. Of course, I have the service interface here, which is making sure that the implementation class, which implements this user service, has overridden all the methods. Okay. And then I have user DTO, of course. So pretty straightforward implementation. And what I can do is I'll run this code right now. Okay. And let us see if we get any sort of errors over here. So we don't get any sort of errors. Everything is working good. So our application is running flawlessly, and it's time that we test all the endpoints into Postman. Okay, so what we need to do is we need to query these endpoint or send a request over here. So I'm going to switch over to Postman and I'm going to organize things a little bit. So now these all endpoints we had for notes. So what I'm going to do is I'll add a folder over here. Okay, I'll call this folder as notes and I'll move all these endpoints into notes. Okay, now here I'll add another folder. I'll call this folder as admin. Okay, now this will tell me that all the admin related, like whatever request I'm triggering to the admin controller will come under this folder. So this way I'm organizing all my APIs. Okay, now to create a request, you can say add a request here and you can fill in all the details here manually. Okay, this is one way of doing things. You can take a look at the controller and trigger and enter all the details here manually. But another way is by making use of JSON over here. Okay, so what I did is I spent some time creating this JSON over here so that you don't have to spend time creating requests in Postman manually. Okay, so what I will do is I'll copy this entire JSON. I'll show you how the magic works. I'll copy this entire JSON. I'll come over here. Here you can see this import button, right? I'll say import. Now here you can paste whatever we just copied. So I'll simply paste it over here. And you can see import complete for 3 requests over here within admin API. Okay, so I'll say dismiss and there are no issues as such. I'll say dismiss. Here under admin API, if you open this, you have 3 requests being created. You can see these requests are auto created, but these are created inside a separate collection, I would say. What I would do is I would simply select all and I would move this under admin here. Okay, and this new request that I had created, I'll simply delete this. Okay, and I'll delete this admin API then. Okay, you can delete this. This is not needed. Okay, so this was created during import and we deleted admin API. So here now, if you see all these 3 requests, you can see this is the request for getting all the users with the relevant headers, update user role with the updated parameters, you can see, and headers as well, and a get request to get a user. Okay, so this makes life much more simple for you all. You don't have to manually type in all the URLs and set this up in Postman. All right, so now let's test all the endpoints. So first I'll try to get all the users. Okay, we are getting 401 unauthorized. Interesting. We need to give authorization. So I'll say basic auth and I'll enter user 1 and password 1. Okay, I'll say send. You can see all the users. So we have 2 users, one with user ID 2 and username admin. And this is a user with user ID 1 and user name as user 1. Okay, there are other details like credentials expiry, account expiry date, and all of that which are being default set over here. You're seeing that as well. Okay, since there is no 2-factor authentication enabled, there is no 2-factor secret as well. So that is null. All right, so you can see the details here and this API is working perfectly fine. So I'll just save this. Update user role. Okay, now this will also need authentication. So I'll say basic auth. All right. And what we are doing is we are trying to update the user. So user with ID 1 with role admin. Okay, so this role has to be role underscore admin. Okay, because this is how the role is being identified into our application. So if you come over here and if you go to models and app role, here you can see role admin. This is how role is being represented. So you'll have to say role underscore admin over here. Okay, so the role of this user right now with user ID 1, if you see, okay, we are not showing the role over here, but the role of this user is 1. Okay, so role information is not being passed in this. Okay, but if you go to get user by ID over here, and if you see the code, so user DTO has the role information. You can see user DTO, and this is being used in this API, okay, where we are getting the individual user information. So what I can do over here is if you go to get user by ID and if you enter the auth credentials over here, basic auth, and everything else is fine. If you trigger this API, you'll see that role is being set over here. You can see role user. Okay, so user ID 1 is having role as user. If you say user ID 2, he's having role as role admin. Okay, so what we will do is we'll update the role of user ID 1 to that of admin. Okay, so what I'll do is here in this update API, in the params, I'll say user ID 1 and role is role underscore admin. Okay, I'll say send. You should see user role updated. And if you go and here we had role user early on. If I try to fetch this again, you should see role is now admin. Okay, so we are able to update the role successfully. This is working absolutely fine. I'll change this back to user. Okay, and I'll say it's updated. You can see, and here now it's admin. If you trigger it again, it will be role user. Okay, so the APIs are working perfectly fine. There are no issues as such. Whatever we wanted to create, we have been able to successfully create it. Okay, just make sure that you're updating this role name to role underscore whatever you want to. Okay, and it matches the one that you have defined in app role.java. Okay, so I hope you have been able to follow along, and I hope this was useful. So we have our APIs working over here. We are able to get all the users, update the user role, and get the user ID as well. But there is one small problem. We are able to do this with the help of the user credentials. Now this user is having the role of user and not the admin. But these are admin APIs, right? This is coming in from the admin controller, which only admin should be allowed to access. So this is one big problem we are having right now in our application, where these APIs or endpoints can be accessed by any user who exists in this system. There is no sort of authorization that is implemented right now. And the solution to this is to add a sort of restriction which will enable only authorized individuals to access and perform admin related actions. The solution to this is to implement a sort of authorization which will only allow the users or a specific set of users to perform admin related actions. Okay. Now what we are going to do is we need some sort of restrictions where the person with only role underscore admin should be able to access these three APIs. And there are different methods or techniques, I should say, using which you can do this restriction. Okay. So let me talk about the different techniques that exist whenever you want to restrict actions based on roles. The number one technique that exists is URL based restrictions. And the other technique we have is method level based security, or you can restrict things based on methods that the person is trying to access. Okay. So we are going to discuss these two techniques in a hands-on way very briefly. So let us talk about how can you manage access and restrictions with the help of annotations in Spring Boot with the help of Spring Security. Now, managing access with annotations is also what is known as method level security, because you use annotations with methods to secure them in your services or controllers. All right. So Spring Security has inbuilt annotations. Okay, it provides us with some annotations to secure our methods and our services or even controllers. Okay, so let's talk about what these annotations are. So you can see first annotation we have is pre-authorized. Then we have secured. We have annotation like rules allowed, post-authorize, pre-filter and post-filter. Now, depending on what you want to do, you will pick the appropriate annotation, but this is a list of annotation that exists. Of course, we'll be diving deep into each one of them, but for now, this is the list. And here is an example of making use of the one annotation, which is pre-authorize. Okay. So pre-authorize, like the name says, it evaluates the role over here in this example before invoking this method. So before this method, which is pre, it is checking if the request has this role admin. And if it has, only then it will be allowed to perform this admin task. Okay. And you can see the import statement here at the top. Okay. It is coming in from the Spring Security, in fact. Okay. and this is inbuilt. All right. So this is an introduction to what annotations exist in Spring Security. So let us dive a bit deep into method level security. So method level security in Spring Security allows you to apply security constraints directly on your methods. So whoever is invoking the method, okay, the context is checked for the role that exists in that request, and based on that the flag is given whether the request should be proceeded or it should be stopped over there itself. All right, so that's what method level security is, and there are a few annotations that exist in Spring Security. These are provided to us, these are inbuilt and provided to us within the framework itself. Okay, now let us take a look at each annotation over here, like pre-authorized, secure, roles allowed, everything, and understand how you can make use of this with the help of examples. First, we'll talk about pre-authorize. So what is pre-authorize? Pre-authorize annotation checks the given expression before entering the method. So you can see, you can make out with the name pre-authorize. Okay, so before entering the method, it checks, and the given expression can be a role check as well. Okay, and it is very powerful, and it also supports Spring expression language. If you are aware of it and if you know how to use it, you can make use of Spring expression language inside this annotation. Okay, now here is an example. We are making use of pre-authorize over here. Okay, so you can see there are three methods, like delete document, then you have get document, and you have update document, and we are in the service class. As you can see over here, we have service annotation. Okay, now delete document is checking using pre-authorize annotation. It has role, and the role name is admin over here. Okay, so only users with admin role can delete the documents. Here, if you see, we are having role based access. Okay, so this delete document is admin only. Here it is role based. So both user and admin roles can access the documents, right? So you're trying to get the document, has role user or has role admin. So any of the role would work, but if this role exists, only then the request will go forward and this method will be allowed for execution. You can see over here, you can even do ownership checks over here. So you are checking if document.owner is equal to authentication.name. Authentication is nothing but the authentication object. So whatever name exists in the authentication should match the document owner. So here what it means is only users can update their own documents. Like I cannot update someone else's document because this check would fail then, right? So you can see these are three different methods with pre-authorize being used in three different ways. And this gives you a clear picture of how pre-authorize can be used when you are willing to secure your methods within your Spring Security project. So I hope this is clear as to how you can make use of pre-authorized. Then we have the secured annotation. Now, what is secured annotation? So secured annotation is a simpler alternative to pre-authorize, and it allows you to specify rules directly. Now, let me explain this to you with the help of an example so that you have a clear picture. So you can see this is secured annotation in action, where you have create account and get account method inside a service class. So you have a service class over here, service annotation. You have create account and get account. Okay. Now this account service. Here what this means is in order to access this method, the role can be user role or role admin. Okay. So this is allowing role based access for these two roles, and this is only admin only action. Okay. I hope this is making sense. You can see how this is a simpler alternative to pre-authorize annotation. Then you have roles allowed. What is roles allowed annotation? So this is a part of JSR 250 and it's similar to secured annotation. It specifies roles allowed to invoke the method. All right. Let us see this in action. So here you can see this is order service class. We are having the service annotation here, and you can see roles allowed over here. We are having two methods over here, which is process order and get order. So in order to process the order, only users with the role manager can process the orders, right? And users with both role user and role manager can get the order. All right. I hope this is making sense over here as to how you can make use of roles allowed. You have post authorize. Now post authorize annotation checks the given expression after a method has been invoked. So like we have pre-authorize, we have post authorize. After the method is done executing, the expression is evaluated, and it is useful for filtering the return objects based on security constraints, right? You must be wondering, why would you want to evaluate something after the method is executed? So it's useful for filtering the return objects based on any sort of security constraints that you might have. So you can take a look over here at an example. Okay, now in this example, if you see, we have getReport method inside a service class, and this is returning the report over here. Now initially we have access to report ID. Okay, so we cannot make a check before executing this method, right? So let's say you want to allow users to retrieve only their report and not someone else's, right? In that case, you would need access to owner over here, right? Where is owner? Owner is coming in from report, right? So report will be available only after the method is done executing, right? And in that particular case, you need to make use of post authorize because you cannot identify the owner with the help of report ID. You need the entire report object to get the owner. So in that case, you will make use of post authorize because after execution, you will see who is the owner and whether it matches the person who is authenticated right now. And if it does not matches, you will reject. You won't allow going forward. Okay, so that is how this works post authorize, and I hope this is making sense. Then you have pre-filter and post-filter. Now what is these annotations? So pre-filter and post-filter annotations filter collections or arrays passed as method arguments or returned by the method. Okay, so they are useful in both the scenarios. And let me give you an example for the same. So let us say you have an example called message service, right? And this is a service class. Let's say you have a method over here which is allowing users to send the messages. Okay, so what will pre-filter do is only messages owned by the users are processed in the send messages, right? So if the message is being owned by the user, you can see filter object.owner is equal to authentication.name. So if these are the owner messages, only then it will be processed. Okay. Similarly, if you take a look at the post filter, only messages owned by the users are returned in get message. So when returning the messages, it will check if the owner of the message is equal to the authentication name. So it will return only that user's messages and not someone else's. So I hope this is making sense. These are a few annotations. Okay, I would also like to talk about a few scenarios in which you would make use of these annotations, because normally students are clueless as to there are 5 annotations or 10 annotations, which one should I use when. So I have a list of scenarios over here. Okay, so let's say you have a scenario wherein you want to perform only admin only actions. Okay, so which means that method should only be accessible to administrators, and this can be secured using pre-authorized or secured annotation with the admin role. Okay, so if this is a requirement, you can make use of pre-authorized or secured annotation. If you have a scenario wherein you want to implement role-based access controls, like for example, methods should be accessible by multiple roles, and if you want to implement this, you can define this using pre-authorized with OR conditions, or you can make use of secured with the help of multiple roles. Okay, you can implement both ways. Then let's say you have a scenario wherein you want to implement ownership and contextual based access. Okay, so in that particular case, let's say you have methods that require checks on ownership or contextual conditions. So you can make use of pre-authorized with some expression language. Okay, and you can enforce these rules there. All right. Let's say you want to implement post invocation security. So let's say a method is returning some data and you need to implement some security checks as to verify that the data is going only to authorized person. Then in that case, you can make use of post authorize to enforce the access control on the returned object. Filtering collections. So let's say if you have methods that are dealing with collections of object and you want to filter those collections. So you can make use of pre-filter and post-filter and write your own rules as to how you want to filter them. All right. So I hope this is useful, and I hope you have a Hawkeye view, a really good view of method level security in Spring Security. So you can see how we have access to inbuilt powerful annotations that enable us to do a lot of things with this wonderful framework. So I hope you have been able to follow along, and I hope this was useful. So let us now enable method level security into our application. So what I'm going to do is I am going to close all the tabs. I'm going to switch over to our security configuration. Okay, this is a file that we need. All right. Now over here, what I'm going to do is here, first we need to enable method level security. Okay, so you cannot directly go into the controller and service classes and start using the annotations. Of course, you can do that. You can make use of annotations over here, but they won't work unless you tell Spring Security explicitly that I want to enable method level security in my project. So you need to first enable that in the configuration. How would you enable that? You would add a annotation to your configuration class, and you need to add this at the top here. You can say enable, and you can see this annotation over here, enable method security. So this is coming in from the security framework. Okay, and you can see over here, this is added. All right. Now, this also comes with a few parameters. So I'll paste some code over here. You can see these are few parameters that you should know about. Okay, so I'll just make this in a single view so that you don't have to scroll and you can see everything on a single screen. So here you can see enable method security. You can use it without the parameter as well, but there are a few parameters that I want to talk about. So the first parameter is pre-post enabled, and I've set the value to true. What this means is this enables Spring Security pre-post annotations like pre-authorize and post-authorize. Okay, so with this, you're saying you are enabling those annotations. Secured enable will enable the @secured annotation. And JSR 250 enabled will enable roles allowed annotations in your project. Okay, so these are few parameters that you should be aware of. Now, what you can do is, in order to restrict the endpoints, what you can do is come over to the control over here. Okay, and let us try to restrict this first endpoint, which is get users, and I'll say pre-authorize over here. Okay, so we are making use of this annotation pre-authorize. And then I can specify the role part as to which role I want to allow access to. I can say over here has role. Okay, and here inside, I would say two inverted commas, and here I would say role underscore admin. So this is the name of the role that we have in our application. Okay, so I've added this annotation at the top just before the get all users. Okay. And let me rerun and let us see if we are able to get this to work. So ideally, what should happen is users with this role should only be able to access this endpoint, right? So we don't get any error. It's working perfectly fine. If I switch over to Postman, okay, let me come over here to get all users. Now here I'm logged in with user. Okay, so this user has the role of user and not the admin. So let me try accessing this. So you can see I am getting an error, and the error that I'm getting is 403 forbidden, right? Which means that I'm authorized, but it's not allowing me. Okay, I'm trying to access something that I'm not allowed to access. And why did that happen? Because we added that annotation. Okay, still you will be able to access the get user by ID using the same credentials. So this would work. But the moment you update the annotation over here, okay, so if I copy this and if I take the annotation here and if I rerun the application, let me rerun. So it was just working right now. Now, after rerunning the application, if you come over here, if I try to send the request again, you see it's forbidden. And now if I enter my admin credentials, like it's admin and it's admin pass over here. If I say send, you can see it's working with admin credentials because this user has the admin role. Okay. So I hope this is making sense as to how you can make use of method level annotations. So this is really important concept because this is used in a lot of Spring Boot projects where Spring Security is integrated. Okay, so you saw the usage of this annotation as to how you can use it, but I want to touch upon one more thing as to where all can you use this annotation. Right now I've used it in controller. Okay, what you can do is you can remove it from here. Okay, or I'll just comment this. Okay, so I'll just comment this here. You can comment this here. Now you can add this annotation at the controller level or the class level as well. So if I add it at the class level, all the endpoints within this particular controller will have to have this particular role. Okay, so whoever is accessing need to have this role and they all would be restricted. Okay, so after running, if I come over here, if I try to access it again with admin credentials, it is working. But if I say user and password 1 and user 1, if I send, you can see it's forbidden. Okay, and all the endpoints will be forbidden, even the update one. So if I try to update this, you can see it's forbidden because in authorization, I'm trying to access it using user 1. Okay, so you can make use of it at the method level. You can make use of it at the controller level as well. And also, if I comment this, you can make use of at the service level as well. So if I go to, let's say, the service implementation of this. Okay, so if I head over to user service implementation, here, if I say get all users, I want to pre-authorize this one. I'll just have to import this and I'm sorted. I've disabled it from everywhere. Like in the admin controller, I've disabled it everywhere, right? Even at the class level and the method level. Now, since I've added it at, and I've added it in which method? I've added it in get all users method, right? So if I come over here to get all users, if I try to get all users using user credentials, it will still show me forbidden. Okay, so this is working fine because this is being rejected at the service layer, right? And for user, the request is rejected because he does not have the permissions to access this particular endpoint. Okay, so you can make use of pre-authorized, post-authorized, secured, roles allowed, all these annotations at the class as well as at the method levels. Okay, and I've just shown you examples as to how you can make use of them. All right. Also, remember, you need to enable method level security. So many people or many students ask questions that, hey, method level security is not working. So the answer is, have you enabled? Can you check that? Okay. So yeah, just be sure about this as well. Okay. So this is the latest annotation in latest Spring Security Framework. Earlier they had some other annotation, but this is now the updated one. Okay. So I hope you have been able to follow along and I hope this was useful. So let's talk about URL-based restrictions with Spring Security. So Spring Security allows you as a developer to configure restrictions based on the URLs within your application. And you can define all of this in your security configuration. And let me quickly show you an example which will give you a complete overview of how this is done. So let us say you have this sample configuration and I'll explain you what this sample configuration does. So here at the top, you are seeing like these are all standard class definitions. This is the security filter chain and there's a filter chain bean. Okay, this is a bean that I'm creating. This is all standard. Let us talk about this part over here, wherein we are making use of something called as RequestMatchers. Now, what this line of code does is it is opening the access to all the endpoints under API/auth to everyone. Okay, so it's saying that API/auth is open to everyone. And this is most likely the authentication URL. So API/auth/signin/reset password/signup. So these endpoints should never require authentication. The reason is if anyone wants to sign into your application, okay, he is now signing in, right? So there is no, it should be a public page, right? It should not have any sort of authorization. Otherwise, no one will be able to log in because they need to authorize, they need to sign in, and they don't have the authorization yet. So it is normally public, and that is why you're making use of permit all over here. which is signaling that all the endpoints that start with this will be public. Then the next line you have over here is restricting the access of all the URLs that start with /admin to the users with admin role. Okay, that is what this code is doing over here. Okay, so anyone outside of admin role will not be able to access these URLs. And then you have the third configuration over here, or the third line that I'm talking about. This is again the URL which says /images, and this is again a public URL. It is open access to all image resources within your application. And then after this, you have any request authenticated, which means that any other request apart from these should be authenticated normally. Okay, so this is how you can manage custom authorizations based on URLs. Okay, and HTTP basic over here is enabling basic authentication. Okay, so I hope this is making sense. And because of URL based authorization, because of this feature, what happens is if your application has URLs organized, for example, all the admin related endpoints are on /admin URL, all the public endpoints are on /public URL. Okay, so in that case, what you can do is you can make use of security configuration, and you can just configure the security and the authorization based on the URLs. Okay, and what this helps is all the configurations will reside in a single security config file. It won't be scattered. So in case of annotations, if you're making use of annotations will be scattered across the files, right? But here, everything is in a single file, and you can tweak anything whenever you want to. Okay, so that's the beauty of this. So I hope URL based authorizations and URL based restrictions, whatever you call it, is clear to you all, and I hope you have a clarity as to how this works. So right now in our application, I will be demonstrating how you can enable URL based restrictions. Okay, so if I restart the application, I've disabled all the restrictions that I had early on. And if I run the app right now, the application is accessible to normal users. So if you try accessing with the help of the normal user credentials, you'll get the output. This should not happen. So we'll be restricting this endpoint. Okay, what we will do is I'll come to security config here, and here, so when we are saying request, and we are saying any request, so here I'll take this to a new line, and here I'll add one more line over here. I'll say dot, and here you can see the suggestion RequestMatchers. Okay, so this will allow us to match the endpoint. So I'll specify a pattern over here. I'll say /API. So let us take a look at the endpoint. It's /API/admin. Okay, so I'll say /API/admin over here. Okay, and I'll say /**. So all the endpoints that start with this should has role, and I'll say role_admin, something like this. Okay, so done. We have specified or made one line of change, and if I run this, let us see what the output is. So the application is up and running. Okay, we get an error. Let me see what the error is. So the error that we are getting is because we are making use of role_admin. Okay, we are not supposed to add role underscore, since role underscore is automatically prepended when using has any role. Okay, so I'll just remove role underscore. This is automatically prepended. The message was quite verbose. So I'll just restart the application now, and let us see if we get any issues or errors. Ideally we shouldn't. Okay, and you can see there are no issues as such. And earlier we were able to access this endpoint with the user credentials. If I try to access it now, you should see we get a forbidden message, and every endpoint will have a forbidden message. All right. So this is just one configuration that we did, and all the URLs are protected. And on the other side, if you try to access notes URL, they won't be protected. So if you try to get the notes, okay, so if I say basic auth, and if I try to get the notes, you can see this is working fine because this does not have that admin API/admin in the URL. Okay, so this is how this thing works, and I believe this is a really good hands-on example and gives you an insight as to how this you can get this to work. Okay, just remember this role underscore part which I missed, and here you can add more request matches. So you can say request matches, you can add more if you want, and if you want to permit anything like to any of the URL /public, let's say you have this endpoint /public, and in that case you can say .permit all, something like this. We don't have anything on public endpoint, but if you want to do this, you can say that anything on the public endpoint is public to everybody. All right, there is no authentication needed. All right, if you skip this, then it falls in this category, other endpoints. So anything except this falls in this category and it will be authenticated. All right, so I hope this is making sense. I'll just have this as an example written over here. I hope this is making sense, and I hope you have been able to follow along as to how you can make use of this. So for our application, we just need to have or keep this particular configuration. We don't need this configuration. We want to expose the public endpoint. This I just showed you as an example. So I'll get rid of this. Okay. And I'll also do some cleanup of the import statements over here. Okay, so we are set, and I don't think we need method level security as well. So I'll comment that out, and I'll also remove all the method level annotations that I had added, even at the controller level. I'll just get rid of them. Okay, and here, okay, I'll get rid of this from the service class. Okay, so one way is either you have this enabled over here this way. Okay, you have this, or you can comment this out and you can enable the method level security. Okay, and in the admin controller you can have the pre-authorized. So if I say control Z over here, this thing, you can enable this at the controller level itself. You don't need to add it at the individual method level. The reason is every code that the admin must do must start with this URL, and it has to be authorized over here. So this entire controller actually has to be authorized, right? So you can add it over here at the controller level, or you can add it at the config level using URL. It's up to you. Okay, but I'll just stick to this one. It does not matter. I'll just stick to the one using annotation for now. Well, there are two ways to implement authorization in your Spring Boot application with the help of Spring Security. First is you can implement authorization at the method level. Other way is with the help of security config file, and you will make use of request matches over there. Now, a question or something that people always ponder on, that which way should I use and which one is the best approach for my project? Should I learn both the mechanisms? Is it needed? So what I'm going to do is I'm going to break this down and I'm going to compare both these two approaches. I'm going to list down pros and cons and everything that I can. And then in the end, we'll take a look at few scenarios that will help us understand as to when you should use which approach. So first, let's talk about the differences between the two. So we'll talk about different things like the definition. So first thing is definition. So method level security uses annotations over here, as you can see, to secure individual methods. And the difference of request matches approaches, it configures security based on URL patterns in HTTP configuration. Okay, and this is where Spring Security config comes into picture, wherein this URL based configuration is done. All right, now this will be useful, like the URLs in your application are really organized. So if you know like this is existing at this endpoint and it can be done on the endpoint basis, then it's best to have the request matcher approach in that case. All right. If you talk about annotations, here you can see these are all the annotations that exist. You have pre-authorized, post-authorized, secured, roles allowed. And then you also have request matchers if you talk about request matchers approach. Okay. So what is RequestMatchers? RequestMatchers takes pattern as the parameter. Okay. It's a method. RequestMatcher is a method that takes pattern as the parameter, and it is used to specify security rules based on those patterns. If you talk about granularity, so if you compare these two basis granularity, method level security will offer you fine-grained control over individual methods, right? So you can go to individual methods and you can annotate them that I don't want this to be accessible by this person. So it's very fine-grained. However, that is not the case with RequestMatchers approach or URL based, because in that particular case, you are configuring URLs. Now you don't know which methods those URLs are touching upon, right? So that's the difference in terms of granularity. Now, location of configuration. So when you talk about method level security, the annotations can be on methods, classes, in services, or in controller layers, right? You can put it at different places. But when you talk about this URL based approach with the help of RequestMatchers, you can have a centralized security configuration file where you have all the authorization logic and all the authorization related configurations defined there, right? So this is a difference with respect to the location as to where you configure. Talking about flexibility, method level security is highly flexible. Okay, you can write complex expressions, you can make use of Spring expression language as well. But here, if you see on the other side, the URL based approach, this is very straightforward. Okay, there is no complexity involved. It's straightforward. You just specify the rules based on URLs, and the patterns that you specify will be matched against. Okay. Impact on business logic. So with respect to method level security, you can imagine like you are touching upon controllers, service layer. So this gets coupled with the business logic. However, if you are configuring URL based approach, the security related configuration is separate from the business logic. And that is really good. I'll tell you, if your project is huge, okay, and there are so many files in controllers, so many in service layer, then having a centralized configuration for security helps in long term. But if it's scattered, then in that case, you will have to touch upon the method level security. Complexity of management. So method level security can be verbose. Okay, it requires annotations everywhere. Now, it requires annotations everywhere, and that can be difficult to manage. So you might have annotations all over the code, a lot of annotations being used, and that might make your code look a bit more complex. But with respect to RequestMatchers, since we spoke about the decoupling from business logic, so security rules are decoupled and separate from business logic. So in that case, it's easier to manage all the rules in one configuration file at a single place. Anyone can make changes over there, and it's totally understood. Use case. Okay, so if you talk about use cases, when we talk about method level security, this is ideal for a detailed control and complex conditions. So if you want to do some sort of complex security measures that are not possible with URL based approach, then you should take help of method level security. But if you have a simple and maintainable URL in your application, you can make use of RequestMatcher approach. Okay. If you talk about examples, here are the different examples. Here you can see these are two annotations being used, and here you are making use of RequestMatchers. It is pretty straightforward as to what we are doing. We are allowing roles having admin, okay, admin in them. So this is URL based and this is annotation based. Now, what are few use cases that we could talk about? Okay, so one use case for method level is you can secure service methods accessed by various controllers. And so basically what happens is if you add the annotation in service layer itself, if that service layer is being accessed by many controllers, okay, that is applicable at all places then, right? Because it's centralized. And you can even add additional conditions like we spoke about. However, in case of RequestMatchers approach, it is totally URL based. So let us talk about pros and cons. Now, like you can guess, method level security provides a detailed access control. It can help you implement complex security logic, and it can secure your business logic layer. However, RequestMatcher approach or URL based approach provides centralized, clear URL based rules, and it's less intrusive to business logic. So I hope this difference is clear. And the cons for both would be like method level security requires annotations on each secured method. So you have to go find out every method and add annotations over there. Okay, it's tightly coupled with business logic. Whereas request matcher approach is less granular, like it offers based on URLs, right? So it will less granular. You are just configuring on the basis of URLs and you are not coupling it with the business logic, right? So that's one of the cons for request matcher approach. Now let us talk about different scenarios and in which scenario you will make use of what. Okay, so let's say if you have a scenario in your project where you want to take care of a fine grained control access, then you will go ahead with the method level security. And the reasoning for this is it provides detailed control over individual method. If you have complex security logic involved in your project, of course, method level security, because it allows you to make use of expression language. If you have a service level security that need to be added, then in that case, you'll again go ahead with method level security. Okay. However, if the requirement in your project is to have a clear URL based security, centralized security management, and if you want a simple and maintainable security configuration, then you'll go ahead with the URL based configuration or request matcher approach. Okay. And the reason is, of course, it's centralized, simple, easier to manage, and all of that. Okay. So I hope you have a good understanding of how these two things can be picked depending on the scenario in your project. Okay. So I hope you have a good view of what you would do in your project if you face a security related scenario. So I hope this was useful. And one more thing I want to talk about is combining approaches. Okay, so now there will be scenarios wherein you would also want to combine both the approaches, right? So let's say you might have a URL based configuration already in place in your application. And if there are certain methods that you want to secure, that is perfectly fine. You can combine both the approaches. Both can complement each other, both work with each other. There will be no hassles as such. Okay. So you can have URL based security in security config, and you can have method level as well using annotations if there are some secure methods that you want to add additional security on. Okay. So that is also possible. So it's perfectly fine to use both as well. So I hope this was useful and I hope you were able to follow along.